good morning, everybody. This is Vishnu on behalf of TSTSI, IIT Guwahati, and everybody here on the room. Please, we are very happy to welcome you to NCC STR Workshop 2023. It's a very bright, sunny morning here. It's a pleasure to welcome you all to this workshop. We have a packed agenda. Without delay, I would like to kick off the proceedings. Pamela is not here. On behalf of Pamela, welcome you all, and let's start the day. So this is workshop. Standards driven research is the key topic these days. It's a very important topic. It's what we should be looking at to pioneer Indian research towards global standards. Let's look at the proceedings, and we have very experienced chairs. My great friends are here. Arzadji is here, Dr. Arzad Alam Karani, IIT from IIT Bhilai, as well as Samar, another of my great colleagues. Samar is here from Intel. So we are in good hands. Let's look at what they are up to. Next slide, please. Yes, Professor Azad is the chair of TSDSI SGSS Working Group 2, Applications and Service Layer Standards. He's also into AIML. He's associate professor in IIT Bhilai. Broad areas he has been expertise in computer networks, queuing theory, queuing systems, wireless communications, and so on. Not only that, he is an industry expert as well with product design development, etc. So his master's and PhD from IIT Bangalore. I would like to welcome Professor Azad, and it's a great pleasure to have you here, sir. Next, we also have Samar. Can we go forward? Yes. So Dr. Samar Shailendra is a senior standards architect at Intel and lead standards delegate at India and 3GPP SA6 application, which is actually application enablement and critical communications applications. He is also visiting professor at IIIT Bangalore. Currently, he is co-chair of TSTSI Roadmap Committee and vice chair of TSTSI Study Group Networks. It's a great pleasure to have you here, Samar. Next, I would like to go forward. This is the program schedule. It's a very exciting program that we have here. I hope you all interact and please take advantage, profit from these experts who are here. And as well as please use the chat session if you are online. If you are in the room, just raise your hands and we can have an interactive session. So first, we will have the context setting about TSTSI, 3GPP, global standards. My colleague Pritam Bishnoi is here from TSTSI. After that, we have technical sessions going forward. There is technical session 1 and 2, 3, 4 onwards. We will come to that in a bit. These are all very exciting, very pioneering sessions which are here. For example, we have cyber physical systems, which is actually our topic. There is sustainable data driven society. There is another great interesting topic. A digital divide, that's a topic which is globally discussed these days. That is coming next. And we have tech session 4, which is ubiquitous intelligent mobile connected society, which are all having very experienced speakers from all around India as well as abroad. Finally, you will see me back with the overview of ITU. I would make a pitch to you to get involved in global standards ITU, and as well as with my colleague Madanji on 1M 2M. And at the end, we will have Professor Ajit Chaturvedi talking about conducting the Q&A and having concluding remarks. That's the deal for today. I hope you enjoy the sessions. And at this point, I would like to welcome Bishnoiji, Pritam Bishnoi, to the stage to set the context and get the ball rolling. Welcome, Vishnu.
Thank you. Sir. Respected delegates, good morning, and uh, I am thankful to you all the organizers who have given this opportunity to speak to set the context. I, on behalf of DGTSDSI and all the members of DGTSDSI, welcome to all the attendees and the participants who are on site and online for this conference. So, with this, I would go on the deck and the presentations. Next slide, Chandrakanta. So, with the presentations, what I would like to talk about the setting the context is basically the infrastructure which has been built on the Indian scenario. So, for the introductory part where Vishnuji is mentioned today that how the context setting for the today's seminar. So, we are going to set that particularly take the example of India, and in this, if you see in the center part, the DPI, that is digital public infrastructure, which has been developed in India. And in this, there are three fundamental pillars on which the Indian stack has been posed. First, we're talking about that it is the digital infrastructure is citizen centric, it is people oriented, and for this, the identity of the individual has been given in India through the Aadhaar. Second pillar is the we talk about as the payment. So the digital infrastructure which has been created in the form of UPI, particularly the BHIM application, where the bank account has been linked with PAN and Aadhaar and the mobile as a Jan Dhan Yojana, that is a second infrastructure with respect to the payment. Coming to the third part, all these transactions, there is going to be exchange of information, that is nothing but data, and therefore there is a requirement of data security, and that is the infrastructure which has been created in India is in the form of DigiLocker. So these are the three fundamental pillars of any digital infrastructure. And in this case, since this has been made the digital public infrastructure, particularly with the investment of the public funds by the government of India, and the amount, the colossal amount of efforts which has gone into in this, it covers 1.3 billion people, so which is nothing but the second largest population of the world. So see the size of the digital public infrastructure. Then coming to the area itself, it is the seventh largest country in the area in the world. So therefore, coming to the terrain itself, the kind of different terrain where has deserts, mountains, it has the Siachen glaciers. So therefore, covering from east to west, north to south in 3,000 odd kilometers plus. So the digital infrastructure which is required, connecting the unconnected people all over the country, requires colossal amount of effort. Now with this, if we compare the outcome, how this digital infrastructure is going to give us the operational dividend to all the citizens of the country. First, if we compare two systems, that is closed system and the open system. With the closed system, I would take the example of vending machine where you have limited choice. Let's say you have a vending machine of coffee and tea, so you can't have third thing. Either you have to decide, either you take coffee or you take tea. Whereas once you go to market which is open, you can have all the choice, you can have juice, you can have tea, coffee, you can have fruits, you can have lunch, dinner. So that is open system. So see the advantage of digital infrastructure in India, which has been made. It is based on the open networks. So this the advantage of digital infrastructure is that it gives opportunity to all the stakeholders, and at the same time it becomes more competitive. Then it gives you at lower price, and then there is a chance for innovations, and therefore there is a continuous improvement in the infrastructure. Now with this, if we see the outcome, that it gives the swift delivery of all the services provided both by the government as well as by the private sector. It is also looking after the inclusive growth. So if these are the advantages, so this becomes as a the standards which we must take it from our national stack as a India stack to the global standards. The themes of today's four sessions, which means that first and foremost thing, if we need to ensure that it succeeds, so therefore first and foremost thing that we must ensure ubiquitous connectivity. That means each and every citizen, all 130 million people should be connected. Each and every corner, nook and corner of the country, each and every city, each and every rural village area, irrespective of whether it is in hinterland or the border area, should be connected. So this is a very important. As of now, the data which is shown in the public domain, that 25% of the households are connected with the internet. Only 10% of the household are having the accessibility with respect to laptop, desktop, or the palm top. But the kind of infrastructure which is going to be created by the Bharat Net, wherein each and every panchayat, each and every rural area is going to be connected, and therefore we need to see that this ubiquitous connectivity will ensure connecting the unconnected people. Second, it is also making that it has to be given some kind of cognitive capability. That is how the intelligent networks, so that will make it more effective and efficient. Second, coming to the digital divide. The digital divide is there between the urban and the rural areas. The connectivity of the internet in the rural areas is basically, as of now, is 30 to 31%, whereas the accessibility or the availability of the internet penetration in the urban areas varies from 65 to 70%. This divide also needs to be bridged, and therefore we need to see how do we harness and leverage the technology to defeat the digital divide between the rural and the urban areas. We also need to see in the third session that the sustainable data driven society, that how do we sustain, we need to create an ecosystem so that it should be able to sustain itself, and all the stakeholders have a the decision making which is of ownership and participative. The fourth session, which is of the cyber physical system, is again a very important session, wherein we see that every physical domain has to be converted into a digital domain, and that gives us an additional advantage for the further the innovations and the coming to the standards, and overall development for the society is an important parameter. So with this, we find that the development of these global standards for digital public infrastructure ecosystem in India needs to be taken to the entire world, to the 6 billion population, and which in any case it has to be firstly starting from the India, that is 1.3 billion, and it is a Asia centric, rather digital centric society, where we need to move from India to the Asia and from Asia to the entire world. Next, Chandrakant, may I request you to change the next slide, please? So with this, setting the context, I will now cover about the overview of the TSDSI, and in that I will see that all these subjects are connected as shown on the view file. Next. Now, why are we going in for the standard driven research? Why standards are required? So all the advantage of the standards which we have discussed, that it is going to ensure the interoperability, it is going to ensure level playing field for each and every stakeholders. It is going to ensure the transparency, which will make the things more competitive. It will prevent the monopoly, it will prevent the proprietorship, and therefore availability of the best technology at the competitive rates will be the advantage to each and every citizen or each and every human being of this planet. Next. Now, there are various stages of the standardization wherein we talk about starting from the emerging from the idea to the adoption and implementation of the standards. So these are the stages which are being discussed, and these proposals are being processed at various level till the standards are evolved. Next. The paradigm shift from the consumer to the producer of technology is the role of standard driven research. So, therefore, if we see as on date also, most of the standards and the patents and the IPRs are based on the either the developed countries, particularly from the Europe and the US, and now from the last 5 to 10 years, the technology which is being now harnessed is much more by China, even which is overtaking the Western countries. So with that, we need to see that how we as India should be able to contribute. And if we are the fifth largest economy of the world and second largest in population, and if our contribution in the global standards is not proportionate to our capabilities in terms of size, in population, area, and economy, then I think there is a need for us to see as to why it is less than even 4%, which we should see how do we take baby steps to improve upon our contribution in the entire world. Next, coming to the TSDSI. Now, TSDSI is the youngest SDO or Student Development Organizations of the world. It came into being on 7th of January in 2014. This is the 8th year where the TSDSI has now completed its task. We need to see that how TSDSI has performed over these 7 to 8 years, and what are our expectations, where are we presently, how do we bridge this gap, and to reach where we would like to reach, what steps we need to take over these years. Our objective is, as I mentioned, that we need to ensure that there are 7 global SDOs, particularly with respect to 3GPP as a OP. How do we perform the better than others, and can we learn and imbibe best practices from other SDOs? Next, with respect to the TSDSI vision, as we mentioned that we would like to see that our percentage or contribution in the national standards and then taking them to the global standard increases exponentially over the years, and we should be in sync with the national digital communication policy of 2018, which has been made public. And there are 3 pillars of this, wherein is it talking about connecting India, that is through the BharatNet, and that is where one of the context we are talking about is that ubiquitous connectivity by connecting the unconnected people. Second, Propel India is basically to harness and leverage all the next generation technologies, whether be it 5G and beyond 5G, whether it's blockchain, AR, VR, or for that matter, cloud computing, quantum, all these next generation emerging technologies, how do we ensure in addition to AI and IoT? Coming to the third pillar, which is the data security, since the footprint on the internet is going to increase exponentially, and we will have larger area, or which is going to give again the threat or create vulnerabilities for the hackers, and therefore we need to see that all our applications, all our infrastructures are made secure, and at the same time they are made functional, they are available, they are accessible, and they are affordable. These 3 A's are very important in technology, that affordability, accessibility, and availability needs to be ensured. it has to be cheaper, and it has to be accessible even from the remote area, from any rural area, from any citizen. Next, coming to the various stages of the standardization, there are three stages. First stage we talk about as the pre-standardization stage, wherein the idea emerges and it is brought into the form of the NIP, which stands for new idea proposal, which is then brought to the TSDSI by the various members. It is being then discussed into the study groups, and there are two study groups. So the idea which is new item proposal which has been brought, then it is decided whether it should go to study group networks or should it go to study book systems and applications. Next, coming to the next stage of the standardization process. Next slide, Chandrakanta, next slide. We have discussed about the pre-standardization stage. Next, now during the standardization stage, once the NIP has been brought and it is being discussed by the technical study groups, and then it is then taken to the next stage of the standardization. Next slide, Chandrakanta. In the standardization stage, we find that the NIP which are being discussed by the study group, so their outcome is either, if it is study item, then the outcome will be the study report, and if it is going to the work item, then the outcome will be as a the draft standards, and then it will be taken and it will be discussed with all the individual members of the TSDSI in both the study groups, and once it has been approved, then the same is cleared and approved by the general body meeting, and then this becomes as the TSDSI standards. And once it is accepted, the unique number is given and uploaded on the TSDSI website, and then it is given to the TEC, Telecom Engineering Center, wherein it is again being discussed within the members, industry, academia, and all the stakeholders. And once it is accepted there, then it becomes as the national standard. Similarly, the contribution of the TSDSI, which also goes to the global SDOs in the form of whether 3GPP, whether 1M2M, or ITU-T and ITU-R, and those international standards are then they are transposed or adopted in by the TSDSI and then through the TEC as a national standard. Next, now, the coming to the post standardization stage, we find that once the standards has been accepted, then these are published, and we all know that after the standard is published, after that only the product development in the market which takes place. So it generally takes maybe 12 months to 18 months before the product development based on these standards is deployable and in the market to the public for the utilization. And till then it lives as a end of life, and this is how the ecosystem works. And from again we start with the either improvement in the same product or with the new product, depending upon the new item proposal, that is next NIP. Next slide, please. The technical activities, as I mentioned, there are two technical groups that study group networks, that is SGN, and the study group services and solutions, that is SGSS. And the various areas where both the study groups carry out the technical activities, as it has been mentioned. And in addition to the technical activities in these two study groups, there are various task forces also for open source global SDO strategy, and these are startup engagement, standard driven research. These are in addition to the technical activities which are being carried out by both the study groups. And now at present we have 61 individual members, that is IMs to 1 and 55 IMs to 3GPP. Next, now the proposed TSDSI roadmap, now it is under consideration, it is being discussed, and we find that how the emerging technologies which needs to be harnessed and how the standard driven research is going to address these issues which we already talked about. And these are the various technologies, whether it is artificial intelligence, whether it is blockchain, whether it is metaverse, and AR, VR, which I have mentioned earlier. And the first area is basically the 6G technologies on which we start working, and particularly the release 19 and release 20 presently, which is going to cover. And as we mentioned in the context, that we need to see that our all standards need to be citizen centric, public centric, and they need to see that how are we going to address those three pillars of human beings, payment schemes, and also the data privacy. Next, we have the partnerships and affiliations with various organizations, including the global SDOs, like in this case, it is 3GPP, 1M2M, and also we are the member of the global standard collaborations, that GSCs. There are certain partnerships which we have carried out, the memorandum of understandings, MOUs, where we have joint workshops for exchange of our knowledge, and we learn from each others, and we imbibe the whatever are the best practices from the other organizations. We do have regional cooperations like with India EU cooperations, and also the 5G multilateral MOUs. We participate in their workshops, seminars, either through online, that is remotely, and even through the physical presence, which may be sometimes in the hybrid mode. Next, the technical reports which have been published by the TSDSI over these 7 8 years, on various topics which are mentioned here, in 6G technologies and the IoTs. We have talked about 6 gigahertz spectrums for the IMT services in India, and also we are talking about studies on M2M communications use cases. And now latest which we are working is basically for broadband broadcast convergence, that is direct to mobiles, wherein we would like to see the how the mobile phones on the same spectrums can the digital TV can be brought, and how the congestion can be removed, wherein the broadcast broadband convergence using the spectrum of the broadcast can be used here. Next, the case study where the 5GI journey from the requirement to the standards is been discussed, that particularly as we know that there are three kind of the RIT technologies in the three different configurations, A, B, and C. Configuration A and B are more prevalent to the developed countries, whereas as I mentioned that the Indian context is different, and we cannot use those technologies without customizations to India, that may not serve our purpose, and therefore we need to see that how do we have our own standards, particularly it should meet Indian requirement. So with this, the configuration C which I am talking about, that is the low mobile and large coverage, which was where we wanted that 700 megahertz is the band which is going required for the Indian, particularly that the lower frequencies, that is sub gigahertz bands, give larger ranges. And since we are having 60 to 65% of our people in the rural areas, and therefore more important for them is connectivity rather than the bandwidth and the data transfer speed, and therefore going to higher frequencies will require certainly a larger number of repeater stations, which means larger capex, larger repeater station, and that may not become economically viable solution for India. Secondly, coming to the mobile connectivity as the speed, when we say it was catering for 120 to 500 kilometer per hour, that also is more relevant to the developed countries both in Europe and Western, where the connectivity by the public transport, even by the railways and the transport national highways, where this kind of speed is available. Whereas for 60 to 65% of people which are in rural areas, where the connectivity is single road, most of them are two wheelers, maybe cycles, so their connectivity speed may not be more than 3 to 30 kilometer per hour. And that is the second difference from the developed countries for us as India. Third, we talk about even for the the distance, this ISD distance. So there it may be even less, but particularly in our case, it has been estimated that a gram panchayat which covers 3 to 4 uh, villages is in the radius of 4 to 5 kilometers. So by 6 kilometer, if we get from the BTS, if we have the radius of 5 to 6 kilometer, we cover 80 to 85% population, maybe 90% population of rural areas, and that is why this configuration, the LMLC, was more relevant. Though Vishnu sir is aware what all efforts has gone, but it has taken more than 4 5 years now since this has been accepted in the 5G, in release 17 in 3GPP. This has become. Here I would like to bring out that in since I am from army, so what we think, and I served for 40 years, 4 decades, and I was dealing with the army communication, and we spend more time on the borders where there is hardly any connectivity. So we have our own connectivity, that is separate area of secrecy. But the point which I just wanted to make it here is that the technology which we get from the foreign technologies, from the in the form of import, most of our weapon systems and surveillance devices are from the ex import, either from the US, Europe, or from Russia. The technology they give is already end of life, which has reached there. They want to, that becomes their dead stock. They want to give that to us, that is one. And since it is proprietary, so they charge high price, that is two. They charge in dollar, that is three. Everyday dollar, rupees, we all understand. Four, it cannot be maintained, it life is already over. So we have become a permanent customer to fund them for their R&D and D and for their better technology. Now this cannot continue forever, and if continue, so one sentence I will just say: we feel anybody who controls technology will control the world. That is all. And how, what all goes into this, we would not like to discuss. So for that, if the entire IPRs, patents, and standards and contributions is from them and none from us, so then we will be dependent, and national security is giving in the hand of others. I don't know whether it is really worth. If yes, for how long? So with this, I feel that we must have our own standards, and 5GI is one of the example where we could do it. So with that percentage, 4% contribution, with all those parameters, I think is too less for us. Next slide, please. The work which is going on as the 6G, and now, so various meetings and the webinars and studies, and where we find that now, since we have more or less lost nothing, no contribution in 1G, I mean talking about 1980, no contribution in 2G, I am talking about 1990, no contribution in 3G, I am talking about 2000, no contribution in 4G LT, I am talking about 2010. I'm talking about every decade how we have not contributed anything. Now we are in 2020 and beyond, or 2022 or 23, very less contribution in 5G. So I feel now, I think we should not wait that in the 2030 or IMT 2030 and 6G, we should start working now so that we don't miss the bus or the opportunity. Next. The engagement with various verticular within the interministerial groups, I am talking about within the how are we interacting as a TSDSI with the financial sectors, with the fin technologies, with the ID RBT, as I already talked about the broadcast broadband conversation. So there is already work which is going on by Sankhya Lab, IIT Kanpur, and Prashar Bharati, and they have already made the chip. They have demonstrated. They wanted to inaugurate this on 26th January by the Prime Minister, but since they were not ready, whatever was shown to the Ministry of Information Broadcasting, it was not meeting the requirement more than 70-80%. this gap of 20% needs to be covered. So now we feel that by 15th August 2023, they should be able to complete that balance 20-30%, this convergence area, wherein they will be able to make sure that at least they will cover 4 or 5 metros starting from Delhi and Bombay. The future topics which we talked about on the 5G with respect to the railways, that is RDSOs and the JCS, Ministry of Defense, which I already spoken to you, that in the defense, most of the communications and other sensor technologies, including the drones and UAVs, are ex import. They are not indigenous. Now with Make in India policy and with the government assistance in the IDEX and various programs, some improvement has taken place. They have issued some 3 negative lists, and in each list, which contains more than 100 items, that these 300 plus items will not be procured ex import by the Indian Armed Forces. They will remain without these items till they are produced by Indian OEMs. So that is the decision which the Ministry of Defense or the Government of India has taken. So we feel that if we have all the interministerial groups, lot can be done, because technology is considered as a nervous system, and therefore it has an impact on each and every ministries, making them more efficient and effective. Next. With respect to the 3GPP, since 3GPP, TSDSI is one of the organizational partner, that is OP. There are total 7 OPs to the TSDSI, to the 3GPP, and in this we have 55 individual member 3GPP IMs, and they also participate in various meetings. In the 3GPP, there are 3 important verticals, that is the SA group, the CT, the core technology, and the RAN, radio access networks. These are the 3 study groups, and in each study group there are various sub study groups. Like in SA, there is SA1, SA2, SA3, SA4, SA5, SA6, and similarly in the CT1, CT3, CT4, CT5. So these are and the groups in there where we take our proposals. We have been attending these various meetings. So what we can talk about that, in these also 2 meetings which I attended in the Hungary, and one was in the Toulouse in France. We found that the participation from the other countries, particularly from China and Europe, and in any case the US, is much more compared to the Indian participants. In the last 2 meetings, what we have seen, like, I mean, now in this there is going to be a meeting in Rotterdam from 24th, that is from tomorrow, till 33rd of March, where the governing leadership elections are going to be there. So we find that there are total members are roughly 700. So if there are 700 plus members in 3GPP, so assume that each member has 1 vote. In We have 55, so from that we see that out of those 755 vote are there, but they have made the rules of eligibility of voting. So whether it is complex or not, but I feel that we have not been able to draw benefit from that. Out of these 55, only 18 members are eligible for the voting. So that is point number 1. Their rule is that if the voting is to be there in, let's say, meeting number 99, so somebody has to attend meeting 98 as well as meeting 97. So previous 2 meetings are supposed to attend, then only they will be made eligible to vote. So out of those 55, we have only 18. So here what I would see, that we are paying them, for the membership to 3GPP. Let's say whether X amount of whatever amount it is, so 55x rupees are being paid, and if only 18 are eligible, so balance 38, that amount, there is no return on investment of that value. That is one. Secondly, if we are not attending those meetings, so we are not learning. And if we are not learning, so we can't contribute. And if we can't contribute, therefore be no IPR. If there is no IPR, no patent, no standard, then we will be following whatever other people are. So we are supporting. So we will be always buyers, and we will be always users, and we will be paying for the products and services, and we will be paying for the membership also. This becomes a ecosystem which suits them. So we need to see that how do we break this ecosystem in this. So this is the 3GPP. 3GPP more work for any standard, any decision, because two important things which I understood. First and foremost thing, that it is a member driven organization. If there are 700 members, so it's a member driven organization. Second and key area is consensus based decision. Out of those 700, if 699 says yes and one says no, then it is no. So most of the decisions are not taken in the hall during actual meeting. They are taken during tea break in offline. Once they decide, then they come and then they support each other. They support each other where they feel that it is going to benefit commercially, and they have the control on the technology. So this is what I have learned. So my submission in through this seminar is that our participation should be maximum, learning should be maximum, then we should go to step 3, because to reach that stage it may take more than a year, 2 year, or maybe even 3 years, depending upon our uh, continuity, interest, and others. Next. Now, the coming to the cumulative, the metrics. So, what all, how many technical reports which have been published, how technically draft reports, which are the number of standards which have been published, both as a national standards or the TSDSI standards, and how over these 2014 onwards, once the TSDSI has came into being on 7th January, has increased its contribution, has increased its global projects, increased its memberships. So though it is increasing, but the pace with which we feel that it is not exploiting the India's full potential. There is a lot of scope for us to even do much better than this. Next. Organizing structure, there is a general body in which these are the chairs, vice chairs, and treasurers. The technical groups, as I already mentioned, both the study groups. We have talked about the governing councils in the secretariat. The DG is there, Ms. Mamila Kumar, and the technical activities and the operations and Marcom as shown on the view file. Next. The TSDI membership. So these are the various kind of sections and the ICT ecosystems which we have in this. And this is an organizations where different kind of memberships, whether it is corporate, associates, observers, and guest membership, even subject matter experts membership can also be thought of. Next. These are the resources which are available on the website. So we would request you all to go through these. Next. So now, in the end, this is going to be the last slide, where we find that in through these meetings, whether through NCC 2023, ComsNet 2023, which was there in Bangalore, whether it is IEEE ANTS, and also there was a meeting in the IMC, that is Indian Mobile Congress 2022, which was from 1st October to 4th October in Delhi, where the 5G was launched by the Prime Minister. So we had carried out these workshops, and we want to now identify and request all the researchers who are working on the standard driven research to give us those details. And we have put the questionnaires and the form, so that we would like to assist them for funding and these kind of activities which we need, that we would like to assist them either through the TTDF, that is Telecom uh, uh, Technology Development Fund of the DOT, or through the DCIS funds, which is also through, or for that matter, R&D fund. So these are the data which we are going to uh, collate and shortlist those proposals on the researchers, institutes, organizations, startups, where we feel that we should be able to handhold them for funding so that they attend meetings, they contribute in the standards, and we have larger contribution in the global standards. Next. So this is the QR code which has already been given in the form, which we would share with all the participants and attendants and whosoever has attended this meeting, and we would request if this can be shared with others. Next. With this, I have done with the presentation. If there are any questions, or are we still taking questions in the end, or in the end? So thank you very much for this opportunity. Thank you. Jai Hind.
Okay, thank you very much, Vishnuji. A very passionate talk there. I think we all agree with him, no? I think those who control the technology basically controls the world. And as he told, the 6G table is open. So please, you're all welcome to the table. And the he talked about the ecosystem creation. You must have listened to him. The creation of the ecosystem is basically what TSTSI is trying to do. And he told about rural necessities, requirements from our side, which are basically the India centric. It's not only specific to India. I mean, if you go to global standards, you see this everywhere. Everywhere there are such specific requirements. So those citizen centric requirements that he mentioned are quite important. I think he mentioned about end of life and proprietary technologies. Please take note those the movement of that to futuristic technologies, which are innovative, is important for us. So with that, we move on. Thanking Vishnuji again. We move to technical session one, cyber physical systems. We would like to start this session. I would like to introduce session chairs. Dr. Ruchir Gupta is currently associate professor in the Computer Science Engineering Department at IIT Varanasi, Uttar Pradesh in India. Previously, he was associated with JNU, Indian Institute of Information Technology, Jabalpur, and his research areas includes edge computing, IoT, game theory, peer-to-peer networks, and machine learning. So that's Richard. Next, yes. So we have Vinay. Vinay is General Manager, Telecom Standards Group at Reliance Jio. He has 2 decades of telecom R&D experience, holds MTech from IIT Roorkee. He's contributed to national and international standardization efforts at ITUR, 3GPP, TSTSI, and ORAN. So yeah, thank you very much, and it's a pleasure to have you here. Welcome to Rujir and Vinay. I hand over to both of their safe pair of hands to take it forward.
Sure. Thanks a lot for that kind introduction. Uh, and good morning, everyone, and welcome to the 6G Cyber Physical Systems track of this conference on standard based research. It's an honor to be here today to discuss the latest advancements in this exciting and rapidly evolving field. As we look ahead to the future of wireless communications and the Internet of Things, it's clear that the next generation of networks will need to be faster, more reliable, and more secure than ever before. And that's where 6G comes in. With its promise of ultra high speed connectivity, massive device density, ultra low latency, 6G represents a major leap forward in the capabilities of current wireless networks. But to make 6G a reality, we need to work together, the academia, industry, and the government, to establish a common framework for research and development that will benefit everyone in the field. And that's why this conference is so important. It provides a platform for experts from a range of backgrounds to come together and share their knowledge, insights, and the ideas on standards based research. One of the key themes of this conference is the importance of collaboration between the academia and the industry. And nowhere is this more important than in the development of the 6G cyber physical systems. Now, by working together, we can create standards that reflect the latest advancements in the research while also ensuring that these standards are practical and scalable for industry applications. Now, another issue is addressing the challenges of future also implies that there must be a shift, right, in some of the basic network paradigms. From physical and digital worlds to a cyber physical continuum, the network platform should not only connect humans and machines, but be also fully, it should also get fully merged in with the realities to allow seamless interaction and immersive experience to the end customers. Throughout this track today, we'll be exploring a range of topics, including the technical challenges of 6G, the potential applications of cyber physical systems, and the role of standardization in driving innovation and progress. I encourage you to engage with one another, to ask questions, to share your your ideas, insights, and to make most of this unique opportunity to learn and collaborate. Today's talks include: one, the role of standards driven research in haptics proliferation by Professor Brijesh Lal. Second, the development of cyber physical systems and Internet of Things using small world phenomena by Professor Omji Pandey. And third, the importance of positioning and sensing for building a digital twin, which will be given by Mr. Jishnu from Tejas Networks. Now, standardization is about making a research solution to an existing challenge work in real life situations, right? And before I close my opening remarks, maybe more something more on standardization, in offering. One, standardization is a critical process for ensuring interoperability and compatibility of telecommunication industry in general. However, developing effective standards requires anticipating the potential challenges which will come in future much ahead of time and addressing them proactively, right? And standardization is not just about creating technical specifications per se. It is also about anticipating the needs and expectations of all the stakeholders. By involving a broad range of stakeholders in the standardization process and anticipating their concerns, standardization bodies can develop the standards that are relevant, effective, and widely adopted. All three are equally important. Last but not the least, the success of standardization, whoever does it, depends on the ability to anticipate and address the challenges, as I said, whether it's the need for new technologies, one, challenge the changing market dynamics need to be taken into account, or the evolving regulatory requirements also push sometimes the need for further standardizations. Standardization bodies must be agile and responsive to all three to ensure the standards remain relevant and effective over the time. With those words, I would like to again thank you all for joining us today, this morning, and I look forward to a productive and insightful conference on standard based research in the field of 6G cyber physical systems. Thank you very much. I would like to hand over the session to my co chair, Dr. Ruchit. Thank you.
So can you put these slides of speaker introduction? So is it already there? Okay, so in this session, first talk is from Professor Brajesh Lal, as mentioned by Vinay. Professor Brajesh Lal is currently Professor Electrical Engineering Department and has earlier served as head of Bharati School of Telecom Technology and Management. He is the coordinator of two Center of Excellences, Airtel IIT Delhi, Center of Excellence in Telecommunication, and Ericsson IIT Delhi 5G Center of Excellence. He is also the in charge of an IoT laboratory that he sets up in collaboration with Samsung. He is also the co-PI of the project building an end-to-end 5G testbed funded by DOT. So I'll request Professor Lal to deliver his talk. Professor Lal.
Morning, everyone. Thank you for this opportunity. So, Ruchir, will somebody put up the slides? All right. So, these slides are essentially placeholders. I will talk in general about the role of standards-driven research in haptics, and you'll see that there's a lot of opportunity here as far as haptics is concerned. The entire stack, right from the application layer till the communication stack, everything needs to be standardized for haptics to become commonplace and a reality in our daily lives. So in today's talk, what I'll try to do is try to make clear what haptics is about and why there is a need of standardization and what's the scope of standardization that might be needed for making such a thing more commonplace. So if you can move to the next slide, please. All right. So the easiest way to understand haptics is to think of the tactile internet. The idea here is that you, instead of just interacting with your environment through vision and speech, you also interact with your environment through the sense of touch. We already have some degree of tactile experience by the way of our phones, the way they give us feedback, vibration feedback, and some other simpler implementations of those kind. But haptics is set to become even more pervasive because a lot more work will need to be done collaboratively between machines and humans. So as we move towards the domain of cobotics, there will be a need to have more reliable and more easily usable uh, tactile or more accurately haptics capability. So haptics capabilities essentially consists of two capabilities. There's a sense of pressure, which is kinesthetics, and that of the texture, which is known as tactile. So tactile and kinesthetics together imply the complete haptics experience that we can get from the environment. The way this has to play out is through a way of, for example, for illustration, a haptic glove, which is what a person would wear and will get feedback based on a, a robotic hand which would be interacting with the environment. So, one of the first works that we're doing at IT Delhi are related to teleoperation. So, on the one hand, you have an operator who's, let's say, wearing a haptic glove. With this haptic glove, the user expects to experience whatever the robotic hand is experiencing. For this, the requirement is that the robotic hand should be able to sense what's around it by way of pressure and by way of fine details, which are also known as texture. So both of these information have to be faithfully transferred back to the haptic glove and played out in the haptic glove so that the human being experiences whatever the robotic hand is experiencing. So as you can see, this requires standardization in way of collecting data and in way of transmitting it, and finally in way of converting it back into a signal that the human understands. So all of these areas are in need of standardization. What the reason standardization is important here is because a lot of solutions today for such devices are proprietary, and as long as they continue to be proprietary, proliferation will continue to be low. As soon as interoperability is introduced, there is an opportunity for much larger uh, deployments of such devices. This is as far as the device itself is concerned, but there are also implications to the communication network. So, in context of 5G and beyond, moving towards 6G, while the latency numbers have gone down, which means that the latency has improved and end-to-end latency is low, which is a good thing. The reliability is higher, the security is higher, and it is scalable. However, what happens is when you move from speech to video, to haptics, the need for latency becomes even more stringent. The need for availability becomes even more critical because any loss of reliability could result in catastrophic accidents. So suddenly, as you were moving from speech to video, people talked about bandwidth, they talked about lower latency, and experience which was being enhanced. And the moment you move to latency, those numbers no longer are good enough. So there will need to be continued evolution in the way the net communication networks service such applications. Therefore, there is, besides the need for standardization in the devices themselves, there's also the need for standardization related activity in the underlying communication network. The third area that will require some degree of standardization is the encoding and decoding approach that people will have to take for haptics. There will need to be a standard mechanism for encoding and transmitting the data which corresponds to haptics, because interoperability can not be guaranteed by any other way, because otherwise you'd require the same proprietary algorithms on both sides. Just as we've seen for video and speech, immense amount of standardization activity happens for codecs for these fields. Something similar will also be needed for haptics. So haptics in that sense represents a, a green field and a plethora of opportunities as far as standardization activities is concerned. You have to standardize the way the hardware works, the operating system that sits on top of it, how does the encoding happen, and how does the communication happen. So there's this large canvas that has become available because of haptics becoming more and more popular. And the fundamental reason for tactile or haptics becoming popular, one is increased immersiveness, and the second is performing tasks which might be otherwise dangerous or monotonous for humans to do. So a lot more human like activities being performed by machines is what we are headed towards. Can we move to the next slide, please? All right, so here we look at the architecture and technology components. If you look at a typical tactile internet architecture, you have what is known as the master domain, where you have a human directing the remotely placed devices, for example, a robotic hand, or possibly a larger machine which performs tasks autonomously. So you have the control domain on the other end, and all of this is connected via network domain. What you need is bidirectional haptics control, which means that you need to have feedback to the controller, and also on the other hand, you expect the controller to pass on actuation signals for the devices at the endpoint. The other thing that we need to understand here is that while you are trying to do this, we will need to also look at what is known as creating intelligence in the server. So the human controller can be replaced by a machine that is a set of algorithms. Each algorithm is one task or the other. For example, filling the shelves up with the equipment or devices that you need, or cleaning a place, or possibly sweeping for mines in a minefield. Any activity could either be done by a human operator who's adept at that task, or we could set up algorithms and bring out the corresponding algorithm on the server, and the entire activity could be done autonomously end to end. So all of this means that there is this need of high degree of interoperability. You could have human operators, you could have multiple human operators who could be operating from different remote locations, or you could have servers or distributed intelligence placed at different parts in the entire network. So any of these should be seamlessly be able to connect to the network, and via the network to the endpoint, which again could be of a different, which again could be of different types and could be at different geographical locations. So the need for interoperability is paramount in large scale proliferation of such tasks, and it is also very important for these tasks and these capabilities to become more advanced and more uh, fruitful. So in this diagram we are able to identify all we are actually able to see all the areas where standardization will play a key role as far as research in this space is concerned. So to the rightmost part of the screen you see the endpoints. Here you have devices. You'll have to do some degree of standardization in the way the different hardwares operate. You'll have to have some degree of standardization in the way the drivers are written. You'll need some kind of standardization in the way the encoding of the data is done. Then you will need standardization improvements because the capability of the network domain itself has to go up. And finally, at the remote end where the human controller is sitting and operating the devices remotely, again you have a set of hardware which needs to be interoperable, and again the need for encoder being interoperable across devices and manufacturers will become important. Can we move to the next slide, please? Right. So this lists some of the things that I've been talking about a little more comprehensively. These are device related. This does not talk about the standardization activities that will be required in the area of communication itself. Rather, in the device, what are the things that we might need to do? So there need to be standardization with respect to design, where there should be design guidelines, haptic language, so that you understand the intent of the operator or that of the algorithm, and the endpoint or the machine reacts accordingly. Creation of tools so that you are able to perform tasks seamlessly. Similarly, there'll be a need for standardization in software, most importantly in the codec, so that devices of different manufacturers can speak to each other, because they'll all transmit data in the same format. But unless there is some degree of design guidelines in way the hardware is itself produced, this will not be possible. So in software you have APIs which have to be standardized, operating systems that will need to be standardized, but more importantly the hardware itself, the actuators and driver ICs will also need to be standardized. Otherwise all that you do at layers higher will be of little use, because the hardware itself, if it is not standardized, will not be able to understand what is being said to it. So so this clearly tells us that the amount of opportunity just as far as the device and its enablement ecosystem is concerned is huge, and this is just one aspect of standardization driven research as far as haptics is concerned. And haptics is going to become an important payload in 6G. Therefore a lot of work will go into development of hardware and codecs and also design guidelines. Now the thing that we must understand here is that when we started communicating videos, streaming videos, or using them for video conferencing or speech for that matter, uh, the devices for capturing speech, the devices for rendering videos and images had evolved to a reasonable degree. So the standardization activity at those points in time were driven largely by the encoding need and the communication network needs. Right now, the hardware itself is improving, and therefore it probably is a good thing that while the hardware improves, there are certain standards guidelines that are put in place so that some of these do not move far away, that they become difficult to deploy in generic or existing architectures. Can we move to the next slide, please? All right. Now here are some of the activities that are currently on. So some of the haptic standards do exist, but they do not pertain to the haptics technology stack. These are uh, almost silo kind of efforts being done without looking at interoperability in the manner that they should. So the idea here is to create haptic standards which are based on the entire technology stack, so that the interdependency of the entire system is taken care of, and because of this, there is consistency in the way the endpoints will interact with each other. So here we have three standards on which some work is happening, but as is obvious, it does not look at the problem end to end, but tries to solve uh, some specific problems in the area of haptics. For example, MPEG-V provides an architecture and specifics associated with information representation. This is to enable interoperability between virtual worlds. Then you have this other standard, SMPTE. This deals with the definition and representation of haptic tactile essence for broadcast production applications, because people want to experience tactile or haptics content along with here being able to hear it and also being able to see it. And then the ISO standard, which deals with evaluation of haptic and tactile interactions with devices such as 2D and 3D gesture sensors, desktop haptic interfaces, and tactile mobile devices, for example, you have in phones these days. So these are very, very specific standards. And because of that, what happens is they do not create an environment or an ecosystem which can really make this kind of capability flourish. Can we please move to the next slide? All right. So that was about the device. The other aspect that we need to look at carefully is the communication network itself. And here, at least we have committed ourselves to the edge. Of course, there's work that needs to be happened at multiple places in the entire communication network. But as a group, we are looking at mobile edge computing, and the reason for that is that the need for low latency and high availability, the best way to guarantee that in today's environment is via edge. Therefore, the work that we do in the area of research for enabling haptics, outside of the device related research, for the communication aspect, we are committing ourselves to edge, and we are seeing how the edge should evolve so that it can seamlessly and natively support the tactile applications that might exist. So on the left here, you see the 1 millisecond latency requirement for activity. So here uh, you have a sensor, you have embedded computing, there's this communication that happens between the transmitter and receiver, and if it is at the edge cloud, you are able to reach to the actuator with a 1 millisecond delay. If you go all the way back to the server, they'll be maintaining this low latency requirement will get really difficult. And on the right hand side is a more detailed picturization of the same scenario where, like always, there's need for bidirectional haptic control. The human operator wants to send signal to the endpoint based on the feedback that it is getting from it. And on the other hand, the endpoint has to react to whatever the human being is asking it to do, and it also has to sense the close by environment so that it can give feedback to the human operator. Can we move to the next slide, please? So these are details of the proposed architecture by HC, and these slides will be shared. You can look at them at leisure. We'll move on to the next slide. We'll leave out these details because then we take away from the flow of the presentation. Next slide, please. So, but at a high level, what you have is MEC components and information flow, and within the components you have entities and you have interfaces. Can we please move to the next slide? Okay, these are more details. We can move on, please. Y- yes, next slide. Yes, so let's spend a little time on this particular slide because this sort of showcases the kind of setup that we have here at IIT, where IIT Delhi, along with IIT Bhilai, is working on enabling this particular architecture, making sure that it is able to perform reliably and accurately. So, um, at the remote level, you have a haptics hand. This is on the rightmost side of the slide, and the haptic glove is, in some sense, the remote control or the human controller. Like I said earlier, it does not necessarily have to be a human. It can also be a machine with the right set of algorithm and commands written in the code. And on the leftmost side, you have the UE or the endpoint, where you have the robotic hand, which is performing the actual manipulation close to the environment of interest. And in the middle, you have edge level activities which ensure that the data is interchanged between the two devices in time. So the platform needs to be, the platform is being looked into and developed, and we are working at this particular point in time in distributed computing. And how can distributed computing ensure reliability, speed, scale, all of it at the same time? Because some processing will be done at the UE level itself, most of it would be done at the edge, and some less time critical activities can go all the way up to the server, and those non real time or relatively less real-time applications can be run on the server itself. Can we move to the next slide, please? Okay, so these are the current 3GPP standards which are talking about, and these are all with respect to MEC. These are the standards which impact the edge computing work that anybody would want to do. Can we please move to the next slide? And this actually is the list of the different things that exist. Okay, can we move to the next slide? Okay, so this is the last formal slide that I have. So here again, what we have is the potential use case, the use cases and the potential 5G requirements, and these 5G requirements will in turn require research, and this research will need to be standardization driven. So, in closing, let me reiterate that haptics is a very, very important modality in coming times. One, because it increases the immersiveness and the level of experience when we communicate with other humans. It helps improve entertainment by way of consuming streamed content and in gaming. And finally, it allows humans and robots to interact and work collaboratively. So, after Industry 4.0, in 5.0, the most important aspect that is being talked about is collaborative work done by humans and robots on the shop floor. So, haptics has a very, very important role to play as a modality type in the communication networks of the future. The second point that I would like to re-emphasize is that most of the research in the area of haptics is standardization driven. Well, should be standardization driven is a better expression, because some of it today is not standardization driven. There are proprietary efforts which are happening in isolation, but they have to come together. They have to be able to speak to each other. So at the device level, at the communication level, at the codec level, so the opportunities are limitless as far as research and opportunities to contributing to standardization, and possibly even making a few new standards are talked about. Thank you. I'll end my talk here, and I'll be happy to take questions if any, now or later, depending on what's decided.
Thank you, sir. So you discussed about haptic and the possibilities of standardization into that. You also discussed about the MEC and the interface between MEC and haptics, and of course, you stressed upon the requirement of standardization for haptic application. Questions will probably take at the end.
Okay. Okay, good. Thank you then.
Pardon? Yeah. So if there is
Thank
any
you.
question, probably a couple of questions we can
We
take
can
right
take
now.
them in the end, Ruchi. Thank you so much. I said thank you. I'll take questions in the end along with the other questions.
Okay.
Thanks.
Okay. So our next speaker is Dr. Omji Pandey. Can you please share his bio?
Yes, thank you very much for.
So just a minute. So Professor Omji Pandey is currently working as an assistant professor with the Department of Electronics Engineering, IIT BHU. His research interests include wireless sensor networks, low power, wide area networks, unmanned aerial vehicle networks, mobile and computing, cyber physical systems, and IoT, cloud and fog computing, UAV assisted optical communications, and social network. He also worked on image, video, and environmental sound classification problems under various conditions. He received PhD from Department of Electrical Engineering, IIT Kanpur in 2019. Worked as postdoctoral fellow with Communication Theories Research Group, Department of Electrical and Computer Engineering, University of uh, Saskatoon, SK, Canada. His today's topic is development of cyber physical systems and Internet of Things using small word phenomena. So, Professor Omji Pandey, kindly deliver your talk.
Yeah, so
So,
thank you very much. So, can I share my slides? So, slides are visible to you all?
yeah,
Yes, sir.
So, thank you very much for this opportunity to deliver a talk on the small world models. So, in fact, the title was Development of Cyber Physical Systems and Internet of Things using small world models. But in a brief manner, I have written this small world models for IoT applications, or we can say CPS applications. So, basically, if we are looking for cyber physical systems and Internet of Things, then we have several standards. For example, IEEE 802.15.4, which is corresponding to GP protocol for wireless sensor network applications. And here in the left bottom, a schematic diagram of wireless sensor network is also illustrated, where various sensor nodes are sensing the phenomena, and they are sending the information to the sync node in a cooperative manner. And the sync node is connected to internet, and the end user is getting all the information what has been sensed by the sensor nodes. So, what are the basically challenges with when we are especially going to work with wireless sensor networks? So the challenge is we want the network to be of to run for years, and for that we are having various protocols and standards. For example, IEEE 802.11, that is Wi-Fi. But as it is going to work on high speed data rate, we want a lower speed data rate, and we are going for IEEE 802.15.4 protocol, where the data rate will be of the order of 250 kb ps, and we are fetching the information from the area of interest. A real field sensor node deployment is also illustrated at the right bottom, and if we will take the help of these standards and these networks, then we are able to develop these cyber physical systems and Internet of Things. Where from the middle figure you can see that physical world phenomena is going to be sensed by this wireless sensor network, and ultimately the data is going to the cyber world, where various computations going to be performed, and they are either generating the actuating signals to control the physical world phenomena, or they are doing computation and again sending the information to cyber world itself to get some more info about the physical world. So this is the illustration about cyber physical systems and Internet of Things and wireless sensor network, and why we are very much required in the direction of this standards, either that is standards in terms of hardware over the devices, or in terms of communication. So that I will discuss later. But in particular, if we are looking for wireless sensor network architecture, then essentially it is going to be divided as bottom layer, middle layer, and application layer. Where in particular, we have addressed the challenges of several challenges of wireless sensor network. For example, node localization, synchronization, low latency and energy balance data transmission, and various other aspects. Now, what are the applications of this CPS and IoT driven smart world? That is also shown here, that we have various applications. Either we are talking about smart homes, healthcare, smart cities, or smart agriculture system we are talking. So we are looking for various standards with respect to communication and with respect to hardware devices, which will further enhance the quality of service or energy efficiency or quality of experience at the user. So for this context, basically, I have used this small word phenomena. So first, because it is a new terminology, I just want to go to in more details of that. What is the small world models? So in the year 1967, this person, Stanley Milgram, he observed this small world phenomena in the context of social connectivity, and he performed certain mail delivery kind of experiment, and he concluded that in this world, two randomly persons are not more than 5 to 6 steps to each other, and later on this became a theory of degree of separation theory. So later in the year 1998, there were two persons, Duncan Watts and Stephen Sturgate. They observed this phenomena in a graph. So graph means if you are having a well-structured graph, which is a regular graph, we will call it as a regular graph, and if we are doing certain kind of rewiring in that particular graph, then we will move into the small world graph, and if the probability of rewiring is going to increase to a higher value, then we are moving towards random graph. But in particular, or we can say essentially, the benefits are, if we are lying into the small world graph, that benefits we will try to understand that how we will get benefited if we are going to lie into the small world region. But before understanding this, the benefits of a small world, we should understand that what are the characteristics of these regular small world and random graph. So essentially, there are two parameters through which we are going to classify a graph or a network, that the network is a regular network or a small world network or random network. So they are the average path length and the clustering coefficient. So average path length is going to tell us that how many number of hops are required when we are transmitting the data between two randomly selected node pairs. And clustering coefficient is going to define that what is the clusterness of the individual devices in the network. So if we are talking about regular network, we are having both values as high, average path length and average clustering coefficient. In case of small world network, we are having high average clustering coefficient and low average path length, while in case of random network, we are having both values low. So the advantage comes if we are having a low average path length. Of course, we are going to address several challenges such as low latency data transmission, which is pretty much desirable for the next generation of wireless networks. And with the help of this high average clustering coefficient, we are going to get a benefit of balancing phenomena. If some of the devices in the network, they are feeling more interference phenomena, or they are heavily loaded with the data traffic, then we can pass this information to other devices to whom they are well connected, and we will be able to efficiently address the several challenges of the network. So, like how this small world wireless sensor network emerged, that is illustrated over here. That where we are saying that in the context of wireless sensor network, also we are introducing some long range links in the network, and this is the small world model developed by us in IIT Kanpur, where we have used some mobile nodes, and they are moving and they are creating this small world phenomena. They are introducing this small world phenomena in a wireless sensor network. So this is basically conventional wireless sensor network, and over the simulated test bed what we have developed, and this is the small world wireless sensor network in the context of simulations. And this is a real field sensor node deployment, which for which development we have used NI sensor nodes, NI 32, and gateway, as a gateway we have used NI 9792, and this is the small word developed over real field uh, test bed, we can say. So basically, the challenges comes with respect to that how we can introduce this long range links in the network, and there specifically we have to focus on this several standards uh, through which we can create these long range links without affecting the scalability issues or other challenges of the network. So these are the motivations that why we are going for this development of small world models for wireless sensor network, and these are the existing methods through which we can introduce this small world phenomena. And here the essential part of this hardware standardization or communication standardization is pretty much required, because you can see, like, if we are going to introduce this small world phenomena using wired links, where we will create some of the long physical wires in the network, so they will face several challenges. For example, they will not be useful for applications like battlefield surveillance or flood monitoring areas. And if we are going for heterogeneous sensor nodes, where we will mount on the individual sensor nodes various radios, then it is going to increase the hardware complexity, and it is also going to increase the cost of the sensor node. And if we are talking about the long range link introduction using data mules, where mobile node will move in the network and they will create long range links, then we will face several other issues. For example, we have to face the issues of data latency, because the nodes will move and they will pass the information. So another interesting part is beamforming. We can do the MIMO beamforming, or we can do the collaborative beamforming to further address the challenges of hardware complexity of the sensor nodes. So from this slide, we are able to understand that yes, if we are able to, because like if we are essentially looking for this wireless sensor network, we know the standards that on which standard it is going to work. It is IEEE 802.15.4, and it is having limited radio range capability. And if we are going for a cellular infrastructure, then of course you can provide the long range connection, but of course the deployment infrastructure cost and the complexity of the development of the network, that will be quite challenging issue. So of course we should focus, or we should be able to develop some of the standards through which we can address the challenges of long range introduction, which right now you are saying that there are existing methods and all the methods are facing certain challenges. So that is the motivation that currently I'm also working in this direction. And recently some of the works we have done where we have used LoRa communication protocols for the long range introduction, but that is also facing certain challenges. So of course we should move in the direction of development of some of the protocols or some of the standards, whether it is in the context of hardware, or it is in the context of communication. So these are some of the research contribution in the context of small world phenomena what we have done, and they are only few. We have already published some other journals in the context of this small world cyber physical systems or a small world Internet of Things. But yes, some of them are mentioned over here. And this is one of the problem formulation that how we have developed this small world model. So I will not go into much detail of this problem formulation, and some of the notations they are explained over here. So this is the a comparative study that when we are going to introduce this small world phenomena in a wireless sensor network, then if we are going to at a time we are going to introduce the long range links in the network, then the illustration is given over here. But as we know that as we are going to introduce a single link in the network, the whole topology of the network will change. So we have also introduced this small world phenomena in a wireless sensor network using in a iterative manner, and that is more effective, and it is providing more better performance with respect to introduction of a small world characteristics. So this is a real field sensor node deployment, and this is the conventional network, and this is the small world wireless sensor network where we have introduced long range links which are indicated using red color. So this is the what I was talking about, that the iterative and non-iterative methodology, and a comparative study is illustrated over here, where we can see that the performance of iterative APL reduction, if we are talking about, then it is giving us the better performance in comparison to non-iterative method. And with respect to average clustering coefficient, both methods are almost performing on the same manner. But yes, of course, the performance of non-iterative is in the context of average clustering coefficient is better. So, what are the applications? What are the challenges we have addressed? So, we have addressed this localization performance. We have seen this bandwidth utilization, power consumption, and the number of anchors required, which is also a major issue, because if we are going to mount on individual sensor node GPS, the power consumption and the cost of the network deployment is going to increase. So this is another comparison what we have done over conventional wireless sensor network and a small world wireless sensor network, and we have evaluated the performance over simulated test bed, over Intel lab dataset, and over real field sensor net deployment. And in the all the context, we are getting better performance. Either we are talking about localization performance, or power consumption, or bandwidth requirement. So we have also done the Kramer all-over bound analysis, and that I will not go into much detail. So this is another problem formulation where we have proposed some probabilistic model for the introduction of small world phenomena, and the problem formulation is to achieve low latency and energy balanced data transmission, where we have kept this one as an objective function with a certain constraints. So this is an illustration that when we are going to introduce this long range links, we are introducing the set of links at different iterations, depending on, because like as at a time we are going to introduce certain long range links in the network, the various node will deplete their energy, and they will also experience various data traffic load on them. So depending on these situations, we have assigned certain probability to individual sensor node, and at each discrete time instance we are going to introduce this long range links, certain number of long range links in the network, which are indicated using blue color. At time instant t1, we can assume that at time instant t1 these blue colors are going to indicate the long range links, and at time instant t2 these red links are the long range links introduced in the network, while these dots are the sensor nodes, and black links are the conventional links. So we can see that this black links are having limited radio range, and as I have already told that we are going for the standard for IEEE 802.15.4. So that is having a lot of challenges with respect to power consumption and the connectivity, like at what range they can do the connectivity. So essentially, we should. The important question is, when we are going to introduce this long-range links in the network, that is the most critical part, because like the question will be how you will create these long-range links, and that we have also discussed that what are the existing methods. So we should be able to standardize this communication in such a way that the devices automatically will be able to understand, and they will do, or they will perform their connections accordingly, that it should be of low range communication, or it should be of moderate level of communication, or it should be of long range communication. So that standardization in the context of hardware and over the devices, or in the context of communication, is required. So this is an illustration of conventional wireless sensor network and small word wireless sensor network. And if we are going to do the clustering of the devices, or we can say it is a kind of leech protocol, where the cluster heads are going to communicate to the sync node, and this is the direct data transmission, where the devices are directly transmitting the data to the sync node. So all these things are from all these diagrams. The main primary challenge, if we are talking about, that is that how the devices will communicate over a longer distance, and that's what the standardization is going to play a very crucial role, and which will lead to improved performance of the networks in various contexts. Either you are talking about bandwidth utilization, or you are talking about energy efficiency, or throughput performance, or latency, or you can say even if we are going to improve the performance of localization in the network. So these are going to illustrate that if we are talking about network lifetime and data latency, then the small word models, where we are going to introduce this long range links in the network, they are giving us better performance in the context of data latency if we are going to compare with the conventional routing algorithms. However, of course, the performance of data latency is not better if we are going to compare with the leech protocol or direct data transmission frameworks. But of course, if we are going to talk about network lifetime, and we are measuring the network lifetime in terms of number of iterations, then you can see that small word models based cyber physical systems, we can see, or we can say Internet of Things, or we can say wireless sensor network, they are giving better performance in comparison to either you are talking about conventional routing approaches, or leech protocols, or direct data transmission frameworks. So we have evaluated the performance over both simulated test bed and real field sensor node deployment, and the results are shown to you. Now we can go for this beam farming, and as a part of research work, I have already done this the beam farming from the individual sensor node as a part of my postdoctoral research work. And currently I'm looking for collaborative beamforming, where we can introduce this. So the primary challenge is that how we will be able to create the long range links. So here, if we are going to use the single node for the beamforming, we have to use antenna array, or we can say the hardware complexity of the sensor node is going to increase. But if we want to do the beamforming for the introduction of long range links, then we can do the collaborative beamforming as well, where the sensor nodes will be single antenna mounted, but a group of sensor nodes will perform the long range introduction. So the primary challenge is here, if you are going for collaborative beamforming, that how we will select the devices which will give us the optimal introduction of small word characteristics. And Further, the challenge are like how many devices you will consider for the beamforming and which set of devices you will use for the beamforming. So there are various challenges we are when we are going to address the challenges of cyber physical systems using small word models. So for this, we have to go for various standardization so that we can improve the performance of the network, uh, which will address all these issues what we have addressed so far. So this is the an illustration where we are seeing that the advantage of this small word phenomena, and we can see that if you are talking about convergence rate, the convergence rate is very good if we are falling in the range of in the region of a small word, and the error is also better in the small word region. So this is basically either you are talking about detection of the phenomena in the network, or you are talking about the parameter estimation of the phenomena in the network. So it is just illustrating that if we are doing beamforming based small word development, then we are getting various advantages. Now, as I have told that this we have to go for development of some of the standardization with respect to communication part, then it is a small word based low power wide area network. So low power wide area network is going to provide us the advantage if we are going to introduce the long range links, because it is based on LoRa communication protocol, where the power consumption will be less while the transmission range will be high. So, but as looking for the large volume of the data generated by the IoT devices or cyber physical systems, continuous transmission of the data over the long distance using LoRa communication protocol will also face several energy efficiency challenges. So, if we are going to do the multi-hop data routing, and various papers recently came which are proposing multi-hub data routing in low power wide area network, but on the other hand, they are going to face the challenges of quality of service issues, and for example, data latency will be increased, and data interference will increase. We will be able to receive low throughput data at the sync node or at the gateway. So here we have proposed this is the work which is published in IEEE Transactions on Cognitive Communication and Networking, where we have proposed a Q-learning framework where we are the devices are automatically identifying that which next relay node we have to select for the transfer of the data, where they are adjusting the transmission range by themselves, and they are improving the performance of the network. So further, we can also go for this improving energy efficiency and quality of service over time varying IoT network. And currently, I'm working on this particular problem. And also, if we are talking about, because like we know that we are all the devices in most of the cases, either that is human held devices or any other devices, they are very much socially connected. So we have also used social relationship index factor, and we are trying to introduce some long range links or short range links in the network, and towards improving the performance of the network. And we are also working on this UAV assisted small word LoRa communication solutions. And recently I have published in IEEE Internet of Things one paper, which is where we are going to introduce in small word phenomena in time varying IoT, time varying small word UAV network. So this is an illustration of that, and we are also exploring this UAV-based optical wireless communication, where we are planning to introduce this small word phenomena in the optical wireless communication. So the overall, what I just want to conclude from here, that yes, we are able to see from these slides that yes, small word phenomena is going to address several challenges of the cyber physical systems or Internet of Things, But the primary challenge is that how we are going to introduce this small world phenomena in the network, and it is a very challenging problem. And for that, like, we have to go for this development of some of the standards and protocols, so that we will be able to utilize the advantages of a small world phenomena in various contexts. So here I just want to conclude, and like, if you are having any question, I'm happy to answer.
Okay. Thank you, Professor Omji Pandey. You discussed about the wireless of standardization in those scenarios. So, thank you. Now, our next speaker is Mr. Jishnu from Tejas Networks. Can we? So, we'll complete the session. So, Mr. Jishnu Arvind Keshan is the principal architect in CTO's office, Tejas Networks India Limited, where he is responsible for deciding the long-term roadmap of the company. He has been actively involved in standardization activities as TSDSI from since inception, and at ITUR, WPSD, 3GPP, 3GPP, REN 1, SA2. He was instrumental in development of TSDSI, CPRI, frontal standard. He played a significant role in inclusion of TSDSI low mobility large cell LMSC as a 5G evolution configuration in rural eMMV at ITUR. He later coordinated TSDSI effort for inclusion of TSDSI's 5G radio interface technology, 5GI in ITUR IMT. He represents Tejas at ITUT SG15, and he has contributed towards the development of ITUT 80T2 and MPLS TP standards. So, Mr. Jishnu, kindly deliver your talk.
Thank you, Ruchir. Thank you, Vinay, both of you for inviting, and happy to be at NCC. This was my first paper was in NCC. That it was way back in 2004, and happy to be back in NCC 20 years later, and happy to find that NCC has become sort of one of the premium communication conference in India. And hopefully, I will see a lot of you also getting into industry and doing a lot of those standard-driven research. So can you put the slides? Thank you. So I work in a company called Tejas Networks. So we started off as an optical products company, and now we are also doing wireless. So this is sort of an interesting thing that as we move to sort of terahertz, sub-terahertz wavelength, the electromagnetic moves from something like an RF to an optical thing, and we are sort of in the intersection here. It's also interesting because a completely new domain is coming up. So I am from network side, so it will be all the topic would be discussed from what we see this as an issue from a network side. So the one of the main use cases, which at least in Tejas we believe, is creating a digital twin of the whole city, the people, everything out there. It's also called metaverse by Facebook. So the digital twin would have to be an authentic digital representation of this physical world. So unlike the gaming which you do on your phone today, it's not really not a real-time authentic display of the digital world, the real world. So they take a snapshot at some point of time and try to make it very realistic, but we really want to make it as realistic as the real digital world. So the I have taken a picture from Boston Harbor. Sadly, I don't have it for Guwahati. And how they built up a digital world, which would be a digital representation of this whole world. And this should basically enhance your experience as well. And hopefully, the Google Street View, roughly, if you want to visualize this, it's like the Google Street View becomes sort of much better with a communication networking layer, adding a sensing capability to it. So can I move to the next slide? So what is the real problem from a networking side of it? So you have a problem where you have users who are connected. So these are called this is your handsets. These are the sensors. These are devices which are like any cyber physical system, whether it's your tactile internet, which Professor Brajesh Lal mentioned, or any sensor network which needs to be connected at the hub side. So all of those things jointly we can call it as connected objects. It is easy to get positioning information about from them. So there are enough standards work which has happened to basically find out, triangulate the object which are connected. So this is the positioning problem where you can get enough information. Just there is an angle of arrival, there is the location. So ideally we want to get a three-dimensional view of the person and as much detail from a positioning point of view for all the connected object. So that's one part of the problem, which has been a communication problem for quite some time, and this has been addressed all the way from 3GPP release 8 to even now in the release 16, 17. The second problem, which is completely unique, and this is a 6G problem, which at least in Tejas we believe has much larger communication or the convergence of sensing with communication, which is for the unconnected object. So this is already happening. So if you see Tesla, etc., they have lidar and multiple other sensors integrated into the device. So on the UE side, this has already been happening. So communication and sensing is sort of integrated at the UE side, but at the networking side, it has still not happened. Now that we are getting a much larger spectrum and all that, and we are also using sort of those radar spectrums, can we also sort of integrate radar type sensing into communication? So that's the whole problem, which among multiple other things which 6G is looking into, this is one of the main aspect of the problem which 6G looks into. So that problem, I'm just calling it as sensing related or sensing problem. And these are the two problems which has to be independently thing. I'm just looking now only at the sensing problem because positioning is quite well understood. And one more thing about positioning is that we have been used to this GNSS based mechanism for positioning, but not all places, especially in indoor, you will get GNSS signal. So you have to look for a network, or the communication network also should enable sort of the positioning. So that would continue to evolve. So now the question is, can I integrate the radar-like sensing into communication for detecting the range and the Doppler of the unconnected object and even environment? Say, for example, if it is raining in that place, can I also create a rain in my digital world? So all those environmental, like hopefully we don't have to do that for fog or smog, etc. But anything on the environment also we want to sense it and create it in the digital twin world. Can I move to the next slide? So yeah, basically I just showed the network and how it will be providing that. So the first part, so these are all just the topics at the very top level, and I'm just putting in the main key problems. So what should be the waveform? Can I still continue to use OFDM based waveform? This has been quite popular in LTE, NR, and has been doing a tremendous job. Should we continue with that OFDM? And the only problem with OFDM, if you all know, is basically the high PAPR issue, which there is also a technology called a DFT-S OFDM. So that has been one of the main thing of the 5GI contribution, which went from India. So we had sort of, this was an optional item, and then DFTS cannot be used for multi-layer. So that was one issue in the existing standard. But this is one way to sort of reduce the PAPR. So should I basically do a DFT spreading of the OFDM? The third thing is that as soon as you move to sub-terahertz in say 100 to 300 gigahertz and all that range, the PA technology has lower power efficiency. So we get into this problem much more bigger way in that frequency range. So the PAPR continues to be a problem. So should I continue to use OFDM even for sensing? So there are other waves being considered, which is like frequency modulated continuous wave. Here, basically what we do is we just linearly increase the transmit frequency. Then there is something called single frequency domain equalization. uh, so that could be the other way. So these are waveforms. So nothing has been decided. So this is too early in standards to decide. So we will look into this. This is one problem which is of interest both in the research world and in the standardization world. The second problem is about signal processing. What should I do? So basically, if I want to just put it in a simpler terms, an FFT along the subcarrier dimension, if I am using OFDM for my sensing, gives me the range, and if I do an IFFT along the time direction, it will give me the Doppler. So these are the two things which I can straight away do and get the information about range and Doppler if I am using OFDM. But as I mentioned earlier, you have the PAPR issue. There is also the cyclic prefix. A non-cyclic prefix increases the processing effort. So that's another thing which you need to take care. So signal processing is the second element of the problem. The third element of the problem is like sensing related issues which is there, which is basically, if I suppose use 120 kilohertz, so you know that 5G allows you to support multiple subcarrier spacing. So if suppose I take for example 120 kilohertz as my subcarrier spacing, all I can do is sense objects which are moving at a speed up to 230 kilometer per hour. So that is one part. If I use a normal cyclic prefix, my like the range I can do is around 88 meter with a 120 kilohertz subcarrier spacing. So the subcarrier spacing also sort of becomes an important issue. The third thing is that if suppose I use, if I have to go for sub-meter range resolution for my sensing, then the bandwidth requirement is like at least has to be greater than 150 megahertz. If I use basically the present mechanism of having a 125 millisecond, 0.125 millisecond burst size, uh, you can with this one. So this is roughly the burst duration which I would have to use, 0.125 millisecond, if I'm using a 120 kilohertz subcarrier spacing. If you use 32 symbol over 20 millisecond, these are, so basically if I'm using a lot of my symbols basically for sensing, the communication suffers. So basically I cannot do both simultaneously and all that. So there is any sensing which I do with communication has an impact on the overhead that I separately will discuss, but I'm just putting one number, 32 symbols over 2 millisecond. And if I take say 125 subcarriers over 150 megahertz, this improves my so the it's like giving a 46 dB extra gain for sensing. So that is another aspect of it. Can we move to the next slide? Yeah, the other problem, which is not related to specifically at the physical layer, is a resource allocation problem. So how frequently should I do the sensing? Because as soon as I do sensing, and if I do only sensing, there is no communication, and if I do only communication, there is no sensing. So it has to be something in between of this. So any signal overhead for radar excitation, we want to keep it minimum. So I just put a number here, which if you do 64 beam, and basically if you are doing this every 64 millisecond, you are roughly having an overhead of around 28 to 30% is your overhead, which is sort of unacceptable. So this is something, an algorithm, etc., which needs to be developed over here on how do you optimally do it, and then accordingly it has to come into standards. The fifth aspect is from interference from the radar signal. So if I'm using the same, say for example, the OFDM to basically sense an object, an adjacent base station would see this as an interference. How do you handle it? So maybe I can communicate, inform him about my waveform, what I'm using, etc., over the XN interface. That's one way to handle it. Or maybe I can just orthogonalize the frequency domain for sensing versus communication and then avoid it. So there are multiple approaches you can do even here. The other thing, the sixth thing is that can I do multi-band sensing? So now we are talking about frequencies in 6G all the way from 450 megahertz all the way to maybe 300 gigahertz or something around that. Can I do a better thing whereby can I use some lower band for doing a ultra fine granularity resolution? The low band could be a periodic beam sweep, and the higher band, can I do something like a higher resolution or in the different multiple dimensions? So can I combine that whereby the resolutions can be done in a different way. Low band and high band can be used for a different way, where you do ultra fine measurements, but without actually creating a lot of issues on overhead, etc. Can we move to the next slide? Then this our topic outside that, which is related to AML. This is so once I detect, once I sense the object, can I do that object classification? So is it a car? Is it a moving car? It's a static car, etc. Can something be done on that? Can I do something like a fall motion detection and all that stuff, whereby if suppose there is some accident, can I detect it? Can I do semantic segmentation of radar points? So all of these are additional AML topic. This is also new. Like I have not done a lot of research on this, so maybe few of you should understand it more and then maybe start contributing towards the standard. There is also you could what I understand is that you could do non-supervised learning for classification of this radar clutter. Uh, you have other options like you can have better resolution using classical 2D FFT. So these are topics which are like linked both to AML as well as how do you do the physical layer processing. The other topics which are also of interest for networking company like Tejas is like, can I do distributed massive MIMO? So is it like anyhow we are moved to massive MIMO as part of 5G. So if can we extend it further to do a distributed massive MIMO, which would help us for localization, because that becomes easier for doing the triangulation, etc. from a connected object perspective anyhow. Can it also improve sensing? Can I do sensor fusion, whereby it need not be that I get this information only from the networking layer or this radar type sensing integration? There would be multiple other informations which you will get directly from the sensors through the test sensors which are deployed. Or it could be that it could be even video feeds which you are getting from the field. Can I do the sensor fusion of all of this and create a much better sensing accuracy information and all that stuff? Other point is like I think sensing itself is a new object, so there is no channel modeling etc. done in sensing. If I'm using whatever frequency, it's not very clear which part of the frequency is can be used only for sensing and all that. So all of those regulatory concern are also there. So once all of this gets fixed, even channel modeling in the appropriate frequency band would become quite important. So these are all the topics which are there both at a research level and for standards. So to just step back, I have not a slide for that. What is happening in 6G is that the framework document or the vision document is getting standardized in ITU, and would be we are again having similar issues like what we had in 5G, whether it's coverage, etc. So that will continue to be there. In addition, there are quite a challenging problem like joint communication and sensing. So these are another very fancy subject which would be of interest for the industry as well. So we would request all of you who are attending the NCC also to not only just focus on research, but spend some time to contribute that to standard, because whatever you do in research, if eventually industry has to adopt it, it has to become part of standards, at least in communication. And then once that becomes part of standards, it would be implemented. It may be a device level issue which may be implemented by device vendors or the chip vendors who are making devices, or it would be done by a networking companies like us if it is a network related issue. But I hope all of you start contributing to standards. And I heard Preetham ji mentioning initially on how TSDSA can enable it. So you can take any help from all of us are there to help you to also start contributing to the standards. And thank you, Ruchir. Thank you for giving me the opportunity, and let me know how do we proceed from it. Thank you.
Thank you, Jishan. We discussed about the various research topics, FDM, AIML, and etc. Thank you. So we received one question from. Sorry. Yeah. So we received one question from Bhupendra Kumar in chat to Dr. Omji Pandey. The question was, do you think that TCP/IP protocol used in slide 16 is heavy? Can you come up with other protocols like UDP or IoT based protocols? Professor Romji Pandey have already answered this question in the chat box, so kindly refer to the chat box. So in this session, we had three speakers, two from academia and one from industry. One speaker discussed about the haptic use case and the possibilities of standardization in haptic and MEC along with haptic. Another speaker discussed about the wireless communication possibilities of standardization. And then the third speaker discussed about the various research topics that will be useful for standard driven research. So we can see that there is a lot of possibility in cyber physical systems area for standardization and standard driven research. But then there are a lot of challenges as well. And of course, a lot of sensitization is also required. TSDSI is doing much of that job. So with the hope that, this workshop will actually lead to some step in that direction, I thank you all and conclude the session. And there is a tea outside for, because we are running short of time, so for 5 minutes there is a tea, and then we'll come back. Thank you.
Sir, you are on mute. The venue one.
Okay. Am I audible now?
Yeah,
Okay,
you are audible, sir. The venue machine is also on mute.
no problem. I think, okay. So I think let Samdarshi go. Dr. Samdarshi, go ahead. I'll go required.
Okay, sure, sir. He written in the chat.
Yeah. Should we get started? It is already coming to 11:40. We are 10 minutes beyond 11:30. Let's maybe somebody can check with Samdarshi, sir.
We are already in. It is starting.
All right, welcome back. Thank you very much. Asif, can we have the slides back up?
Yeah, Chandrakanta, please share the screen. Yeah, thank you.
Okay, so that was a very interesting session from Tech Session 1. We had a lot of insights which were shared. Thank you for that. And now we welcome you all to Tech Session 2, that is on Sustainable Data Driven Society. Let's go to our chairs. Next slide. Okay, so we have Dr. Sam Dasi, who is currently working as assistant professor at IIT Roper. Prior to joining IIT Roper, he served as a faculty member at IIIT Guwahati. His research interests include cooperative communications, vehicular communication and networks, and next generation wireless networks. And thank you. We are very happy and honored that you are here to chair the session. Next. Yes, we have our colleague Anindya. Anindya is CTO at Sankhya Labs with approximately 26 years of experience. He is an expert on software-defined radios and has led the design and development of the baseband and RF systems for Sankhya's products in wireless communications. Once again, it's our pleasure to welcome you, Anindya. Then, with that, We also have Veereswar is here. He's currently assistant professor in the Department of CSE at IIT Delhi. He also works closely with Bharati School of Telecommunications, Khosla School of Information Technology, and Center of Excellence in Cyber Systems and Information Assurance at IIT Delhi. His research interests includes anatomizing the communication protocols employed in cyber-physical systems for security and privacy vulnerabilities and then mitigating them with innovative defense mechanisms. Then with that, I would like to hand over to the chairs. It's a pleasure to have the chairs here. Um, Over to the safe pair of hands.
Thank you, sir. Thank you very much. Thanks for the introduction. My friend Mr. Saha from Sankhya Lab and I, Samdarshi from IT Roper, welcomes you all in this session on data-driven society. So, sir has already introduced our first speaker, Dr. Veereshwar Kumar. So, without taking much time, I request Professor Veereshwar, please come and session is yours now, please. I think slides are already shared. Yeah, and one more thing, I mean, it's our honor that for this session we have Professor Chaturvedi here. Sir, welcome to the session. Thanks for the coming.
Okay. Okay. Thanks, Anindya. Thanks, Samdarshi, for inviting me to give this talk. Please go ahead and go to the next slide. Yeah. So the goal that I had in my mind when preparing for this talk is that I will not go into the technical details of what I do, but what I will do is I will share the journey that I have taken in last 1.5 years as a young faculty member, uh, just taking few initial steps towards standardization. So I became part of this Beyond 5G project, and then I became associated with TSC DSI, and then I started looking for a research problem where I will continue working on for 5-10 years or so, and then I will also make an attempt towards making some contribution to the standards driven research. So basically, let me first tell you what my typical work lies, where my typical work lies, and then I will tell you how I oriented my work towards this standard driven research and what I'm doing there. So I look into this idea of smart cyber physical systems or smart IoT networks, where we are not dealing with conventional computer networks, but we are dealing with networks where there are some constraints, whether it is bandwidth based constraint or whether it is energy based constraints. So you can think of a smart city network, you can think of a smart electric grid where there will be resource constrained sensors, energy constrained sensors, allowing the centralized server to make decisions about the network. You can think of a smart home network utilizing probably Bluetooth protocol, which is bandwidth constrained, supporting energy constrained devices. Similarly, smart transportation, smart robots. And there have been, please go next. Yeah, so we have been looking at a variety of attacks in this domain. I do not need to tell about all those attacks, but there have been these large scale attacks which were launched on electric grid in Ukraine some years ago, and then this Mirai botnet attack, which brought down websites of large vendors, large servers. Okay, go next. Yeah, so I look into discovering such security vulnerabilities in such systems and then mitigating them with some defense mechanisms. So go next. Okay, so when I started looking into this domain, so I thought, what will be the problem statement that I should be looking at? So of course, the problem statement had to be somewhere related to security and privacy issue, because that was my strength. And then, of course, this standardization effort should not just point towards issues, but I should also be ready with some defenses and probably try to get them patented. So that was the solution approach. And then I figured that I will also need a simulator that I could experiment with. And there were some simulators available in India and outside. And then I explored what kind of simulators I could use. And then the goal was to go in these steps, come up with a few papers, next come up with some patent, try to get some work into TSDSI, and then from there go to 3GPP. Okay, go next. Yeah. So when I was looking into the 4G or 5G standards, and I started exploring different documents, standardization documents on 3GPP websites, then I thought that I should be picking up a research topic which is going to be there for quite some time, which looks to have some potential, but not much work has been done in that domain. And when I was looking into this idea of network slicing, I thought that although the architecture is there, some thought has been given to the concept, and the concept is very promising. But after reading the documents, I felt that there is not much attention that has been given to security and privacy issues in network slicing. And therefore, I chose this larger domain of network slicing as the research problem that I will start handling. And probably I will find a lot of security bugs there, and then probably I will try to fix them through different techniques. So that was the goal. And so I started with these two topics. So I thought, let me ask this question, that can we prove that no authenticated entity can become part of the 5G network, because there is so much flexibility provided by this network slicing. So is it possible that if if an attacker is trying to infringe on someone's privacy, or if it is trying to just be part of the 5G network, can it do by exploiting uh, some of the characteristics that are facilitated by network slicing? And then the second question was, because this idea of network slicing is going to provide two very important things. So one, connectivity to IoT devices, MTC, machine to machine communication, where there will be millions of devices connected to the 5G network. And the second was that it is also going to connect devices which will be supported by URLLC. So this ultra low latency and ultra reliable systems. So now, if you have two connections with very different objectives being shared through network slicing, then is it possible that denial of service attacks can be launched against the applications which are using URLLC through the applications which are using MTC? Okay, so that was the goal. So connecting through the MTC is very easy. An IoT device can utilize that. And then can it launch an attack against something which is connected to the URLLC slice? Okay, go next. Okay, and then of course, two typical ways that I had to look was, can I prevent those attacks? And if I cannot prevent, can I look into the intrusion detection system? So can I detect those attacks and then respond accordingly? So go next. Okay, so the simulator. So then I had to look for the simulator on which I could work. So basically, my background is from networks. So not so I would not be using the simulators that have been developed, let's say, at other Indian academic institutes, because there they are more focused towards physical layer. So, but my work starts or happens in the core network. Okay, so of course there will be, so I consider everything as a packet, because that is what as a computer scientist I have to do. I just consider it as a packet. I'm not looking at what modulation schemes are being utilized, which schemes are better. So I'm not looking at those things. I just consider a packet, and then what can we do about that packet, what an attacker could do about that packet. So my work involved only the core network. And after doing some research about the simulators that we had in-house at IIT Delhi, we had something at IIT Hyderabad, IIT Madras, I figured that they were not enough for this type of work that I'm trying to do. So therefore I looked online, and then we found that at that time this support of something happening between the UE and the GNB, the user equipment and the base station, and then integrating what was happening with the core network, which was the open, which was something in which I had to work, was not something that was very easy to do. So ORAN was something which was there, but yeah, so we found that not all the functionalities that we wanted were there. So we selected these two simulators, UE Ransim and then Open5GS. So UE Ransim helped us to simulate the user equipment and the base station, and Open5GS helped us to simulate the core network. And then we could have an end-to-end network slice implemented over these simulators. So now also because I had to look into security issues, so I had to look for the third simulator which could actually do some protocol verification. So this is the ProVerif tool, which can probably which can look into the security protocols and give us indications about what protocol is secure, what protocol is not secure. Yeah, next please. Okay, so then of course I started looking into the 5G authentication and key management protocol, 5G aka, because that is the first place to start when you want to work on any security issue. And we looked into the variety of messages which are communicated between different entities in the whole 5G network. So you can think of UE as one entity, the base station as the second entity, and then there are many entities which make the core network, which includes AMF, AUSF, UDM, and there are others as well. So we found that there were, so if a user wants to register, if a UE wants to register with the network, there are around 21, 22 messages which are communicated between different entities, including UE, base station, and different entities of the core network. And we wanted to analyze each of these messages to see. So the goal was to see if an unauthenticated UE can exploit some of these messaging to be part of the network or not. So that was the goal, whether we can attack the network or not. And the attack here was the authentication issue, if we could find some authentication issue there or not. Okay, so next slide. I guess, so is this the next one? Yeah, okay, good. Okay. So so we use the ProVerif tool, and we have currently prototyped the whole 5G registration process, the basically the 5G aka protocol in the ProVerif tool. So of course at this point we have not found anything, but this tool is as smart as you make that tool to be smart. So you have to tell this tool what to look for, and then that tool looks for. So we are still exploring it further. So I will just tell you the effort that it takes to verify these kind of protocols. So there are only a few well-known security protocols which have been proved to be secure. So of course 5G AK is not proved to be secure, which does not mean that it is not secure. It just mean that theoretically you cannot say that it is secure. So of course practically no one has found any security vulnerability, but that does not mean that theoretically it is secure. So very recently, a year back, TLS protocol, the current version of the TLS protocol, TLS 1.2, was proved to be secure. So we have been using TLS for years, for decades, but it was never proven to be secure. So only a year ago it was proven to be secure. So that is the direction that I want to take this 5G aka protocol. That of course nobody has found a security protocol, but let's prove it that nobody can find it. And if we cannot prove it, then we will stumble upon some security vulnerability, and that is the goal. Okay, so in order to achieve those kind of things in the simulator, so we have tried a few things. One of the things that is very popular in the research community is to establish a fake base station, which will act as a man in the middle between the UE and the actual benign base station. So now this man in the middle can act as a UE, and it can also act as a base station, and then transfer messages between the actual UE and the actual base station. And from there it can see if intercepting or forwarding packets can help find some security vulnerability. So that is our current status of the simulator, that we have implemented this fake GNB. It is working properly. It can intercept and forward packets. Now the next goal is to look for different attacks that could be launched using it. Okay, next slide please. Yeah. Okay, so now this was about one thread that I am following. Now let me talk about the other thread. Okay, so the first thread was finding a security vulnerability in the authentication protocol. The second thread is finding whether the 5G protocol, 5G at least what is being utilized in network slicing, is vulnerable to attacks on availability. Okay, so denial of service attack. So we looked into the again the registration process, and we found that the number of cryptographic operations that the core network has to do for registering each user and the cryptographic operations that each user does, they are very similar. Okay, so on this slide, what I'm trying to highlight is there are three cryptographic operations: so hash, encryption or decryption, and you need to just observe that the entire core side does very similar number of operations as the UE side. Okay, so that means that every time a UE wants to register, the core network has to put a lot of resources in registering the UE. And the registration requests will require the core network to do a lot of computation. And so now what these results say? So these results say that what I'm trying to do is, on the second column we have the time taken by the core network for registering a new UE. Okay, so if there is a benign UE and it wants to register, so that is the time taken. And on the first column we have the number of additional malicious registration requests per second sent by by an attacker. Okay, so if there are no requests, if there are no requests, additional requests from the malicious user, then you see that the time taken by the core network is only 260 milliseconds to register the core that's register UE. So remember, these things are being simulated in a simulated environment. So these numbers may not be the true representative of what happens in a real 5G network, but the trend will follow. So whatever trend we will observe here, it will follow in a 5G network. As the attacker becomes more aggressive, when it increases the number of additional requests that it sends, you see a significant increase in the time that is taken for a new user to re-register. Okay, so what this means that uh, it will become more difficult for the core network to register a new UE if on the other slice the attacker is launching an attack. And this is possible. This is happening because the physical resources are being shared. Okay, so although you have logically separated the slices, that does not mean that they are physically separate. So there is always so the isolation is not complete. There is overlap of physical resources between the two slices, and therefore uh, something malicious happening on one slice is affecting something benign happening on the other slice. Okay, yeah, next slide please. Okay, yeah, so we have come up with deep learning based intrusion detection system, which can detect these kind of denial of service attacks, and we have filed a patent on this work. So basically you will look into these different parameters, different packets which are coming from UEs, different packets which are being generated at the base station, different packets from different entities from the core network. You feed all that information into some machine learning, deep learning based model, and that model will do some analysis, figure out whether there is an ongoing attack, or it is just the benign environment where there are some users which are trying to just register with the core network. Okay, next slide please. Okay, so I think yeah, so this is my last slide. So I would just like to share the lessons that I have learned with this standards driven research. So yes, as has been pointed out earlier, it is very important that we do standards driven research. um, but standards driven research is difficult, and identifying the topic, so as a faculty member where you have many other responsibilities, you are teaching, you are guiding multiple students on multiple different topics, and so then identifying a topic is challenging. Then you have to make sure that whatever topic you choose, it is broad enough to cover multiple angles in which you could look at that problem. uh, so and the other thing that I have found out after working on these type of things for some time is that having a large team helps, but then you also need somebody dedicated to keep track of what is happening in these standardization meetings. When are these standardization meetings? Because it is very difficult to keep track of everything which is happening in this domain, and keep track of all the research work that is happening in this domain. So it is not sufficient to just dedicate one PhD student to do all this work. So you need to have a large team, and probably a dedicated staff which is looking into all these aspects and just summarizing all this aspect for the entire team. And yeah, so demonstrating the effectiveness of the idea is very important. Yeah, so you must have a good idea. You might have a very nice result, but yeah, so demonstrating the idea is really important in when you are looking for standardization driven research. And therefore using existing simulators is definitely suggested. Coming up with your own simulators is not suggested. Existing which simulators means the simulators which have been accepted by 3GPP, and that is our goal, that we will probably use some of those simulators to demonstrate our results at the end as well. So that is the end of my talk. Yeah, so I guess next slide. Yeah, thanks. I would be happy to take a few questions at this point. Yeah, go ahead.
Sir, firstly, thank you very much for this. Since we visited, if I can put in mind,
Yeah.
visited the National Center of Communication Security (NCCS) in the Bangalore on 3rd of January this year. So they were looking for the researchers and the academia who can help them to work with them or collaborate, because that is the first lab which has been created by the DOT, that all the network devices, though you mentioned UV and the BTS and the G Node B, all the IT devices or the digital devices which will be forming part of the network should be certified by them, and after testing there will be kind of rules and some SOPs made, then only they will be permitted to be part of the network for deployment in the India. So since your area is on this research security, so I would request if you could consider to collaborate with the NCCS.
Okay,
Since
yeah,
their
definitely.
sensitivity is wanted academia and the research.
Yeah, thanks for sharing that. Yeah, I am definitely open for such collaborations. Any questions from anyone online?
Yeah, so let me see if there are questions.
Yeah, there is a question actually. Sundarshi, you can present it.
May I flash that question on the screen?
Yeah, if
Yeah,
can you show
please.
it on the,
Sure, sir.
I don't think.
Here.
Yeah, you can see on the screen.
In Mirai botnet attack, the DDoS was executed on the basis of Roy had password exposed, which brought down the DNS service. How does UE devices orchestrate to configure the organized attacks? Yeah, that's a good question. So the concept of UE devices have evolved over time. Okay, so these raw IoT devices, which were compromised by the Mirai botnet, which brought together and then launched the denial of service attacks. So now they can also be easily orchestrated in 5G networks. So when the UE devices are our probably mobile phones, probably such attacks were not possible. But now that we are thinking about the UE devices, which will be IoT devices, let's say the same cameras that were utilized to launch the Mirai botnet attack. Now think of the same cameras connected to the 5G network, and now the same cameras being affected by something like a Mirai botnet. So now the same cameras could be utilized to launch are the UE devices in the current architecture, and they could launch the very same attack. So that is something that needs to be taken care of. Okay.
I think, yeah, that is done.
Okay.
There are no more questions, I think.
Okay, good.
No more questions, sir.
So yeah, I think there are no more questions. Let's thank the speaker for this wonderful
Thank you.
session. So with the insights given by Professor Vireshwar, now if you see the interesting is the topic is really very interesting, and though we do not I think not very much familiar with this kind of the standard driven research, or maybe the data sustainable data driven society with the term itself. But after listening this talk, the one interesting thing that was coming into my mind, if you see, this is something which we probably came across every day in our life also. Definitely I'm not going to speak very technically, but if you see, many times we see some rules or protocols coming from the top, and then we say, what is this is not going to work. What we need is this, not this. Where exactly, I think the point where we feel that actually probably the data was not properly collected, and to form the rule or network, right? And when I say this, so I feel the ultimate aim of this data collection is to eventually improve the system, right? Saying this recalls me a very famous saying in Hindi literature, I hope those who understand the Hindi will appreciate it. That निंदक नियरे राखिए आंगन कुटी छवाए बिन पानी साबुन बिना निर्मल करे सुभाए. What does it mean? That those who give you kind of harsh feedback or the true feedback, you should keep them with you, because without consuming the resources, they can actually improve your system. And this is actually the modern data-driven sustainable society, I believe. So if you see, the topic is very important, and probably our ancestors have already foresee that this is going to be very important, and that's how the today's topic. So, okay, by saying this, now we move to the second speaker of the session. How can I access? Yeah. So let me introduce the second speaker of this session, Mr. Abhishek Kumar. Currently works as big data consultant for Ashland Edge Private Limited, and responsible to advise company about the big data strategy, the implementation of big data, which technologies best fit the needs of the organization, and even implements the selected big data solution. I hope I have announced the company name properly. Okay, so let's welcome the speaker. Sir, please come. Yeah, I need to play the presentations here. Yeah, first I would like to thanks to the IIT Guwahati and TSDSI to give me an opportunity to share my exposure about the artificial intelligence and how artificial intelligence can make the telecom industry and other industries more sustainable, trustworthy, secured, and resilient. Then, before discussing about these aspects, I would like to speak about the advantages of artificial intelligence in different areas. Would you share the slide, please? Thank you. Yeah, please next. Yeah. Then how AI comes with the revolutionary changes in the world. Then there are different areas where the AI can be work to make a drastic changes in the world. The first of one, the automation. When we talk about the automation, then the self-driving car, chat GPT come into our mind, where it works on the natural language processing, and it works on the text mining. Everything I can input in the text, as in the text format, to the chat GPT, and it will give us the relevant output from there. And that Tesla works on the self-driving car to make the car automated, but it will impact the job market. And if we talk about the healthcare system, then in the healthcare system, uh, we know the nanotechnology. If we embed the nano chips inside the capsule, then if we intake it, and then it just go inside the body and take the images of different organs, and once we collect that image data and analyze it, then we can find out the suspicious organs which going to be the cancerous. And we have the AI enabled robot as well, which is capable to perform the surgery. Okay. And if you talk about the education, then these tools can help the teachers to identify the area where the students are struggling and provide the targeted interventions. And of course, for the environment, we know AI work for the weather forecasting. Okay. And we can also collect the data from different sources like sensor data, by which we can analyze it, and we can predict about the disasters in the environment. And at the last but not least is a business, because the maximum machine learning and artificial intelligence is working in the business part to make a smart decision taking, to find out the business problems, to find out the solution of the business problems. Please next. Yeah, now I talk about the sustainability, trust, security, and resilience in the telecommunications.
Not only telecommunication, we artificial intelligence can be applied to any industry to make it sustainable, trustworthy, secure, and resilient. The telecom industry has undergone the significant changes in recent years due to the advancement in technology and the increasing demand for the digital services to maintain the sustainability, trust, security, and resilience in the telecom industry. If I talk about the sustainability, then AI can optimize the energy consumption by predicting the demands and adjusting the supply. For example, analyzing data from the user behavior and can predict the when traffic likely to be high and allowing the telecom to supply the more energy to the high demanding devices. And if some devices are not uses the more energy, then it can shut down the devices, okay, and make it sustainable. And when I come to the trust, then AI can help build in various ways. For example, AI powered chatbots, which help the customer services to provide the accurate and more precision outputs to the customers. And if I talk about the security, then telecom industry and AI can help the mitigate risk, and AI can monitor the network traffic in real time, identify the unusual patterns, flagging them for further investigations. By doing so, AI can help reduce the likelihood of the breach. Additionally, AI can add the threat detection by analyzing pattern across the networks, identifying malicious activities before it can cause a significant damage. And finally, AI helps the telecom companies to remain resilient, to find out the disaster response by analyzing the by quickly analyzing the data in the real time. Next, please. I will show you through pictorial because big data analytics and AI is the ultimate solution or the best approach to make the telecom data driven sustainability, trust, security, and resilient. uh, this, if we look into the picture, then at the leftmost side we have the different type of data sources, telecom data. It may be the customer data, CDR data, BTS data, BSC data, MSC data would be. And connector layers is nothing, it's a collection of data pipelines where we have the streaming data pipelines, batch data pipelines, and by the help of these data pipelines we collect these data into a single data lake. And data lake is further segregated into two parts, is the batch layer and streaming layer. In the batch layer we will process the batch, store the batch data, and process this data using the Hive tools. This is a distributed data warehouse system. And once we process the data, we will get the batch pre-compute view. And same as in the streaming layer as well, using the Kafka we can ingest any streaming and real-time data and ingest it into the speed layer. And by the use of the Spark streaming and the Spark machine lib mlib library, we can transform it and we can get the streaming pre-compute view. Then finally we will ingest the pre-compute streaming pre-compute view and the batch pre-compute view to the serving layer. Serving layer is the nothing, it's a collection of you can say the NoSQL database, or it is the main operational database from which our application and BI tools are integrated to perform the reporting and analytics. Then this serving layer would be any auto scaling, auto sharding database like HBase, MongoDB, Cassandra DB, which is 100 times faster than the traditional databases approach. Next, please. Yeah. Now, how data-driven approach solves real-time problems using AI and ML? Our data-driven approach to solve the real-time problems using AI and ML involves using data to train machine learning models that can use to make prediction or take action in real time. That's mean in business use cases we need to predict the business problems. Okay, then how we can do so? There are several steps which we need to follow. The first of all is a defined problem. Defined problem is nothing, we need to choose some use cases from any domain, like to find out the telecom customer churn in a geographical area, in a different geographical area, or to find out the fault detection of a device or classification of device, these kinds of things. Then once we define our use cases, then we need to go for the data engineering part, where we need to collect the different data from different sources and have to put into one staging area to analyze it and get informations from there. Then after that we need to perform to we need to prepare the data by pre-processing the data, where where we need to perform removing the missing values, removing the outliers, removing the null values, or perform the data conversions. These kinds of technique will be happen in the pre-processing of data to prepare the data for machine learning. And then we train the model. Once the data is prepared or pre-processed, we will feed that data to the machine learning model The machine learning model would be the supervised learning, unsupervised learning, or reinforcement learning, or deep learning might be. Okay, any model will be there, but you need to feed the prepared data there to get the accurate value. And once that model will be trained, then we will validate the model by by some techniques like cross validations and hold out testings. And once the model is validated, we will deploy our machine learning or artificial intelligence model in the production, where our model will integrate it with the different data sources. And at the end, we will monitor our model over the time, because once the time will be passes, the model accuracy will be degraded. Then we should monitor our model by using the ROC and AUC curve to find out the efficiency of model. Please next. Yeah, this is the pictorial overview of prediction system architecture to solve the business problem. See, at the left side, there are different types of telecom data: customer data, towers and complaint data, network logs, CDRs, and IMI data. We have the scoop, flume, Kafka. Different types of pipelines are there, and then we store the that data using the pipelines onto the SDFS and Spark. Then these first three parts are coming to the data engineering part, and the last three parts are coming to the data science or the machine learning part, where finally we load the data from SDFS and Spark to the Hive data warehouse, where we will perform the feature engineering. Feature engineering is nothing, it's the extraction of the relevant features to reduce the dimensionality of the data, to get the more accuracy value from there. Then we will perform the transformation on the data and selection on the data. Then finally we will feed that data to the our algorithm, whatever the algorithm will be here, like a classification algorithm will work to find the churn prediction of the customer. Next please. Yeah, now I will talk about the data driven sustainability in telecom. There are different types of use cases which are comes under the sustainability in telecommunication. The first one is the energy efficiency. One way in which the AI can use in telecom to promote the sustainability in by optimizing the energy efficiency. AI can use to analyze energy uses pattern and identify the areas where energy can conserve. For example, AI can use to automatically turn off equipment that is not being used, or adjust the power uses based on the demand. And the second one is the network optimization. We can also analyze the customer data, network users data, make correlate this data, and also optimize which customer is facing difficulties to use the networks. And we can also perform the resource allocation, predictive maintenance, sustainable sourcing, and recycling. These are the different use cases which are comes under the data driven sustainability. Next please. If we talk about the trust, then obviously once the sustainability come into the picture, then trust will come into the mind of customer. Okay, then first is the data security, because without data security, customer trust will not come to the service provider. Then first, the data security. AI can use to enhance the data security in telecom industry by analyzing the network traffic and data logs. AI can detect the potential security breaches and help prevent unauthorized access to the sensitive data. And the second one is the fraud detection. We can also perform the fraud detection by analyzing the customer data and the network uses, and AI can identify the patterns that indicates the fraudulent activities, such as the stolen and the cloned SIM cards as well. And customer services, AI can use to improve the customer services in the telecom industry as well. AI can identify potential issues and help the customer service representative proactively to address them. And personalizations and transparency is also available. The different two more use cases are there, but data security, fraud detection, and customer service are more prior use cases of the trust and telecom. Next please. Now at the end we come to the security. Then in security we have first the threat detections. Then by analyzing the network traffic and log data, AI identify the anomalies and suspicious patterns that indicates a potential cyber attack. That's mean it works on the pattern detections or behavior analytics. If some user are doing some different patterns or some different behaviors from the real user, then AI will predict these patterns and behavior and find out that value, and give an alert to the system. Then there was some suspicious activity. And the second one is the fraud detection as well, and the password security. We can also use the intelligent password security, where AI will inform us to make a strong password, and AI can identify the potential weak points and encourage the users to adopt the stronger password policies as well. And we can also work with the threat intelligence. AI can use to analyze the threat intelligence of data, and provide the insight into the latest security threats facing the telecom industry. This information can be used to develop better security protocols and prevent the future attacks. Yeah. And finally, we are come to the resilience. In the resilience of the telecommunication, the most prior use case is the predictive maintenance, or the e-maintenance. In every infrastructure and data centers, the site engineers and maintenance engineers will go to the site in scheduled time, and check for the logs of the sensor and devices, and if some warnings are there, then troubleshoot by them. But if we use the artificial intelligence, then AI will collect the all sensor the data, log data, and device data, correlate it, and predict the fault detection before it going to be happen. Okay, and then the alert will be going to the corresponding department or the site engineers. Then site engineers will go to the site before the fault going to be occurred. And the second one is the network optimization as well, is the second use case of the resilience in the telecom. AI can be used to optimize the network performance, making it more resilient to network failures. By analyzing data from network sensors, AI can identify area of congestions or potential bottlenecks, allowing network operators to optimize routing and reduce the impact of network outages. Then the third use case is very important, is a disaster response, which comes into the telecom resilience. In event of the natural disaster or outage emergency, AI can be used to respond quickly and efficiently. For example, AI can be used to analyze the social media data to identify the areas that need assistance, allowing telecom companies to prioritize their response efforts. And apart from this, we have also cyber security and customer services come into the resilience part. This is also a use cases of resilience in telecommunications. Next, please. Yeah. Then I just took an use case from resilience system, as I discussed previously, predictive fault detection system development. Okay, this is the automated system. Then in order to build the automated fault detections predictive system, telecom industry big data platform must be employed. A data lake solution where Hadoop platform is right option, because it is free and open source framework. Why we are going for the Hadoop? Because Hadoop comes under the Apache 2.0 licensing, and we are capable to change the source code of the Hadoop to make our own product. Apache allow us within the Apache 2.0 licensing. And Hadoop platform has a variety of open source systems and tools related to the big data, which can be easily integrated with each other. Actually, Hadoop is not a technology, you can say it's a framework. It's a collections of different big data tools. You can see, look into the picture, there are different types of tools are there. In the data management, we have the HDFS. In data access, we have the Peak, Hive, we have Storm, Solar, we have Spark. For security purpose, we can use the Ranger, Knox, Atlas, SDFS in password encryptor. For building the pipelines, we have the Scoop, Flume, Kafka, SDFS, and Web SDFS. To perform the data governance, to monitor the life cycle of data, we can go with the Atlas and Falcon. Then I will discuss about these tools on further slide. Yeah. The first tool, this is not mean that once we are installing the Hadoop system, then we need to install all the tools available in the Hadoop framework. We can only install those tools which are required and relevant for our project. Then the first tool is HDFS. HDFS is nothing. It's a data lake solution. It's a distributed data lake solution where we can store the data in distributed manner. According to the block size, the data will be divided and stored into a different nodes. Because once we will lose our original data chunks, then we will get our data from different nodes as a backup. And if you talk about the yarn is nothing. It provides the containerized computations in Hadoop system, and we can say yarn is used as an operating system of Hadoop system. If we talk about the Spark, it's a very powerful execution engine which works in the in-memory computations. It is capable to process the billions of records in few milliseconds. And if we talk about the Hive is nothing. It's a distributed data warehouse system for batch processing of data. And previously we had approach about the traditional system where we are work on the scale up approach, where we need to add on the storage when storage getting full. But this is the scale out fashions, scale out data warehouse, where we can add the new nodes to the cluster to increase or enhance the storage. And if we talk about the Japan notebook, it's nothing different from the Jupyter notebook. It is same as the Jupyter notebook to play with the data as for data science workbench. And if we talk about the Kerberos and Ranger, then Kerberos and Ranger is used for the data authentication and authorizations to secure our platform. And if we talk about the Kafka and Scoop, then Kafka and Scoop is used to build the data pipeline, batch data pipeline and streaming data pipeline. Kafka is generally used to develop the streaming data pipeline, and Scoop is used to develop the batch data pipeline. And finally, the Uzi is used for the job orchestration of big data, where we can orchestrate the big data jobs, and it's based upon the DAG, directed acyclic graph, which is very capable for the lazy evaluation. And at the end, Ambari Hadoop also provides you a Ambari web user interface to manage and monitor the entire data lake cluster. Yeah, see, this is the data lake and pipeline architectural design. Look into the picture. Here two different sources, batch sources and streaming sources, and two pipelines are there, Scoop and Kafka. By this pipeline, we are ingesting the streaming data and batch data to the batch layer and streaming layer. And once the data getting processed, both the pre-compute views are finally ingested to the serving layer. And once the serving layer here will act as an operational database, which is integrated with our BI tools and applications for the reporting and analytics. This is actually the architectural design of our data cube product, which where we are working to develop it. Next, please. Yeah. Now, fault detection model development using artificial neural network. Then in case of telecom fault detection, ANN can be trained on historical data of telecom system to learn what normal network behaviors look like. The ANN can then use this learned information to detect the anomalies for the fault in real time, because the ANN is tested and experimented algorithm to find out the fault detection, because it works on different layers. Multiple inputs are come into this layer, and the output of one layer will act as the input of other layer, as seen in the picture. Yeah, then how to develop a fault detection model. Then artificial neural network can be used for fault detection in telecom system, and machine learning algorithm that can learn patterns in data through training, and can then use those patterns to make the prediction or classification of new data. The first one is data collection. As we discussed previously, first of all we need to collect the data to perform the analytics on that. Okay, then second is the pre-processing. Then for the fault detection and fault detection model development, we need to collect the network device, sensor and device logs. Okay, and after that we need to process it by removing the outlier, missing values and noise from the data. This step is very crucial to ensure the quality of data. Then after that we will perform the feature extraction. Extraction is nothing. We are integrating the multiple different data sources and ingest the different type of data sets, and we are selecting the relevant features from different data sets and make a single data set which is clean data set, and finally feed to the machine learning algorithm. And in ANN model training, train the ANN model using the pre-processed and feature extracted data. The training process involved adjusting the weights of network to minimize the error between the predicted output and actual outputs. And finally, we will get the fault detections. Once our model is trained, then we will deploy our model to the real time to get the fault detections. I will explain it by pictorial diagram. See, uh, The first three parts is the data engineering part. As I discussed previously, we have different sources. At data ingestion layer, we have the Scoop and Kafka to integrate that sources and ingest the data into the Spark and HDFS. Once the data is stored on the HDFS and Spark, this will loaded onto the Hive data warehouse. And from that Hive data warehouse, we will perform the batch processing, where we will perform the feature engineering to find out to select the features of different data sets. Then we will perform the transformation. Then after transformation, we will feed the clean data set to the ANN and the BPNN algorithms, and we will iterate this process multiple times to get the high AUC value or high accuracy. Once we will get the more than 90% accuracy, then we can go for that model, okay, to find out the fault detections. And finally, this is the ROC and AOC curve to find out the fault detection model, where we know over the spanning of time, the model getting degraded because different data sets are going there, and the model getting and model is not unable to understand the data patterns. Then this is the best technique, ROC AOC curve, for fault detection model performance validation. Here, AOC ROC curve performance measurement for the classification problems at a various threshold settings. ROC is probability curve, and the AOC represent the degree of measurement of separability. It tells how much the model is capable of distinguishing between the classes. That means how the better model is distinguishing between the devices are workable and faulty. It will make the classification between the workable devices and faulty devices, and get the measurement of our model accuracy. And I think this is my final conclusion. As we had discussed previously, sustainability, AI can be used to optimize the energy consumption and reduce waste in telecom industry, making it more sustainable for the environment. And if we talk about the trust, the AI can be used to enhance the data security, prevent fraud, personalize the customer experience, promote transparency, and build trust in the telecom industry. If we talk about the security, then AI can use to detect the prevent cyber attacks, protect the customer data, and manage access control in telecom industry. And of course, once we talk about the resilience, then resilience is just used to find out or predict the disasters which going to be happen in the telecom industry. And before disaster, the resilience will predict the this scenario, and we will take a measures for that. Thank you. This is completed from my side. If you have say, any questions, then I will try to clear it.
Thank you, Mr. Abhishek. I'll request my co-chair to. There is one question. I'll request my friend Mr. Saha to take that question up. Sahaji?
Yeah. Thank you, Dr.
Yeah, it's how
Sundarshi.
do we say that the data is real time even in streaming data using Kafka, not batch data using SDFS. I also want to know the rough scale to estimate the cost which any virtual private clouds on the cluster or a telecom system models. Yeah, we can say SDFS is not just used for the actually batch processing. Actually, we are using the Kafka to build the streaming data pipelines. And once we get these data pipelines, then we can put it into the SDFS, where we can perform the Spark streaming application to perform the real-time analytics. Am I able to address you?
No, this is.
Yeah. I think you have answered the question. Thank you. I think there is actually one more question. Asif, if you can put it up. There is one more question.
Do we use the developed tools for automating CI/CD pipeline? Like, yeah, of course, you can go with to develop the automating CI/CD pipeline operation like Docker. Actually, Docker and Kubernetes is for the containerization purpose. If you want to going for the CI/CD, then you can go for Jenkins. Jenkins is the best options for CI/CD pipeline, and Ansible as well.
Okay, thank you. Actually, I had one more question. I think it was a very comprehensive, presentation, and thanks for presenting all the thoughts on, how AI will address different aspects. I had a very simple question on because you mentioned about data processing. So, are there any measures that you take internally to remove bias and discrimination when you are collecting data?
It's not. Ma'am, can
Not
we
audible.
increase the voice?
Yes, actually, you are not audible properly. Your question.
Oh,
Can
okay,
you write
okay,
down
okay.
it?
Yeah, I can write. Where should I write? Okay, I can write in the Q&A. Yeah, my question is, how do you remove bias and discrimination? Okay.
Apart from this, there is another question in the chat box also, sir.
Yeah, maybe you can go ahead and present that.
Okay, lots of.
Somebody can help me how we can
How
access
can you integrate data warehouse AI system explained with the NWDEF in 5G SA in telco space? Yeah, Mr. Prajit Paran, right? We can use the Hadoop system to do that. Okay, because Hadoop is a framework which is collection of different tools, and we can go with the Hive system. Okay, if we you are developing only batch processing data platform, and if you wanted to make the only streaming data platform, actually in the big data platform we have two types of architectures. The first one is the Lambda architecture, the second one is the Kappa architecture. In Lambda architecture, we can perform the batch processing as well as the streaming processing. Both type of options are there. Okay, that's mean you can ingest the batch data as well as streaming data. Okay, then and if you want to perform the only real-time analytics, then you can go with the Kappa architecture where you have only platform to process the real-time data. You do not need to store the data for the very long time. That is a CPU intensive system, not a disk intensive system. Am I capable to address you, sir?
Yes, I think it has been answered. Thank you.
Yeah.
Yeah, this is actually my question. Thanks for presenting. I think.
Is this one? How do you remove the bias and discrimination in the data processing stage? Yeah, we will perform the outliers detections, remove the outliers. We will remove the null values from there. We will convert some data types, like if some data types in the date, then we need to convert it into the string to find out the values. We will convert some value in numerical category as well. Then by this way we can perform the to remove the bias and discrimination in the data, to reduce the dimensionality, as well as we can also perform the feature engineering as well, to extract the features from different data sets and make a complete single data set, which is used for cleaning, and finally go to the machine learning algorithm.
Thank you. Thanks a lot.
Yeah, thank you.
Yeah, I think over to Dr. Sundarshi.
Okay, thank you very much.
Let's thanks to the speaker for the wonderful session, and this really gave us interesting insight how things are actually getting implemented in the industry. And so we have already taken few questions, and I think now there are no more questions. So with this, I announce the completion of this session. Thanks everyone, online participants as well. And um yeah, so the one announcement is we have arranged the lunch for everyone, and cabs are already there. So please use the cab to reach there, enjoy the lunch, and then we'll get back here by 1:50, right? Right. So we'll again resume the session. Thank you.
Thank you to all the online participants for joining.
Okay, welcome back after lunch. We had very exciting and informational sessions in the morning. I hope you all had good lunch. We have the next session, Industry 4.0 in Rural Health, and that is Goodbye to Digital Divide. So this is chaired by Ashok K. Talukdar. Can we go to next slide, please? Oh, really? Okay. Yeah. Okay. It says okay. Asif, Chandrakanta, can you please bring up the chair bios, please?
Can you see my screen?
Yeah, we
Mm,
can see the screen. Let me introduce Dr. Talukdar. I think
ah,
I'm the chair of the session.
yeah.
So,
Professor, just wait a minute.
okay, sure.
Chandrakanta, can you please bring up the chair's resume, please?
Professor Talukdar, can you unshare your screen first? Then,
Ah, okay.
sorry for the glitch. You can stop the sharing, sir, with the same button, third button.
No, we can continue with that. Is there any problem?
We would like to briefly introduce you, sir. That's why. If you don't mind. If you just stop sharing, we will give you back in a minute.
Okay.
Thank you. Uh, I think, are you able to stop sharing, Professor Rajarshi, please?
No, no. I think it's Professor Talukdar is sharing. So, what I did, can I introduce myself?
Oh, yes, please. No worries. Yes, thank you very much. Please go
Yeah,
ahead. Go
yeah.
ahead.
That I can. Okay, I think it's okay. So, you want to share, or I'll just go with that.
I think the sharing is available. Chandrakanta, please. Great. Okay, finally. Yes, we are very honored, and it's our pleasure that Dr. Rajashri Mahapatra is here. He's going to chair the session, and he's associate professor with the Department of Electronics and Communication Engineering at SPM IIIT Nayara, Raipur. He's also serving as Dean Academics of IIIT Nayara, Raipur. His current research interests include 5G beyond communications, machine learning for communications, molecular communications, intelligent reflecting surfaces, etc. He's awarded National Scholarship, MHRD Scholarship for Research, Framework Program 7 Fellowship for European Project. He's senior member of IEEE and a member of Communication Society. Once again, we welcome Professor Rajashi. It's our great pleasure and honor to be here. Thank you very much for chairing the session, sir. Please go ahead.
Yeah. Thank you, Vishnu, for the introduction. Let's. So, this session is about the defeat the digital divide. So in this standard workshop, so without wasting time, that we'll start our session. So the first speaker, we have a two presentation in this session, right? So first presentation by the Dr. Talukdar. So it's I'm just going to give a brief bio of him, then I will hand over the session to him for his presentation. So he is a co-founder of and a chief scientific technology officer of the
Thank you, Professor
Excite,
Mahapatra.
and yeah, and he also co-founder of the Cybernetic Care, and he's also he's a innovator, right? I can say a big entrepreneur. So he's a chief scientific CTO of the SRIT India Private Limited. So and he also work advisor of the ICI Lombard Health Insurance. He also work in a faculty in the IIIT Bangalore, and he also do some kind of adjunct faculty in NIT Surathkal and in NIT Orangal also. So he has experience in the industry as well as the academics. And he has published working in a lot of in the healthcare domain. So let's hear from him that how exactly that what is he going to present, that how the industry 4.0 is actually help us to the defeat the digital divide. So I like to welcome Dr. Talukdar and hand over the session to him. Dr. Talukdar, please. Yeah, you can please
Thank you
share.
very much. Yeah. Can you see the screen?
No, you just share that it will come, I think.
Can you see my?
Not yet.
Okay. So, uh, thank you very much, Professor Mahapatra, for the
Welcome, sir.
kind introduction, for this opportunity. I would also like to thank the
Not yet.
Sir, I think there is some signal issues.
problem. So, okay, looks like there could be some problem. In that case, maybe
Azim, you have a PPT?
you could share.
Yeah, Chandrakanta, please share his screen, share his presentation.
Yes, then.
I think go to the first slide maybe. So where the title of the slide, title of the presentation will be there. I think this is the third slide. Yeah, yeah, Dr. Lalula, you can start. We have shared the PPT. Yeah.
I cannot see the screen.
Can you see the screen?
It is loading in my case.
No, you stop sharing. We have shared, I think.
Sir, Chandrakanta is sharing on behalf of you. So,
It says Chandrakant
yeah.
Rathore is presenting to everybody.
Yeah, sir,
Yes.
there is some signal issues, I think, from your side. So, we are presenting on behalf of you, sir. You may
Okay.
proceed, sir.
So thank you very much for the opportunity to be here. So what I'm going to talk about is standards in healthcare. Next. Next slide, please. Skip it. Yes. So the point is that health is not everything. But if you don't have health or if you are not healthy, then everything is meaningless. So the question we are asking is that how do we standardize the healthcare service? Okay. Why? The reason is that each provider, which could be a doctor or a hospital, they have their own standards. One of the basic reasons of this kind of heterogeneity in the standards are that it helps them to continue the way healthcare is progressing now. So what I'm going to talk about, necessity of standards for medical necessity. I will explain what is medical necessity. Next slide, please. So let me share some statistics. And all these statistics are from US, but where documentation and publications bring out everything. So you can, from these numbers, you can make out what will be the scene in India. So medical errors are the third leading cause of death in US. Next slide, please. Drug side effects, they're the fourth leading cause of death in the US. That means drug-drug interaction, drug-disease interactions. Next slide, please. resistance is in a pretty bad shape, and that became worse during COVID pandemic of 2 years. And it has been estimated that by 2050, which is about 30 years from now, due to antibiotic resistance, the patient will die from sepsis and other things more in number compared to cancer. And this will cost the world $100 trillion. $100 trillion. Next slide, please. It is estimated that this year, the patient harm, I repeat the word, patient harm, the value of that is 383.7 billion US dollars. Next slide, please. In US, the wastage in healthcare is $935 billion. Pakistan is struggling to get $3 billion to run their government. And here it is $935 billion, just the wastage in healthcare. Next slide. So the question I'm asking is that why? Why do we have these problems? Simply because there is no standard. Everybody has or have their own standards. Define what is hospital decide what is how is and what standard when is industrial cost, quality control, be it in the and standards in the because of that means the patient in healthcare hospitals all you always win the merchandise, and if there is a problem with that merchandise, manufacturing defect or something, you can return that merchandise. Can you do that in healthcare? No, because there is no standard. And as I said, it is always head I win, tail you. And that you is the patient. They're paying the money, more money, and finally, they are blamed for any fault happens at the hospital or at the doctor. Next slide, please. So, what are we talking about? How do you address this standard issue in healthcare? So, one of them is Industry 4.0. I'll just briefly take you through the journey. Industry 1.0 was the days of steam engines, and Industry 2.0 was electrical power. Industry 3.0 was primarily computing and things like that. Industry 4.0 is about internet and 5G and 6G or whatever you would like to talk about. Next slide, please. So what are the challenges? Why we are talking about this? First of all, we call it evidence-based medicine. But the evidence, which are the journal papers and publications, look at the number. They double every few months. So today you have millions and millions of evidence. You don't know which one to take, which one to use, which one not to use. And there is a gap between the study and the practice. It takes 17 years from a research, from the desk, to reach to the clinic or to the operating room of a hospital. Healthcare stops, whether it is doctor or nurses, they are leaving the profession, and that became worse during the pandemic. Physician density is not increasing. That means the number of healthcare providers for 1,000 people in the population, that is not increasing, even though population is increasing. Non-communicable disease and late onset diseases are increasing in an exponential manner. Cost of healthcare is skyrocketing, high medical errors, high drug side effects, and very high gap between a junior doctor and a senior doctor. And you don't have the money and time to go to an expert. So, how do we solve this problem? The message I would like to carry home is that we need standards. Next slide, please. Okay, so Industry 4.0 in healthcare, which will be digitization, number one. So we need digitization in healthcare. Right now, it is all paper, handwritten. So we need digitization in healthcare. Next generation web, I'll talk about it in a moment. 5G, 6G networks, AI, which is artificial intelligence, then digitized knowledge. So we have to take the knowledge out of the doctor's brain, put it on a machine. I will tell you how. And then we need to standardize. Then Internet of Things, primarily for medical devices, machine learning and AI, big data mining, and augmented reality. Next slide, please. So what is next generation web? Now, some time ago, we had desktop computers and laptop computers. But today, if you see, web is, some time ago, it was a passive interface where we used to use web to publish something. But web is changing. And in web, the browser is going to be an active device and doing all the computations. For example, WebRTC, real-time communication. Real-time web, it is secured, it is having ultra-low latency, end-to-end encrypted, peer-to-peer communication, it is 5G ready. Another one, web USB. From a web browser, you can access the USB in your machine. WebSocket, we have a new socket which helps browsers to talk to each other. We have web speech. I'm sure many people in this audience and even in the speaker, they have used it. In the web, they speak and it gets written into a text, which is speech to text. Then you have WebGL, graphic library. You have Web AI, example, Google Translator. You can speak or give a passage or give some text to Google, it will translate it to any other language you want. Chat GPT, and there are many other examples. So the point I'm trying to make is that web is going to be the device for communication between human beings through the web browser. Next slide. And how is this transformation going to happen? It's going to happen through digital twins in Industry 4.0. And what is a digital twin? It's a digital representation of a physical object where we have taken the data and put it into the computer. Advantage, we can use it, simulate it, and do many other things which were not possible earlier. If you want to use AI in healthcare, you need the digitized data and digital twins. And here are three examples. Physician's brain digital twin, then person or the patient's phenotypic digital twin, and genotypic digital twin. Next slide, please. Goodbye digital divide. With 5G and next generation web, you can now take healthcare to the remotest part or of the world, what we call the underserved. If you have the communication channel, you can take it. So on the left, if you see, that is a combination of symbolic and non-symbolic AI, or sub-symbolic AI, sorry, sub-symbolic and symbolic AI, which is practically symbolic AI and neural networks. Then you have the AI layers, and then you have the reasoning. So the reasoning, which will be workflows, and those will be pathways which are connected to the computer understandable knowledge. So I'm talking about not the data, not the information, but knowledge. Next slide, please. So now I'm going to talk about the standards for homogeneity in knowledge, which is the biomedical knowledge. And I call it physician's brain digital twin. I just introduced digital twin. Now I'm talking about the digital twin of physicians, plural, not a single doctor or a physician. So all physicians combined in the world, all their knowledge is now put into physician's brain digital twin. Next slide, please. Our paper on physician's brain was awarded the best paper in international conference in international Madrid. Here on the right side, on the left. And what is it mines? It mines the knowledge from PubMed and all the technical literature, including textbooks, and then combines with various ontologies. Ontologies are there for quite some time, and ontologies are the representation of the knowledge in machines, in computers. So, what we have done here, we have taken the ontologies and then combined that with patient data from hospital and the knowledge from textbook and all the published paper till June of 2022. So all those knowledge has been mined, combined, and then put it into a graph database. I repeat, a graph database, exactly like in our human brain. Our knowledge comes from the connection between the neurons through the synapses. So here we simulate that into a machine. Next slide, please. So in October, we have published a journal paper, which is disease omics, which includes disease ontology and few other ontologies combined with patient data from hospital and then other knowledge from Wikipedia, PubMed, textbooks, and many other sources. Next slide, please. And here is an example of disease omics, how it works. So this is the user interface on top of the knowledge graph. On the left, you can see that there are some symptoms which the doctor enters, which are human understandable, I repeat, human understandable English language or natural language. So the doctors or the healthcare provider at the primary care says, okay, these are the symptoms, type the symptoms, and then say, okay. And then what it does, there is a complex natural language processing AI system which takes all those English keywords and then convert them into machine interpretable vocabulary. So here are three vocabularies: SNOMED, ICD, and UMLS. And you can see there is a moment, please. on to see the screen is just one. Okay. You can see
Dear,
that I'm not able to see me,
dear sir,
but you can see
sorry.
here that
Yeah, dear sir.
hemoptysis is the doctors use that coughing blood and is the cause. So there is AI, very sophisticated, is practically the same, like high blood pressure and hypertension, or high blood sugar and diabetes. So one is a 3 word, another is 1 word. Like as I said, diabetes is a single word, whereas high blood pressure are 3 words, which we call engrams. So all those engrams have been and here that the code understands it properly because they have been interpreted and normalized to the same vocabulary. And then we take this, look at the knowledge graph, which is running on a cloud. From there, it says these are the possible diseases. And the beauty is that here you can see even a cancer is a possibility having such kind of symptoms. And I tell you, anywhere in the world, whether it is US, Europe, or in India, cancer is detected at a very, 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 very late stage. Why? Simply because cancer is never identified or detected at the primary care. The patient runs from pillar to post for years and years and years. It takes 5 to 6 years for the patient to reach a tertiary care, cancer care, and then it is too late. Only because there is no knowledge at the primary care. And that is exactly what I'm saying, is that we need to have a standard of democratization of knowledge, democratization of biomedical knowledge, which is clinical knowledge and many other stuff I will just take you through. Next slide, please. So this is during COVID, we authored an article which is that how to prevent this antibiotic resistance. And WHO discovered our paper. They put it on their website by saying that COVID related publications, which are very important. Antibiotic resistance is in a very, very bad shape. Today, antibiotics don't work. And you know, the superbug, where India is the capital, in hospitals, ICUs, patients are dying because they are antibiotic resistance. Antibiotic resistance tuberculosis is highest in India because we are abusing use of antibiotics. Left, right, and center, we are using it. Somebody goes with fever to a doctor, doctor immediately says, okay, take 4 antibiotics, even though it is a viral disease where antibiotic will not work. So abuse of antibiotic drug has brought us to this stage. Next slide, please. 2 years ago, 2021 in November in US, we presented what we call onconomics, which includes all cancer knowledge in knowledge graph in computers, where we have taken NCI thesaurus, ontology, combined with cancer patient data. And then we publish this, which is onconomics, all knowledge of cancer, which is available today at the primary care. So that at the primary care, at a very, very early stage, from the symptom, the doctor can say, it is time for this patient to go out of my income profile. They don't recommend or they don't refer the patient to a specialized care. And finally, they do when it is too late. I don't need to tell many stories about it. All of you know. Next slide, please. Dragomics, it was presented 2022 December, which includes all knowledge about all drugs available as of today, licensed drug or prescription drugs. We have not included non-prescription, that OTC out of the what is that OTC out of the counter medicines does not include, and it includes drug and drug disease interaction. Let me just tell you what, because it is the fourth leading cause of death in US and India, it will be also of the same order. Now, I'm sure in this audience there are many people who take more than 5 drugs a day. If somebody has diabetes, then after some time there will be, diabetes is part of metabolic disorder, so they will have kidney problem, they will have other problem, retinopathy and many other problems. So for each and every drug you take 1 or 2 drugs, so which we call polypharmacy. Also, when you go to a doctor for a condition, doctor treats you for that condition for you went to the doctor. A lot of time, the doctor doesn't know what are the comorbidities or multimorbidities you have. So there is a drug-disease interaction. In polypharmacy, it is drug-drug interaction where they interact and they react. And as I said, so this is a knowledge graph where we have all drug-drug interaction and disease-disease interaction. Next slide, please. Here it is an example of explainable AI, and this data was taken from AIIMS, All India Institute of Medical Science in Delhi, from the pediatric ICU for antibiotic issues. So it is an explainable AI using Bayesian network. We found out that how antibiotic resistance are happening in the intensive care unit of AIIMS at Delhi. Next slide, please. And then I talked about next generation web, and all those things have been included and integrated and delivered to the primary care through WebRTC. And you can see here the doctor and the patient, they are talking to each other over a audio, visual, and data link. And here all the digitized and digital data with the knowledge is available at the fingertip of the doctor and the patient. The chances of error is minimum. The chances of wrong drug is minimal. It also has antibiotic resistance. If somebody is prescribing an antibiotic through antibiotic stewardship program in this system, will alert by saying this is not the right drug. Next slide, please. So here it is WebGL I talked about. I'm not going into detail. X-rays from DICOM. It's in 3-dimensional, getting presented through web. Next generation web. Next slide, please. Here it is. I also talked about molecular. This is a multi-omics work which we have done a long time ago, where you include DNA, RNA, protein, and n number of other data, combine it together to treat a patient faster and better at a cheaper or a lesser cost. Next slide, please. So this is most probably my last slide. Standards for medically necessary. As I said, every provider, they have their own standards. If you go and ask them that why my mother died, when he entered into the hospital, he was pretty joyful, he came walking. What happened? Hospital will give you 20 different excuses. So we need a standard for right care, for the right patient, at the right time, at the right price, for anybody, anywhere. That's the message I'm trying to communicate, with zero wastage, zero error, and zero patient harm. Not hundreds of billions of dollars. We don't have the luxury to waste the valuable resource. So we need to have a standard for medically or medical necessity so that there is no overtreatment. And I'm sure almost all of you have experience. The moment you go to the doctor
Doctor,
prescribes you 20,
hello,
50 risks.
hello, doctor. So, can you hear me?
Yes,
Hello? Yeah, can we conclude? Actually, we are running late, almost 10 minutes.
yes,
Can we conclude in the next 2
yes.
to 3 minutes?
So precision health standards. So
Thank you.
next slide, please. Thank you very much. Here is my email ID if you want to contact. And because we are running out of time, thank you for your attention. And I would like to conclude by saying we need standards for healthcare because health is not everything. But if you are not healthy, everything is meaningless. So we need to be healthy. And for that, we need standards in healthcare. Thank you very much.
Yes, Ikant. Yeah, thank you, Dr. Talukdar, for your nice talk. I think TSDSI may be looking after the setting up a standard board for this healthcare. So we can go for the next speaker. Ikant, you can?
Yeah. Thank you, Dr. Rajashi. I'll take over from here. Thank you. Can you
Sure.
hear me?
Yes, yes.
Dr. Rajashi, can you hear me? Dr. Rajashi, can you hear me?
Yes, yes, we can hear you.
Okay.
Please.
Kashyap, please bring the introduction. Thank you. So, Professor Salil Kashyap is an assistant professor in the Department of Electronics and Electrical Engineering at IIT Guwahati. His research spans areas of wireless communication, and he's very actively working on resource allocation problems in massive MIMO OTFS and UAVs also. Before joining IIT Guwahati, he was a senior DSP engineer at Marvell, where he designed physical layer algorithms for next generation WLANs. Without taking too much time, let me invite Dr. Salil Kashyap for his talk. Thank you.
So I think I have 15 minutes, 15, 20 minutes. Okay, good. Ma'am, can my slides be displayed? Oh, and I can change from here?
No, sir.
Oh.
You just have to say yes.
Okay, fine. So I should stay like this? Yeah. Okay, so good afternoon, everybody. I'm here to talk about intelligent reflecting surface aided wireless energy transfer in beyond 5G IoT networks. Yeah, so this is joint work with my PhD student Chandan Kumar and a faculty colleague Dr. Sarvendranath R. Another MTech student with me, Supreet Sharma. Can we have the next slide, please? Can we have the next slide? Yeah, thank you. Yeah, so as we understand that it is expected that billions of IoT devices would become a core component of next generation wireless systems. Yeah, the number of IoT devices, just to give you a feel for numbers, currently we have around 13.8 billion IoT devices connected, and it is expected that the number would rise to 30.9 billion globally by 2025.
So it is therefore important to understand that we need cost-effective solutions to basically provide reliable communication over the air. And not just that, we also need to provide these IoT devices with perpetual energy supply, since most of these IoT devices depend on limited capacity batteries. Yeah, and therefore there is a need to provide perpetual energy supply. Next slide. Yeah, so one potential solution is to charge these IoT devices wirelessly. Yeah, so wireless energy transfer is a promising energy harvesting technology in which these sensor nodes harvest energy from electromagnetic signals. One can essentially power these IoT devices without wires. It removes the hassles of battery replacement. Let us say these IoT devices are placed at inaccessible, uh, dangerous locations where it is not really convenient to replace the batteries quite often. Yeah, and it does increase the battery lifetime of these energy constrained IoT sensor nodes. However, we should understand that wireless energy transfer is a fundamentally different problem compared to wireless information transfer. And that's primarily because only a small fraction of the energy that is radiated by the source can potentially be harvested at the sensor nodes. Uh, this is primarily due to path loss and the limitations associated with the energy harvesting circuitry. Moreover, when we design such energy transfer networks, the design must ensure that we harvest more than the sensors harvest more than what they consume. So, furthermore, the receive power levels that are suitable for decoding may not actually be suitable for activating the harvester in these sensor nodes. Next slide, please. Can we have the next slide? All right. So one potential solution to tackle these challenges offered by wireless energy transfer is to use massive number of antennas at the base station. So one can essentially exploit the huge array gain offered by these massive number of antennas to boost the receive energy at these sensor nodes. So we have done some work in that direction. So basically, the gains that we achieve through multi-antenna beamforming can help power these sensor nodes. However, the drawback with these this solution is that it requires one radio frequency chain per antenna. Yeah, and these radios themselves are power hungry, they are bulky, and they are costly. In fact, Xiaomi very recently in 2021 has come up with a solution, a wireless charging solution, which is called MI Air Charge. Here they have a transmitter with 144 antennas, but then and as soon as you enter the room where this is kept, your phone starts charging wirelessly. So basically, this device can uh, provide charge of around 5 watts within a distance of a few meters. But then the size is so big, and so there are still several things that need to be done before it becomes commercially available. Uh, can we have the next slide, please? Next slide, please. So while we understand that radios add to the hardware complexity, the power consumption, and the cost at the transmitter, uh, there's something that is gaining a lot of attention these days, which is related to intelligent reflecting surfaces. This is being looked as or viewed as a promising 6G technology. Uh, so if we see here, these patches, these are like mirrors. Yeah, I mean, one simple way to understand this is these are mirrors. All they do is they so the phase of the incident signal can be programmed. All right, so the reflected signal phase can be controlled. All right, and so essentially one can induce amplitude and phase changes in real time. And if these green patches are appropriately programmed, one can ensure that the reflected signals through each of these patches that reaches the receiver adds up constructively, thereby boosting the receive strength. The advantage with these surfaces are they do not require dedicated radio frequency chains. At least the amount of power that would be spent in driving these surfaces would be much lower than what we require for a massive MIMO setup. So while one can live with fewer antennas at the base station and add more of these reflecting elements to achieve similar gains that can be achieved with a hundreds of antennas at the base station. All right, so this is an RF chain free surface, easy to deploy. Now, the key here is to design these patches or program these in such a way that the receive signal strength is boosted one can essentially obtain higher data rates, improved coverage. We talk about defeating digital divide. So this can definitely help improve coverage to regions where we have not reached so far. The cellular connectivity is not there. And this can as well be used to efficiently charge these IoT devices. All right. So in this talk, my focus will be more on charging IoT devices because that's what I have worked on. Can we have the next slide, please? Next slide. Yeah. So this is one problem that we looked at where let us say we have a source. Yeah. Where we have a source with multiple antennas but just a single RF chain, and the objective here was to understand whether we can trade off these antennas at the base station with in fact the objective. So we also extended this setup to subset antenna selection, where let us say we have uh, n antennas, n RF chains, where n is much larger than nRF. uh, Through our study, what we tried finding out was we tried finding out answer to the question if we can trade off active RF chains at the source with these passive elements at the IRS while maintaining the desired performance in terms of energy transfer. Yeah. So can we have the next slide, please? So can we have the next slide, please? So these were the key questions asked. What should be the antenna selection strategy? How should we really select the antenna depending on the channel gains? How should the phases of these black patches be programmed? What would be the impact of channel estimation error? Most of these patches, these are like designed so every patch can induce a phase shift, but then in practice how this is implemented is it is using a pin diode. Now if we have one pin diode fabricated on a black patch, it can at most induce two phase shift levels, so 0 and pi radians. So there is a trade-off. These patches cannot induce phase shifts in the range 0 to 2 pi. They have some precision. So depending on the number of pin diodes that can be fabricated, two pin diodes can, for example, give you 4 phase shift levels. And so what is the impact of discrete phase shifts on performance? We've looked at extensions to multi-user scenario, and the key question we are interested in was, can we trade off active RF chains at the source with these IRS elements? Yeah. So I'll skip the technical details, but I would urge people to look at most of the details are available in the paper reference there. Yeah. Can we quickly go to? So I'll skip the details in the interest of time because the sessions are getting a little delayed. We can go next. Yeah. So this is one slide which I would like to explain. So channel estimation is one important aspect of intelligent reflecting surfaces. The moment we have n patches, so most of the conventional techniques, channel estimation scales with the number of black patches that we have here. So a key challenge lies in reducing the estimation overhead, because we understand that the coherence interval has limited time frequency samples, and within the coherence interval the channels have to be estimated, and then the remaining time frequency samples would be used for data transmission. If we end up spending more time frequency samples on channel estimation, we will have fewer data samples left for data transmission. So we have looked at how to reduce the channel estimation overhead in this particular setting. We can directly go to the maybe the 23rd slide. 23rd slide. Yeah, maybe one slide back. Can you please go back? One more slide. Sorry, maybe it was 19th slide, please. I'm just picking up what to discuss in the interest of time. So this is one plot where what we have on the y-axis is probability of outage in wireless energy transfer. On the x-axis, what we have is the source transmit power. We plot this for different configurations. So C equals 1, 4 means the source is equipped with 4 antennas and a single RF chain. C equals 2, 4 means source has 4 antennas, 2 RF chain, and so on. So 4, 4 is a full complexity system, as many antennas as the number of RF chains. And we also plot this for 2 different number of IRS elements, N50 and 150. What we observe is that one can obtain improved outage performance by trading off active RF chains at the source with passive IRS elements. So in fact, if we notice, C equals 1 comma 4 comma 150 does better than C equals 4 comma 4 comma 50. So it can in fact beat full complexity system as well. So we don't really need to have multiple RF chains at the source. One can as well use these passive elements at the IRS as a proxy to obtain the desired performance and at much better power transfer efficiency. All right, so we can go to the 23rd slide. Thank you. Okay, so the standardization, or maybe 22nd one, 22nd, 22. Yes, thank you. So as far as the standardization aspect goes, so if we can see from this chart, the key takeaway message is that by now there are very limited indoor and outdoor field trials available, prototypes available. Reference number 12 and 13 are some of the works in that direction. Uh, the vision, theoretical research, and prototyping is likely to continue even beyond 2026. There are several fundamental problems that are still open as far as research on IRS is concerned. Yeah, and yeah, so from this chart, this is what we can understand. Yeah, can we go next? Yeah, so just to summarize, we looked at a problem where an IRS enabled source with fewer RF chains than the number of antennas performs wireless energy transfer. We looked at a setup where we proposed a joint antenna selection strategy at the source and passive beamforming rule, analyzed outage performance with both perfect and estimated CSI. Some of the key take-home messages, the key conclusions that we obtained was the antenna selection rule that we propose is near optimal as far as the outage performance is concerned, with fewer pilots than most of the state-of-the-art techniques that are available. We obtain savings of radiated power by increasing number of IRS elements or antennas, and most importantly, the active RF chains can be traded off with these passive IRS elements, thereby improving the power transfer efficiency. Yeah, so with that, I can just go to the references slide and I can point to the right yeah, maybe go 24th slide, please. Next slide. Yeah, thank you. So most of the details are available in the first reference, and yes, yeah. So and the second reference is a good paper on IRS aided wireless energy information transfer. The fourth one is a very extensive tutorial on IRS aided wireless communications. Yeah, so with that, I'll stop. I can take up questions if you have any. Thank you.
Thank you, Professor Salil. It was actually nice and very short and brief detail on the IRS part. And like you know, IRS is one of the technologies that can see 6G. We are hoping. And thank you very much. And let us quickly go for a tea break, quick 5 minutes break, and then we'll come back for the session 4. Thank
I'm
you.
sorry, sir. There are a couple of questions
Yeah,
for
please,
the.
sorry. Yeah, see. Can you
Okay.
place that on the screen?
Yeah, the first question is for Professor Ashok. Let me just put.
Is Dr. Ashok, Dr. Ashok is on the call?
He's also saying that this question is also already answered on his talk, and he poses his next questions.
Is there any question for Professor Salil?
Yeah, one question is for Professor Salil also.
Yeah, can you bring that on the desk?
Sure, sir.
What are issues are considered if the vehicular body designed as an iris?
Oh, okay. So if the vehicular body is designed as an IRS, so from this I understand that uh, so you're mentioning that IRS could be mobile. Is that what you mean? So in that case, the Doppler effects would kick in because for now, most of the research focuses on IRS being placed on a facade of a building or on the walls of a room. But then if the moment IRS becomes mobile, the relative motion between the transmitter and the receiver would induce Doppler effects. So that is an interesting avenue for research. I've not seen many papers where the IRS itself is mobile, but yeah, definitely that can be explored. Right. But yeah, Doppler effects would kick in.
Thank you, sir. One more question. Can I flash that also?
Yeah, please.
Yeah.
What is the context of outage KPI in the context of energy transfer, as we are not doing the information transfer? Okay, so the way we define outage in the context of energy transfer is when we charge these IoT devices, we must ensure that they harvest more than what they consume in sense, compute, and communicate. So most of these IoT devices have been put for some kind of sensing. They would communicate. They would do some computations at their end and communicate to a sensor, a fusion center. So the design must ensure that these sensor nodes do not end up consuming more than what they harvest. Yeah, that is why it is equally important to look at outage in energy transfer, and this is slightly different from outage in information transfer, where we uh, look at aspect where SINR falls below threshold. I hope that answers the question. Thank you.
Thank you, Professor Salil. Thank you very much. Asif, is there any other question?
There are two questions for Professor Ashok, basically. So I
So can
think
we do
we
like
can
that?
take offline.
We can answer Dr. Ashok's answer offline. We can,
Yeah,
if there is
that
any
will be
need,
great,
because
sir.
he is not present right now. Okay. Thank you, everyone, and
Thank you.
we'll come back after 5 minutes. Thank you.
Mr. Anshuman, can you check your audio and webcam, sir? Quickly. Right now, the tea session is going on, sir. Yeah, we are live now, sir. Thank you.
Thank you. Welcome back. I hope you had a good tea. So we are into fourth session, ubiquitous intelligent mobile connected society. We will look at our excellent set of chairs. I believe we have three chairs, co-chairs in this session. Can we bring up their bios quickly? Yeah, thank you. Yeah, Ekant is here. Thank you. Is assistant professor at IIT Roorkee. His main focus of research is design optimization of algorithms for beyond 5G and 6G wireless communication systems that can provide multi-gigabit data rates and improve energy consumption and spectrum utilization. So it's a great pleasure to have Ekant here. Welcome. Next, who do we have? Yes, Abhay Kumar Shah, currently assistant professor in Department of ECE in IIT Roorkee. His research areas are massive MIMO, next generation wireless technologies, and application of deep learning for wireless communication systems. It's a long bio. Let's look at the next one. Prem is here. He's currently working as assistant professor at IIT Bangalore. His research interests are transceiver design, 5G beyond wireless technologies, including massive MIMO, millimeter wave, etc. Two research papers selected by the best in here. PhD thesis involves the best thesis award for IEEE International Conference on CICT 2020. So yeah, we are in good hands. It's a great pleasure and an honor. Thank you very much. We hand over to the chairs for taking this forward. Here we go.
Hello, everyone. I, with my co-chair, Professor Abhay and Professor Ekant, would like to welcome you all in the fourth technical session, which on ubiquitous, intelligent, mobile connected society. As we know, the connect mobile behavior of human being demands a rich, connected environment where one can move hassle-free with a seamless connectivity. And this requires a ubiquitous network that can intelligently support the users, be it humans or machines. So, by keeping this in mind, we have four interesting talks, which includes the topic ranging from physical layer challenges for cell-free communication, the role of intelligent reflecting surfaces, and the 6G vision from industry perspective. So, without taking much time, I would like to introduce our first speaker, Professor Ajit K. Chaturvedi. So, Professor Chaturvedi received BTech, MTech, and PhD degrees in electrical engineering from Indian Institute of Technology, Kanpur in 1986, 88, and 1995, respectively. He is currently a professor in the Department of Electrical Engineering at IIT Kanpur. He held the position of head of the Department of Electrical Engineering, Dean of Research and Development, and Deputy Director at IIT Kanpur. Professor Chaturvedi served IIT Roorkee as its director from January 2017 to October 2022. During this period, he also served as director of IIAS Simla and director of IIT Mandi. Professor Chaturvedi was coordinator of BSNL IIT K Telecom Center of Excellence, where he uh, where he has done a large number of projects for the Indian telecom sector. He is a founding member of the Telecom Standards Development Society of India. Professor Chaturvedi was a member of the DOT committee, which recommended criteria for spectrum allocation to telecom operators. His research interests are in communication theory and wireless communication. We welcome you, sir. Please come.
So maybe
Hello. Hello. So I hope I am audible to the online participants. Let me start this very brief talk by congratulating TSDSI for having thought of using the platform of NCC to encourage researchers from the academia to get exposed to the opportunity of participating in the standards at the global level. As we all know, academia is driven to primarily to academic research, and so academia is used to computing at the global level or competing at the global level, because you cannot get your papers published unless you compete with the best in the world. So it is just one more step to be taken so that we compete with the global industry and academia to get our presence in the standards. It is true that every research that is done is not relevant to standards. It is true that every topic that is attractive to academics is not necessarily of immediate use to the industry or to the standards. But at the same time, it is also true that every academic during the course of his journey looks at interesting research problems which can create some impact. So the idea is that you produce a paper which is not confined to only the print or the electronic version with nobody downloading it, nobody reading it. We want that our papers should be read by the maximum number of people. We want our papers to be cited by the maximum number of people. In other words, we are looking to create an impact. Citations means that my research has created an impact, and so it is finding a place in future research. Standards is just another way, equally important way, by which we can create our impact in the relevant domain. So I hope TSDSI, the important step that has been taken in terms, I think, in the last NCC, now in this in-person NCC, will continue to use this opportunity. Now let me come to this talk. So normally we do research in collaboration with somebody, but this particular talk has been prepared in collaboration with Professor Abhay Kumar Shah from IIT Roorkee. I wanted to make sure that whatever we present here is something that covers some important research works of the past, which are probably more relevant to carry forward in terms of creating an impact for 6G and beyond standards. Next. So now we can go slightly faster. So I will there'll be one slide on road to 6G. Then the next slide will be on an outline or a brief exposure to what is cell-free massive MIMO. Then we'll talk about a couple of interesting research areas in cell-free massive MIMO, which hopefully, unless solved, will not give the kind of impact that cell-free massive MIMO is hoping to create. We'll go beyond and talk about three more important, very broad areas which are essential before we can realize the dream of 6G. This is need for distributed signal processing, channel estimation, and adaptive filtering. Next. Next. So while maybe many of you are aware, some of you may not be aware, that even today, many countries, including our country, at several places, we do not have even 4G. While it is also true that some cities within India already have 5G. And it is also true that even today, big companies are selling 4G equipment because you need to cater to the market which needs 4G. So the idea is that many of these generations go hand in hand. It is not that lock, stock, and barrel, one generation vanishes and the next generation comes. So For example, 5G, it will probably continue for another 8 to 10 years. Maybe its rollout will continue till the next decade. But at the same time, identifying the successor of 5G and beyond, that work is already on for the last 5 years. And it will take another few years before it gets standardized. One, of course, we can define in terms of numbers what is 5G, what is 6G. But one thing that is very clear is that the dream of internet for everything, that will not be realized by 5G. If I try to explain in some very simple terms or in one sentence, then it is visualized that maybe we'll have 1 million devices per cube kilometer. Per cube, because we are also including aerial as well as terrestrial devices. So the third dimension is also included. And this will require ubiquitous, reliable, and low latency connectivity, which hopefully, if we can get the 6G going, it will be able to provide that. And if we want to identify some good physical layer challenges for 6G, there is a very beautiful paper that appeared in IEEE Communication magazine, January 2021. I've liberally used that paper. It is the Road to 6G, 10 Physical Layer Challenges for Communication Engineers. So I've been using the word communication engineer in my classes for 20 decades, but for the first time I saw it in a research paper, the word communication engineer. So if we try to divide broadly that what is it that 6G is looking for, what in terms of conceptual areas or in terms of physical layer technologies. So the three areas are that how to eliminate the conventional cell structures. Second is how to engineer a smart radio environment, which obviously there'll be talk of RIS or IRS. And the third is, of course, how to make use of higher frequency bands, whether in terms of millimeter wave and terahertz. So if we get these three big pieces moving in tandem, in coordination, then whatever we want to call as 6G will become closer to reality. Next. Next. So what is cell-free massive MIMO? So here we are talking about that unlike the conventional base station which was introduced in 1G, that is in analog mobile communication, when GSM was also not there. We introduced the cellular concept, and that concept has continued. So in this, what will happen is that we will be using the word from our usual Wi-Fi domain, where we call access points. So the word base station may not be there. Just a little bit slow now. I'll say next. We'll be using the word access point, and what will happen is that in any geographical area, there will be large number of access points. They will coherently serve many users using the same resource of time and frequency. And each user is served by its whatever close by access points. Thus, each user is effectively surrounded by a cluster of APs. Now, this point is interesting, that earlier we used to say that there is a base station, which one base station serving many users. Now we are saying that each access point or each sort of each user will be surrounded by a number of access points. So that center of gravity will shift from the base station to the user. And if that center of gravity shift indeed becomes a reality, then many of these things that we are hoping to achieve will be able to achieve. And these figures that we are showing on this slide, now we can show both the figures. These figures are extremely illustrative. Please show the second figure also. Yeah. So here what we have done is we have plotted on the X and Y axis the distance in kilometers, and the color coding is shown in terms of the downlink rate. So the red or the deep red is high downlink rate, and blue or the dark blue is the low downlink rate. And if you see our current base station, the current architecture, clearly you can see that as you move away from the base station, for obvious reasons, the downlink data rate keeps on decreasing almost uniformly. On the other hand, if you look at the right side, we have got rid of the base station and we have replaced that with the liberal sprinkling of access points. And here you can see that naturally the sum rate, the data rate, downlink rates are much higher if you look for any user. So the traditional problems which are there in the base station structure, they are taken away. And hopefully this concept will see the light of the day in terms of 6G. That means we will not be talking about only in terms of cell structures, but we'll be talking about cell-free massive MIMO. So there are many other points which are relevant to it. I have collected few points on the next slide. So maybe we can go to the next slide. So while in co-located massive MIMO, that means when you talk of the base station, a large number of antennas are put on the base station itself. On the other hand, what will happen is in the new paradigm where we'll have access points, each access point will have fewer number of antennas, much fewer. So what this is meaning? This is meaning that our base station was something very expensive, something very costly. We are trying to replace it by a large number of low cost access points, and at the same time hoping to gain in terms of the sum rate that is achieved by all the users. Next point. So, in terms of wireless communication concepts, we say that we'll get a higher macro diversity gain because the base station was not something that was mobile, it was fixed as a place. So, naturally, the macro diversity gain was limited. We'll have higher degrees of freedom. Those of you who have related capacity, you know that the capacity is directly linked to the degrees of freedom. And we get high multiplexing gains and high array gains. So these are more like foundations on which we hope to continue to work on cell-free massive MIMO so that the gains can be realized. Next point. It is expected to be built from low cost and low power components. Next point. And it promises huge energy and spectral efficiencies. So the bottom line is, if you want your research to go into standards, cell-free massive MIMO is a very important area of work. If you do work in this area, there is a possibility that you might find your research in the standards, and for that TSDSI is of course available. Next slide. So this is one such problem within the cell-free massive MIMO, that is, we need to develop practical user-centric approaches, saying something at the conceptual level and making a system in which that concept is realized is something else. So what we are saying is that we still do not have practical user-centric approaches to achieve cell-free massive MIMO. Why it is so? It is very obvious, because in cell-free massive MIMO, all APs participate in serving all users. Clearly, this is not scalable. Next point. This is not clearly scalable in the sense that it is not implemented when the network size grows large. And of course, the network size has to grow large. Next point. That means each user should be served by a cluster of access points. Existing methods of choosing the access points require huge connections from all access points to the CPUs, which are in the backhaul, which are connections from the access points to the CPUs, and are fully network controlled. Next point. Further, the cluster found by each user changes quickly depending on a user mobility. So this requires more control signaling. So this slide is trying to point out that we still do not have a user-centric practical solution which will realize the dream of cell-free massive MIMO. It is pointing out that there is huge dependence on network centricity, because it will need large number of backhauls from all the access points to the CPUs, all these collections, that how to do, what to do, those kinds of things. So thus designing a practical user-centric approach is a need of the hour. Next slide. Scalable power control. This power control issue has been central for the physical layer starting from 1G itself. Even at the time of analog telephony, it was important, and of course, its importance has never diminished. And the same thing will be true for cell-free massive MIMO also. What is going to happen is, because you are going to put large number of access points, so that means you are creating potential a bigger interference problem. Next. So ideally, what will happen is, now you need to control the power of these access points as well as the users. Now, who is going to decide what is the kind of power that is to be emitted by the users and by the access points? One simple way is say, okay, give this problem to the CPU. That means now all this power control will be done in the backhaul, and all the optimal power control coefficients will be computed. They will be sent to the access point for the downlink. They will be sent to the users for the uplink. This creates a huge overhead. Again, saying that this is required and implementing it are two different things. Next. Clearly, given the potentially large number of access points and users, this model is not scalable. Next point. Can power control be done at the access points with local knowledge of the channel conditions? In other words, it is saying solving a ideal mathematically formulated problem may not be the best approach. Making a pragmatic approximation at the right stage is the key. Next, this is not easy in the absence of the full knowledge of links from all access points and users. Next, promising approaches from machine learning and deep learning have recently been proposed. So what is happening is that there are now already papers that have appeared which are showing that we can get interesting good results by using these modern approaches of computation. Next need of the hour is advanced distributed signal processing. Let me explain what is the key word which is different here. The key word which is different here is distributed. Because we want to move away philosophically from a network centric controlled network to a user centric control. So that means we need more and more distributed signal processing. Signal processing scheme that can be implemented in a distributed manner so that the system is scalable. Next, in canonical cell-free, for example, there is we talk about conjugate beamforming. It can be implemented in a distributed manner. But then next point, it is far from optimal. Next point, compared to zero forcing and minimum mean squared error schemes, the performance of conjugate beamforming is far below. So clearly what is distributed is not giving the performance that we want. Next, to cover the gap between conjugate beamforming and zero forcing MMSE, we need to additionally have a very large number of service antennas. This is more challenging for the uplink design. Next. So here what on this slide, what I'm showing is, I'm referring to a paper. You can show the complete slide, please put all the bullets. So the previous slide. The last bullet is talking about the paper. This paper has proposed two methods, partial zero forcing precoding, and it is talking about protective partial zero forcing. They improve the spectral efficiency. Now the important point is that this is able to achieve the thing that we are talking about, that means distributed precoding. So ideal mathematical solutions are already known, but newer ways of implementing it. And this scheme, it appeared in the Transactions on Wireless Communication in July 2020. And this scheme provides a trade-off between interference cancellation and boosting of the desired signal. The schemes are implemented by access points with very few antennas. So such papers, we need to build upon such papers. Next slide. This is another such example. We know that beamforming is something that is essential to wireless communication, especially when you talk about massive MIMO or you talk about 5G and 6G. This is essential for designing advanced massive MIMO systems. And when we talk about sum rate maximization under a total power constraint, it's a non-convex problem. So existing techniques obtain locally optimal solutions and require a huge amount of computation. Next slide. Next bullet. Yeah. So what has happened is that again we have got a research paper which is talking about a deep learning based fast beamforming design method without complex iterations has been reported. Next, what it has done is it starts with a heuristic solution, so it's rather a structure, not a solution. It separates the problem into power allocation and virtual uplink beamforming. Now this virtual uplink beamforming is a virtual concept that it has given to how to do it in a distributed fashion. Next, beamforming prediction network is designed to perform the joint optimization. And results show that it is fast while obtaining a performance comparable to the state of the art. Now, I myself belong to the community where we were not looking at such things very seriously because we were always fascinated by optimal solutions, mathematically beautiful solutions. But then when you are looking at implementation scales at which we are looking now, I think we have to look beyond. And probably this is what the look beyond is happening. Next slide. This paper has appeared in Transactions on Vehicular Technology in January 2020. Next. Channel estimation, again, a very common problem in all wireless communications. Extensive research has been already done on reducing training overheads in pilot-based channel estimation. Next point. In 6G, solutions will become even more challenging because massive scale-up connectivity demands. Please put the next bullets. For example, we talk about gigabit per second, we talk about high mobility. That means in all such situations, the channel estimations become problem is going to become even more difficult because the coherence time will become shorter, latency is lower. So that means transmission intervals are substantially shortened. The number of parameters to estimate will be massively large because we're talking about scaling. So that means whatever we were doing now, we have to do even a much more difficult problem in terms of channel estimation. Next slide. So here I'm referring to a paper which is again bringing something from graph theory, from the theory of computation, graph coloring based pilot assignment for cell-free massive MIMO systems. It is trying to address the pilot contamination problem, and it is trying to using graph theory. Next point. This is an efficient pilot assignment scheme. So what it does is that it uses the large scale fading coefficients between the access points and the user equipments. And first, an access point algorithm selection is used to construct what is known as an interference graph. And then it keeps on updating the interference graph. Next. The optimal pilot assignment is obtained by updating the interference graph. In addition, a fair policy for pilots reuse to improve the system performance has been considered. Next point. The proposed graph coloring based pilot assignment scheme can significantly increase the likely per user throughput and reduce the complexity of assigning pilot sequences. Again, a new way of doing things, a new paradigm. How much will it give? How soon it will saturate? Time will tell. This paper also appeared in August 2020. I've given the reference here. Next slide. Last point as I'm talking about is adaptive filtering. We know that in beam forming, transmitted signals have to be dynamically adapted to the propagation conditions, effectively mitigating interference and noise. This is something that is known. But why we need to talk about adaptive filtering is because the conditions keep on changing, whether the user is mobile or not, regardless of that. In fact, if it is mobile, then more. So that means whatever we are doing, that has to be done more adaptively. It is not a question of only finding a solution once, but it's also a question of updating the solution as the channel conditions keep on changing. Next. Optimal solutions require the covariance matrix of the aggregated interference and noise. Next. Current solutions rely on classical estimators. Estimation theory is very rich. We rely on that, such as the sample covariance matrix. We obtain the sample covariance matrix, which will return a poor estimate in 60 scenarios. Why will it become poor in 60 scenarios? Let us see that. First point is because the scarcity of samples. While the numbers of antennas and user devices will scale up massively, strict low latency and high mobility requirements will impose a rather limited number of training samples. Similarly, the problem of temporal correlation, the ultra dense and highly decentralized deployments, because of thousands of distributed access points in cell-free networks, will be subject to non-perfect synchronization and non-stationarity effects. So again, that means the problem is going to become even more difficult. And so whatever we have used for estimating our covariance metrics, those estimates may not work the way they have worked till now. So they themselves need to be recast or redone. Next. Yeah. So this was a sprinkling of 5 what I say as potential research areas. It is not that we have only 5, we have more than that. But if we choose some kind of an approach in these kinds of things, these kinds of problems, the belief is that it will attract more attention in the industry, in the standards bodies, and hopefully then what as academics we want to create impact. We'll have an impact in the on the ground in terms of deployed systems, in terms of standards. Thank you.
Any question from the audience?
Sir, in online tool, there are no such questions.
Okay. If there is no question, let us thank Professor Chaturvedi for such a wonderful talk and for such a wonderful session. And, yeah, please.
Yeah.
So like we were talking about like adaptive filtering and other topics in the last slide, right? So they are related only to selfie, or like in general we are talking about the topic that.
So it is both. That means they will be relevant in self-free as well. But even if self-free does not succeed, they will still be relevant. So it is in terms of both.
Also the deep learning technique that you're talking about for channel estimation and all those things, right? Now like this keyword like AI, how do you like differentiate with like people say ML, DL, AI? So there's a lot of confusion also, right? Like
Yeah. So I will say that personally I don't want to differentiate too much between these terms. They are more like learning schemes. I think somewhere down the line, the word learning or something like 10 years back, we started calling them evolutionary computation. I don't know why it got lost somewhere. So it is trying to mimic the minds of human beings and animals. Our mind is like that only. So if we can capture, because there is nothing more efficient in terms of computation than our mind. So the sooner we are able to mimic it, the better it is.
because this AI term and that we've been using like you said ML, like
Right.
testing
Machine.
theories, like
All learning. They are all learning. They will train themselves and then they will do the job. I that's my view. I mean, of course, we can. I'm sure people who work more in those areas, they might have some better definitions to distinguish. But for physical layer people, I think our main problem is something else. So these are like tools.
thank you very much. Thank you.
We have one more question.
Yeah.
Thanks for the talk. My question is essentially around your vision on the business model, basically the vendor market that will come up to cater to 6G requirements because of the diverse requirements there. What will be their scale? So far, most of these players are big, so they are able to influence the standards directly. But when we start seeing very small players, then what do you think will be the impact on standards?
See, this spectrum is the biggest bottleneck in terms of uh, not making the small players big. Uh, the best example that is provided is Wi-Fi, right? For example, from the very beginning, there was this is sort of free spectrum. Anybody can transmit, and then what happens is we can come up with IEEE standards. Currently, we are not able to come up with IEEE standards. So what I'm hoping is that down the line somewhere, if more small people become big in terms of having an impact, it is possible that we'll move more towards IEEE standards rather than big company driven standards. I hope that gives enough. Yeah, yeah, yeah. Thanks.
Thank you so much, sir. There is one question in the online audiences from Mr. Bhupender Kumar, Triple IT Vadodara. Can I flash that if you may? Yeah, thank you. I hope you can see the
Yeah, I
question,
can
sir.
see. Is there any other way to represent knowledge and reasoning other than knowledge-based graph expert system? Maybe there is, but I'm not aware. I'm not aware whether there is any other way of representation for this.
Any more questions?
Ah, okay. I think one. I think he said that, sir, the proposed algorithm solution require the substantiation. So this is not a question. Okay, I think there is some suggestion maybe. I think there are no more questions. Thank you.
Okay, so let us thank once again Professor Chaturvedi for accepting our invite and to have a wonderful talk.
And sorry for the intervention, sir. If audiences from the physical venue can use the hand mic, so online audiences can listen those questions as well. Thank you.
Questions will be to the hand. Questions from the audience. Okay, fine.
can you show up the bio of next speaker? Yeah. So the next session is on intelligent. Am I audible? Am I audible?
Yes, sir,
Online?
you are audible. Thanks.
Yes. Yeah. Yeah. So the next session is on intelligent surfaces for beamforming or for modulation or for both. The speaker is Professor A. Chokalingam. Professor Chokalingam received his BE degree in EC from PSG College of Technology, Coimbatore in 1984, and the MTech degree in E and EC from IIT Kharagpur in 1985. In 1993, he obtained his PhD degree from EC department, IIC Bangalore. From December 93 to 96, he was a postdoctoral fellow and an assistant project scientist with Department of EC, University of California, San Diego. From 96 to December 98, he was with Qualcomm San Diego as a staff manager. Currently, he is a professor in the Department of EC, IIC Bangalore, and working in the areas of wireless communication. Professor Chokalingam served as an associate editor of the IEEE Transaction of Vehicular Technology and as an editor of IEEE Transaction of Wireless Communications. He served as a guest editor for the IEEE Journal on the selected areas in communication and for the IEEE journals of the selected topics in signal processing. Professor Chokalingam received Swan Jayanti Fellowship from the Department of Science and Technology, Government of India, and National Academy of Indian National Academy of Engineering. He was a fellow of Indian National Academy of Engineering and the Indian National Science Academy and the Indian Academy of Sciences. He is a recipient of the J.C. Bose National Fellowship Award twice. He is also an author of the book Large MIMO Systems. So this is just a brief bio of Professor Chokalingam, but this bio won't be sufficient to introduce him. The term which we see, massive MIMO, which is the key pillar of the 5G technology, this term was coined in 2011 to 12, but the actual research Professor Chokalingam started way early, around 2007, 2008, and he was one of the pioneer of the massive MIMO system which we see today. I would like to welcome Professor Chokalingam, and the stage is yours.
Can you share my slides, please? Yeah. Okay, so am I audible at least for the, or should I wait? I can wait.
I think they want you to wait.
Yeah.
2 seconds.
Yeah, no problem.
Hello.
Okay. So good evening to all of you. So it's a real pleasure to be in NCC always. So first of all, let me thank the organizers of this session and workshop for having me in this session. And they said it's a workshop on standards-driven research. So I was keen on talking about any research that I've been doing and which is current, but the standards-driven research is interesting and exciting to me. For one reason, I think I've been with NCC for the last few decades, Ajit and myself, and we have seen the research base of NCC in general and communications and networking research base in the country as a whole has grown continuously, and it is in a fairly good critical mass at this point in time. And there are enough researchers in this domain, at least at various IITs, NITs, triple IITs, and old institutions. So I think what is the next level of graduation? That next level of graduation is where you take this research output from papers to patents, products, and prototypes. And the enabler for that is going to be the standardization activity. As Professor Chaturvedi pointed out, small people need to be big by some means or the other. In academics, we have the technical strength to do that. A small trigger that happens in Stanford in CMU makes a big deal. It creates the opportunity for investors, startups, and eventually standardization. I think that ecosystem should build up, and NCC should give that platform. And I think we, as probably seniors, reasonably seniors these days compared to the young faculty here, should nudge these young researchers in that direction, in those directions that focus a little bit on standardization, patents, products, startups, and so on, so that will be on par because you are in the best of institutions. And NCC has served its purpose so long, so well, and it should continue. So the direction is clear: standardization, products, prototypes, and everything. And in that sense, I felt very happy to start, to share this in this workshop, my experience or whatever I have about standardization that I can say, but still on research. So I should thank TSDSI to come on board along with the NCC to create that ambience for people to listen to TSDSI's goals and how we can just work with that. So thank you. So next slide, please. So it's a technical talk. So I'll talk about intelligent surfaces, aided communication. Number one, already it has been talked about in few places. And one more thing is channel modulation as media-based modulation, which is a front runner for intelligent surfaces, but for a different reason. And I will say at this point itself, RS-aided communication, as we know in literature popularly, is for beamforming, particularly distributed beamforming. As Professor Chaturvedi's slide says, distributed signal processing. One such example is distributed beamforming, and the hardware that you can do for that purpose, intelligent surfaces at low cost. And when there is no direct link between the source and the destination. So all these put together gives a good flavor of importance for intelligent surfaces. Before that, intelligent surfaces were also used for modulation, which we had done research on and built a prototype in IICEC and then demonstrated, and you will see it in a website about that on-the-air transmission using this media-based modulation. So a combination of both is a good candidate coming from India to the world at large, that these are good techniques. Whether we win or lose, doesn't matter, we participate. So that is the idea that I would like to share. Next. Yeah, this is a view that I have it in my mind. 6G, if I want to look at, there are 4 bullets under which I want to think about it. Operational space. Terrestrial is, 2D for communication purposes. Now we are going vertical, and that is 3D communication. So that is a differentiator compared to 5G to 6G as we go beyond. So confluence of UAVs, drones, aeroplanes, and even LEO satellites as part of the terrestrial is going to be a new thing for 6G, and that is one operational space difference from 5G to 6G. In the spectrum space, there is going to be a change from millimetric wave to terahertz. Terahertz may be decades from now, but the research has started. 6G has created a reason and platform to carry out the terahertz research. So people in RF will be willing to do that. Although we are talking about 28 gigahertz for 5G, it is not that great yet, but we are in that direction. In the application space, I think IoT and millions of devices is one space, but brute force increase of data rate will continue to haunt our minds and applications. Examples: XR. AR, VR is possible in 5G. XR is going to be new beyond 5G's capability, and XR is popular anticipated use case is the holographic communication. We don't have to physically sit here, but then take our 6G phones probably, and then have a 3D rendering of our presence, and maybe that is something which sci-fi in the next 5 to 10 years may happen in the application space. And the last thing, as physical air engineers, the waveform space. The waveform that we want to look at 6G or these 3 bullets in my experience, there could be others. You have to deal with high Dopplers, because high carrier frequency, when you go millimetric wave 1 terahertz, your Doppler is going to be high even for moderate speeds. And bullet trains and even aeroplanes, when you go 500 kilometer and 1000 kilometers per hour kind of speeds, even sub 6 gigahertz will have a lot of Dopplers. So that is one. And waveforms for that we have been talking about. And another interesting thing is you have to look for opportunities of now integrating this radar sensing requirement in a rich, intelligent transportation systems. I do not want to have communication alone, but the autonomous systems that are on the intelligent roads, they have to sense the ambience, the surroundings, and sensing waveforms have to be there. So you have to have waveforms which can do both for you in an efficient way. Last one, which I'm going to talk about, is intelligent surfaces, of course, beamforming and modulation. Next. Yeah, this you can see that, yeah, intelligent surface is something which you can say that this is a surface. In that surface, you have multiple patches, very low cost RF patches, pin diodes, and so on, very small passive elements, and they can be controlled. And they can control in very simple terms. What things that you can control in those elements? You can control the phases of the waveform which come and impinge on that surface and get reflected. So there is a surface, multiple elements, and a waveform comes, let's say preferably obviously from a transmitter. It gets reflected from here. When it gets reflected, the phase with which each of these elements changes the waveform to be going in a certain direction can be controlled. So phase optimization or phase control is what we can do at a very low cost. And next slide, please. When you do that phase control, what do I want to do? I want to maximize the signal to noise ratio or some desired property at the receiver. And this diagram is typically a diagram that you will see it in cooperative communications with relay. But it is not that. It is not decode and forward. It is not amplify and forward. It is simply reflection at a very low cost element. Ignore for the time being the direct path. There are cases where you have no direct path between transmitter and receiver. And suppose if there is a surface somewhere and which is not required to amplify and forward or decode and forward, simply reflect. So while reflecting, you beamform. And in conventional beamforming, you will have an array of antenna at the source, array of antenna at the receiver. Single symbol you will transmit, but with a weight vector, you will beamform. That weight vector is going to be a complex vector, and that complex vector is going to be dependent on the channel gain. So that functionality, we are distributing it in a simple low-cost hardware using this IRS. So you have to expect what transmit array gain that is given by transmit beamforming, and that is one. And receive beamforming you can get from receive antenna array, which is not required even with a single receive antenna. If RAS gives you the beamforming, we are through. Next. I will not go into the mathematics. I would say the beamforming happens. Yeah, please go ahead to the previous slide. There was a red bullet. I will read. There is a beamforming that happens in the medium. In other words, this reflection of the beam is due to the phases that you choose, and that has to be intelligently chosen. That is the why it is called intelligent surfaces. You can choose optimally the phases. In the classical beamforming, you used to do that by channel knowledge, by having the complex conjugate of the channel vector, and then do maximal ratio on the fly. Something similar happens here. So it is not happening at the transmitter. It is not happening at the receiver, which is conventionally so with a lot of array elements. Expensive. Now it happens in the medium with a simple reflecting surface. It is very attractive to me. So a lot of things you can standardize beyond what is there in the literature right now. Next. Yeah, next. And yes. So this is a picture which convinces you. The foremost graph that I show that is in pink is when there is no RAS what is the error performance. Red is when I have 5 elements to help you with a 5-element phase vector, and it improves significantly because of the array gain. And 15, it gets even more. 25 gets even more. So more the number of array elements, very less expensive hardware, you keep getting array gain. In the traditional places, you will have antenna array elements. More of them mean more cost and RF chains and other things. Here it's a low cost distributed beamforming, and you get improved performance. That is why people are very much fond of this intelligent surface. Given that 28 gigahertz and 60 gigahertz are going to be used, directivity requirement comes naturally. Yeah, please go ahead next. Okay, this is a thing that existing waveforms like OFDM, OTFS, if you propose for next generation, they can take the benefit of RAS simply by adding on to the link this RAS, you'll get gains. Next. Next. Yeah, this is another plot which you can see. If I use OFDM, initially what I showed is a simple QAM symbol is what was transmitted, and that reliability kept on improving as the number of elements increased. Now I have a more practical waveform which is OFDM, and OFDM, if I transmit and receive via this RAS, I get blue, which is without RAS, which is traditionally what we use today. And if I use 15 elements, the red curve, and black is 25. The interesting thing is, many people mistake the gain that is given by RAS as diversity gain, which is a slope change in the SNR versus BR curve, which is not the case. It gives a SNR shift, which is an array gain. So it is not diversity gain, it is an array gain, but it is still a great physical layer enhancer. Okay. So you can see all the curves have slope 1 after some high SNR. All the things, they go parallel beyond some certain SNR. Next. Yeah, the OTFS is a new modulation that we have been talking about. And when you use RAS there also things are improving. We can go to the plot directly. Next. Next. So, yeah, here again, same story. The point is, any communication waveform that you have, as long as RAS is implemented, as the number of elements increase, you get better gain. Go to the previous slide, please. An optimization problem for engineers' delight in this area is how to choose that phase vector. You have an RAS array, and each one you have to find out what is the phase and how to pose the optimization problem, how to solve it, right? For a theoretician and for a academic researcher, you make it as hard as possible, and then most elegant way of solving it is an approach writing a paper. That is good, and when he's in the academic institution, you should do that. Go to the industry, don't complicate it. Make it four phases, make it 8 phases. Choose one among that. As Professor Chaturvedi says, choose the pragmatic approximation. So you lose some performance, but that will be good. So these things, I think, between practical standardization and academic thing, over a period of experience, we see this difference. But young faculty, I think they will be able to have opportunities to get this quickly with interaction with TSDSI and industries and startups. So this is an optimization problem, and I think it's a delight. And the students look at this seriously, and we also looked at it. We got some good results for a paper, but I think it is a rich topic by itself. Go to the next. I will go to the media-based modulation. Next. Okay, this you can skip. Go to the next. So this is one slide which I will spend some time, and then I will say why I say that there are 2 purposes for intelligent surfaces. In this diagram, if you see, there are 2 places that intelligent surfaces are there. One I call this as RAS, right, which is in the middle. And towards the left side, you have a transmitter, and there are multiple transmitters, right? And in front of each antenna, there is a small array-like thing which I call mirrors, right? Which is also a surface, and it had elements, and those elements will be not controlled by phase, which is channel dependent. but it is going to be controlled by information bits, 1 or 0. And depending upon that 1 or 0, the channel coefficient between the transmitter and the receiver will change. And when that channel changes, depending upon the 1-0 pattern of the bits which control those nearby surface, right? Suppose if there are 4 elements, I have 2 power 4 combinations of activity, 1 and 0. So you have 2 power 4 possible receive gains, and those gains form the modulation alphabet instead of 16 QAM. So if you use that, it is a very good modulation scheme to give very reliable performance. So in other words, keeping an intelligent surface in the near field of the transmitter for the purpose of modulation, and keeping intelligent surface in the far field controlled by phases for beamforming purposes is going to be a dual advantage for use of intelligent surfaces. We knew them as separately. We knew them for beamforming, and more than 90% of the research is on beamforming, right? But modulation has been there, and we have built this, we have prototyped, and we have filed a patent, and it is on the YouTube to see the a few minutes kind of presentation. But the idea is, it is a natural intelligent surface application for modulation purposes. The point I'm trying to stress here is, if you combine both, you get the benefits of both: a very good modulation, which is good in spectral efficiency, a very good beam forming, which is low cost and energy efficient. Okay, so go to the performance plot, and with that I will close. Maybe ask for questions. Again, this reflection phase design is important. Yeah, so keep this next plot. Yes, so you can see here green and blue. Green and blue compare. Okay, blue is MBM, which is channel modulation, which as itself is better than QAM and other modulation that we think of. And without RIS, blue, and with RIS, it becomes green. First of all, blue itself is good compared to regular modulation like 16 QAM or OFDM or whatever. So this media-based modulation itself is going to be good. On top of that, if there is RIS, it is going to be even better. Likewise, you have to compare red with black. Red is without RIS and black is with RIS. So you have the advantage of both modulation and beamforming using these two elements which you keep near and far from the transmitter. I think I can conclude. Next. Yeah. So this is a very simple concluding remark. RIS and media-based modulation are promising technologies for next generation wireless in general, not necessarily 6G. And RIS is energy efficient communication through distributed beamforming, number one. Media-based modulation is high spectral efficiency modulation scheme using low-cost RF hardware. Because one of the key advantage which I did not mention is it will give MIMO-like spectral efficiency, massive MIMO-like spectral efficiency using a single RF chain or few RF chains rather than large number of RF chains. So that's what I mentioned by high spectral efficiency like massive MIMO, but low RF hardware because the information is carried on which elements are activated by indexing. Okay, so that is second. Obviously, RIS aided MBM is going to be giving the benefits of both. And RIS MBM research is in the early stages. Some of our students have started doing that. And there is scope for more research and, of course, standardization efforts. With that, I will conclude and then thank you. So that is the last slide. Thank you. Yeah.
So good afternoon, sir. On slide 18, you talked about the multiple antennas and having RIS in near field.
Yes.
So how it is different than we directly if we are using the multiple antennas array. So directly phase shift control there, and then using the intelligent surface in the near field region.
Say that again.
Directly, we are having the MIMO techniques, directly phase controlling the multiple antennas, phase radars or all that. Yeah. And now you are talking about the near intelligent surfaces for the in the near field region. So how both these are different? Which one will be more efficient?
So I was telling, if I use MIMO, I have to use one antenna, one RF chain. If there are 16 antennas, right, rate will be high, your beam forming can be sharper, but RF chains have to be same as the number of antennas. Okay, so if you use this media based modulation by creating the intelligent surface and control not by phase but using information bits, and that will characterize the receipt signal vector depending upon the environment. So the channel is going to give you the alphabet for communication. So RF chains are not going to be required in big numbers compared to MIMO. MIMO, if I have NT antennas, I should have NT RF chains. Here, if I can have multiple elements. Elements are not RF chains, which are expensive, power hungry and costly and weighing, right, heavy. So you can have elements, but you can have only one RF chain. So that is the advantage.
There is one online question, sir. I think one or two questions. If there is no questions from the physical venue.
Yes, sir. So questions that I have is the physical property of race when we fabricate it seems to be very tightly coupled with the frequency of operation. Okay? So if we are thinking of deployment in a cellular kind of setup, where we frequently switch frequencies just for interference management aspects, how flexible do you think this system would be?
Yeah, I think this is better answered by industry people because they really burn themselves with the real hard problems of practice. And what you say is very true. It is very appealing from a research point of view. Intelligence service is very appealing from a research point of view. But the real system when you build, all these questions that rise are going to be very relevant and they are very challenging. One simple question related is two elements are there. You say a wavefront is falling on that, and one will be shifting it by alpha 1, another phi 1, another will be phi 2. May not happen because they are close. So the response to that is don't have all elements next to each other as one element. Create that as nearby elements, call that as a subsurface, and few of them you make that as one element. So they try to reduce the effect of what we call this as correlation. So like that, frequency dependency is another. So as of now, I do not know major demonstrations of these technologies in a big way, convincingly. But I think it should come because of the interest that is there, and that may be one possibility. That if there is interest and if this no cost or low cost, I think even industry will be excited to try out. So only when you try out, all these questions will come, and then they will be answered over a period of time. So as Ajit Chaturvedi pointed out, we are 5 to 10 years easily from 6G, and open up all these possibilities, with youngsters. They will tinker with this, and then there will be approaches and so on. I do not have any immediate thinking on that, but as you said, it is hard when it comes to practice, and there are naysayers, very many of them. But that is true. Any new thing that comes about, oh, I knew this in the past 20 years back, I knew this in a different name. But so is, evolution. So I look forward to challenges even though they fail, rather than not making that, very aggressive stand that it is new, I want to try. So it may be new and not proven yet, but the direction is there for us to explore more.
Okay, so you talked about combining TFS with IRS. So when we have this IRS with any of the waveform,
most of the challenge or one of the challenging tasks is to acquire channel knowledge,
Correct.
especially the indirect link. So when we are using OTFS, we are typically targeting for highly mobile applications, and there the channel is changing very fast. And acquiring this indirect channel knowledge requires transmission of multiple frame. Typically, let's say you are using on-off scheme. In that case, is it fair to assume that the channel remains, let's say, same for multiple frame, even with OTFS, where we are targeting highly mobile applications?
Yeah, it's a good question. I think you are bringing another thing which I did not talk about, OTFS and its relevance to high mobility scenarios or high Doppler scenarios. I think I should state one fundamental point for OTFS. In delay Doppler domain, where OTFS is structured or designed, a channel variation in time, which is rapid, is not rapid when it is viewed in the delay Doppler domain. So which means there are two things. It is not going to be varying very fast in delayed Doppler domain if I do the processing. And two, I don't have to estimate too many channel estimates. It is only few strong reflectors, delay and Doppler. So the channel estimation issues are relatively simpler in OTFS, and that may be useful for the applications that you are talking about. And it is better than time domain processing and frequency domain processing in OFDM or what we have been doing in the multi-carrier in the past. But RAS, see, these are all things for us to really embark and then be in the front line to do the research. RAS, it has potential. Media-based modulation, it has potential. Machine learning and deep learning, we have potential. And we have OTFS, many things. So all these things are exciting to us, and then maybe we are the first people who should look at it seriously and then share it in platforms like this.
Can we take the questions online? Can we solve?
Yeah.
Asif, can you flash the questions? Can you hear me, Asif?
Yes, sir. Let me collab all the 4 questions posted by S. Pichia Selvan.
So should I answer all the 4?
Yeah, I'm just
So if
reading
you have
out,
5
sir.
questions, let me know. I'll be
I'm just
trying to
reading
screen.
out those questions. Sir, energy harvesting using RIS, it
Only
is
one?
possible way?
Thank you.
First question is that. Then is RIS channel modeling is different or not in 3 aspect of interface fading? That is 3 question. I posted in the speaker chat as well, sir.
Okay, I think what I heard was, is channel estimation different in RIS compared to non-RIS? I think that is a question, right? The answer is no, there is no difference. Whatever you learn in the normal circumstances between a source and the destination, you have to do additionally source to RIS channel estimate and RIS to destination. So there is an additional set of parameters, but the techniques that you may want to employ and the resources that you may want to employ will be the same as before, if not very different.
Let us thank Professor Chatterlingam for accepting our invite. He had already one talk in the morning. He accepted our second talk or invite for the second talk, and it was a very wonderful and insightful session. Thank you.
Yeah, thank you.
So there was one question from Bhupender for Professor Chaturvedi. It was already answered on the deck. So online audience, they can have a look. Now let us move to the next talk. Can you show the slide? The speaker bio, Asif?
Yeah, sure, sir. Chandrakanta is printing. Okay, thank you.
Yeah. Yeah. So the next speaker is Mr. Ansuman Nigam. Mr. Nigam is associated with Samsung R&D Institute, Bangalore. where he is leading the 6G research team. He is passionate for incubation of core technologies and transitioning them through the early research phase to realistic pre-commercial POC, that is proof of concept stage, while shaping up the adoption of the technologies of the BIS relevance in global standards. He holds a graduate degree in electrical engineering from IIT Kanpur, while at Samsung India, he has actively worked in research, development, and standards for 3G, LTE, and WiMAX and 5G technologies. He has served as an active contributor from Samsung to 3GPP RAN 2 and WiMAX 2.0 standards groups from 2008 to 2014. Post that, he led the 5G research and POC development at SRIB. I would like to welcome Mr. Nigam to initiate his talk. Hasif, can you share his slides?
Hello, good afternoon to all our fellow researchers. I'd like to thank the organizers for giving this opportunity to express Samsung's views on 6G. And it was a delight to hear our previous speakers, our academic stalwarts, Professor Chaturvedi and Professor Choklingam. I had the privilege of studying under Professor Chaturvedi long back at IIT Kanpur. And I think it is the perfect time to think and plan big for creating 6G technology from India. So next slide, please. Yeah, so as all of you are aware that ever since the world's first 5G service got commercially launched, we all started thinking about 6G. But just have a look in last 3.5 years since we launched 5G, it has been there now in more than 90 countries with 200 plus operators and almost a billion plus subscribers. Even 4G took a long time to achieve this, and 6G, so 5G is really real and it is global now. And so it's the right time that we think about what lies beyond 5G. Next slide, please. So a quick look at the standards, 3GPP standards of how 5G has been going. See, Release 15 was the introduction of 5G where the key foundation pillars of 5G were incorporated like flexible numerology, higher bands, beamforming, and bringing in a real change in the core network by bringing in service-based architecture to core network. And Release 16 expanded onto few verticals. It also improved the air interface while making a major thrust on the V2X and positioning kind of functionalities. Release 17 then led to further enhancements from Release 16, and in particular adding a new vertical for NTN, which is very important vertical from as seen from the 3GPP perspective. And then in Release 18, which is ongoing the 5G Advanced, it's called as 5G Advanced, and is preparing 5G for the next phase of evolution, where one of the primary focus is on AI, incorporation of AI and ML into wireless communications. Right. It is also studying newer duplex schemes and also a richer AR, VR kind of services, how the RAN and core should be optimized to give a richer AR, VR experience. Now, while 5G Release 18 is going on, there are also discussions on what should be for Release 19 and when should 6G start. So it's widely understood that Release 20 will mark the start of 6G, and we will see in later slides about what the ITU and 3GPP roadmap looks like. So next slide, please. Next slide, please. Yeah, one more. Yeah, here. So before we jump into this, let's ask ourselves a question: what's the need for 6G? Like even Professor Choklingam was talking about that today, AR/VR is possible to a certain extent, but is truly immersive XR possible? Is metaverse truly possible? When I say possible, please consider it from the perspective that it is possible at a wide scale commercial level. So today, the kind of overall capacity requirements for XR or even for, let's say, digital twin, digital replica kind of systems, and even the mobile holograms, those cannot be met by 5G. In whether it is in terms of user throughput, whether in terms of capacity, whether in terms of the latency requirements. So definitely, a new, more capable system is required to achieve such kind of requirements. And that also makes us believe that we need to create something bigger which will enable these systems and also will be a platform for much newer innovations to come. In fact, while I was thinking about it, if we just ask ourselves what will be the form of a mobile phone in 6G, and when we say 6G, we are talking about 2030s. Maybe there is no mobile phone that may exist then. Maybe our watch will do everything, or there will be projections in the air everywhere. We don't know yet fully. But yeah, it will be very different from the era that we are in today in 5G. Next slide, please. Yeah. While we see these are the needs of 6G, like the service which are not possible at a commercial scale by 5G, let's also take a look at the mega trends which are emerging, which are giving pointers towards 6G. One is machines as the main users. Right. So 5G, and also 5G, we have massive machine type communication where we are trying to enable IoTs at a larger scale. But let's think from the 6G perspective, possibly robots will be a very primary users of 6G. And when we differentiate between humans and machines, humans have certain limitations, but machines can have much lower resolution of many things, which means our 6G system should be designed to cater to meet those capabilities of the machines. That's one of the first megatrends for which we need to consider when we are trying to design 6G. Another megatrend will be the AI, because AI definitely is not a key communication technology, but AI is a tool that can be adopted for wireless communication in a big way. And I'll talk about one or two examples in my slide on how we are trying to use AI. In fact, when we talk about 6G, like we are talking about, let's say, even user-centric cell, like Professor Chaturvedi explained, or the massive MIMO or RIS, we see that dimensions are increasing, and the kind of limits that we are putting on the systems are much higher. Now, when these increase, it leads to exponential increase in the computational complexity. So that's the challenge. So can AI help us solve certain things in a better and a way such that we achieve reasonable accuracy or KPIs while having manageable complexity? So that's we consider that as one of the major tools for AI. And as I was explaining in the previous slide, 3GPP in release 18 has also started work on AI and ML. Especially right now, it is tuned towards physical layer, but gradually it will expand to the entire gamut of 3GPP. Third is the cloudification of networks, right? So when we talk about 5G, 5G was for service based so that it can be cloudified. But even when we see today the emergence of VRAN, virtual RAN kind of systems, it's in a very early stage where we see it's a kind of a monolithic structure of a VRAN. It's not actually cloud native type of system yet fully. So that's one another area that will lead to inputs, or will be one of the triggers towards 6G that we need to consider. And another fourth big area, which metaverse, which includes all the type of AR, VR, XR, all the types of possibilities that we imagine, that together will lead to a cumulative, impact on the requirements that we have to fix for 6G. So these are the four mega trends in our opinion, which will drive towards 6G. Next slide, please. So from all these mega trends and the service requirements that we earlier talked about, we try to derive what are the performance requirements of 6G. So here from Samsung's side, we are trying to portray the peak rate of 1 Tbps, which is 50 times of 5G. User experience data rate of 1 Gbps, couple of Gbps, which is at least 10 times of 5G. Here it is user experience data rate you can consider as the average user data rate. So that's a more usable figure as compared to peak data rate. So user experience data rate is the average data rate which a user experience most of the time. So it's kind of, we are moving towards a ubiquitous gigabit service so that at least gigabits can be provided anywhere, everywhere. Right? Latencies, we are trying to cut short by 1/10 of 5G to 100 microseconds. And when we say latency here in the slide, it means more from the air interface latency, as we particularly talk about in 3GPP. Next slide, please. So here we are adding two new dimensions to the requirements of 6G. We earlier talked in the previous slide about the performance requirements. Here, let's take a look at the architecture requirements and trustworthiness requirements. In the architectural requirements, we see two major dimensions. One is in 6G, it will be a kind of a convergence of computing and communication. The amount of computing required will be pretty high, and computing may not be able to be done on a single node or a single processor or a single machine. So it's kind of a distributed computing paradigm, and to make it distributed in the timelines that is required for 6G, communications itself will come into picture. So there will be always a kind of a trade-off between the communication cost versus the computation cost. Here, things like split computing, distributed computing, where things can be offloaded. For example, we are wearing a AR glass. AR glass may not be able to do all the computation itself, but it can offload the computation to nearby devices, get the results back, whether it is AI computation or communications related computation, but get the results back in the latencies required for the communications of 6G. Another will be the angle of the NTN, on which the work has already started in 5G, but we'll see it as a one very major component of 6G. Right. And another third set of requirements are more related to the trustworthiness requirements, because this is often kind of not heavily focused on eventually in communication system. But when we talk about 6G, we are talking about much heavier usage of AI. We are also talking about in 2030s there is possibility of quantum computers becoming more prominent, which also means that the current cryptographic algorithms that are on which our 5G security systems are based, that will be easily broken by the quantum machines. So we may have to enter into a world of post-quantum cryptography kind of things to take care of. Similarly, as the networks are becoming very open, like you can talk about Open RAN, or even today you can have DU from one vendor, CU from another vendor, RU from another vendor, and in 6G this will be even more granular. So when we talk about openness, we talk about heavier usage of AI, we talk about the advent of the quantum machines. We are talking about a mixture of things where security needs to be guaranteed, that we take one thing from one, another thing from another, and it should be trustworthy. It should work. It should work without any kind of malicious attacks. So trustworthiness will be another important requirement that we will focus on in 6G. Next slide, please. Yeah. So here's the standardization timeline. This is a proposal timeline, and which industry is talking about. And as you may know, that ITU has already started the work to finalize 6G vision by mid of this year, and which will set forth the IMT 2030 requirements, which needs to be met by 3GPP. And if there is any other standards body like IEEE, if it comes up with that, then we have to meet those set requirements, and the technologies that meet those set requirements will be called as 6G. So ITU has already started the work on it, and similarly in parallel, 3GPP is starting to plan for it. And one of the first things which I was already mentioning is Release 20 may be the start of 6G. 3GPP is planning to have a 6G workshop somewhere in 2025, which essentially means that we have only 2 years left to actually take the technologies that we have created into the standards. And this is a very important slide in the context of this workshop that we have on standards approach towards research, standards oriented research. That assume that we have only 2 years left to start things in 3GPP, and let's say 3GPP for now is the only standards body. Then that means in this year we should down select and freeze on few technologies, and then next year shape them up so that they're suitable for standards. You need to transition them into the 3GPP framework so that they become adaptable to 3GPP. So that's one of the important points, in my personal opinion, that we as a country, as a consortium of researchers should look into from India, so that we can contribute to 6G technology from India. Next slide, please. Yeah, so one more slide. Yeah. So 6G will be kind of a combination of extreme performance, will be designed to be softwareized, it will be AI native, it will have integration of communication and computation, it will support many different verticals, which is not only NTN, but maybe beyond that. And it has to be trustworthy and sustainable. So this will be a combination of various different technologies. In the interest of time, I may not be able to go into all the technologies that we at Samsung are trying to pursue, but I'll particularly focus on 2 examples of AI technologies that we were trying to incubate and research on here. But from a wider perspective, yes, we are working on the radio technologies, and we consider cell-free RIS working in higher frequency bands as one of the very fundamental components of 6G. From the network architecture perspective, we consider cloud native, fully cloud native as the kind of definition which should redefine how network architecture looks like. Communication and computing paradigm should be built into rather than as an afterthought. Like today, we are adding MEC as an afterthought into the 3GPP standards. Rather than that, a fully distributed convergence of computing and communication should be built into the system. Trustworthy system should be designed right from the start, and one of the important reason why we should do that is because of the quantum machines. And another angle to it is the AI native angle, where 6G, right now in 5G, we are trying to add AI piece by piece, but rather for 6G, we should think in a more holistic way from a usage of AI perspective. So let's move to the next slide. Yeah. So this is where, for example, today we are choosing a problem, let's say channel estimation, for
Ansuman?
example.
Ansuman, can you hear me? Yes,
Hello?
sorry to
Yes?
interrupt. Can you hear me? Can we
Yes?
try to conclude in like next few minutes? Actually, we are running short of time.
Oh, yeah, definitely. I'm going pretty fast for that very same reason, and we'll cover it in next less than 5 minutes.
Okay. Thank you. Thank you very much.
So in 5G, we are applying AI in a very piece-by-piece manner, where I mean that you pick up a problem, you apply AI to solve that problem. But in 6G, can we think holistically where a bigger chunk of functionalities of whether it is physical layer or it is the entire system as a whole can be done by AI, or there can be many multiple blocks of AI that are governed together, or they are working together to create more meaningful thing for AI. In 5G, for example, we are currently using AI to apply in the detection of errors or correction of errors to certain extent at the very top levels, that is network management level. But from 6G, we have opportunity to apply AI in all the layers of the system and nodes of the system. So next slide, please. Yeah. So one of the practical example that we were trying to work on is if an area is covered by multiple cells, and when I say cell, I mean a particular frequency layer. So if can we turn the cells on and off as per the demands of the traffic, dynamically controlled by AI, instead of having some very few preset manual rules, like typically in industry, if we don't want a perfectly optimal solution, we go with a set of 4 or 8 or 16, and we select one of the things to apply at a certain time. So here we did some experiments, and we were able to achieve much better gains in terms of energy savings by application of AI, where depending on the overall need of the system, we were actually switching on and off the cells or the frequency layers as and when required. Especially during the night time, not all layers are required. Right. So this was one of the results. Next slide, please. Yeah. So this is again related to the same previous example that I was taking here, showing it in a more diagrammatic way, that there are various frequency layers, and depending on the need of the system, one or more frequency layers will be turned on at a time. And this we see as a very practical use of AI, and we see it's the data that you are seeing here is not only a proper simulations data, but it has been taken from the field, and we are seeing some relevant usage of AI here. And again, this is with very manageable complexity. Let's move on to the next and last example here. Yeah. So this may be of interest, more interest to the community here. So this, we were trying to understand the application of AI at the power amplifier level. So power amplifier is one of the most costliest component in terms of the silicon, the communication side silicon that is added to a mobile phone. Because power amplifier is non-linear, so there's a lot of back off in the power amplifier, which limits the uplink coverage or the range of the UE that it can transmit how much to the base station. Right. Now, this is one of the big problems that industry is facing, that in downlink it is good, but in uplink the coverage is shorter. And how do we solve this problem without increasing too much of cost or power overhead? So we thought that can we apply AI to learn the non-linearity of a power amplifier, and then reconvert it, or reverse the non-linearities at the receiver. So which effectively means that on the handset side, the UE side, we are not putting in any extra hardware. Rather, all this intelligence of the AI will reside at the base station. UE transmits it. And the base station AI will be able to recover the non-linearities. This effectively will increase the linear range of the power amplifier, which effectively will lead to an increase in the coverage. Or we can talk about better supporting a QAM. Let's say today we can support 256 QAM, but we can possibly then move up to 1K and 4K QAM kind of scenarios. So this is one example which we did, and this is a work in progress. And we did some certain experiments in house, and once the experiments are complete, we'll publish the more detailed results in it. But this is one practical example where AI can be used. These are the things that I wanted to talk about. In the interest of time, I'll pause here, and I will again like to reiterate that we need to work together so that we can create some meaningful technologies from India and push them to the global standards. Thank you. Yeah, you can skip this slide in the interest of time. Yeah, next slide you can pause it and stop it there. The slide contains some of the work that we have done, which is published, and many more will come in future. So thank you for this opportunity, and I'm open for questions.
Thank you very much. Okay. Yeah. Thank you, Anshuman. That's a very wonderful talk. Thank you for covering the mega trends and the roadmap. Unfortunately, we are kind of running out of time, and we would like. With
Hello,
your
I'm
help
not
and
able to hear.
understanding. Thank you very much, Anshuman.
Thank you.
Yeah. Thank you for taking the time. I want to take a small change in the agenda. We would like to please request patience from the rest of the speakers, including myself and Satish. Satish, sorry, please hold on for a moment. Please, I hope you understand. Professor Chaturvedi has to leave, so we have to take his guidance and his points for summary next. I would like to please call upon Professor Chaturvedi to come and guide us with the summary of the talks that we had today and your general guidance, sir, please.
So on behalf of TSTSI, I've been requested to present a very, very brief summary of what has been happening since the morning. So, what is very clear is that if you look at the topics that have been covered since the morning, we are talking about a very rich and a very diverse set of needs, capabilities, requirements, whether it is in terms of a citizen centric ecosystem, which is creation for local needs, which was laid out by Sri Pritam Bishnoi. He made a plea for standards based innovative technologies for 6G. Professor Brajesh talked about the haptic stack, which is a key component of next generation networks. And each one of us thinks that whatever we do is the only important thing. But there are so many areas, and every area is required to sort of align so that we can get useful things out of it. Professor Omji Pandey talked about small world networks, including the key problems of sensor node localization, energy saving, and beam forming there also. Jishnu Arvindakshan talked about positioning and sensing and the corresponding challenges. Dr. Vireshwar talked about security and privacy issues, especially in IoT networks. His personal experiences and standards were shared. Mr. Abhishek Kumar gave the industry perspective with details on platforms including Hadoop and its tool sets. In the tech session, Dr. Ashok Talukdar talked about the need for standards for democratization of knowledge with several examples from the medical domain. Dr. Salil Kashyap talked about key questions including channel estimation, power savings in intelligent reflective surfaces. And then we have the current session that is ongoing, that is purely focused on physical layer technologies, where I talked about some of the challenges emanating primarily from cell-free massive MIMO and even in general. It was followed by a very comprehensive presentation by Professor Choklingam. He talked about RIS and MBM and the key trade-offs in detail, and also highlighted some interesting problems that can be done by the academic world. And just recently, we heard the industry perspective on 6G by Shri Anshuman Nigam. And again, as is clear from the talks that we've been listening since the morning, that there is something that almost every speaker brings to the table, which is relevant to the other speakers. So the more we try to learn from each other or attend such sessions, I think our problem formulations will become more meaningful, more impactful. Otherwise, our problem formulations suffer from a silo effect. That means our worldview is limited by whatever is in that domain. But if we attend these kind of sessions, and we can attend them only when they are organized, and so I think the way it has been conceptualized by TSDSI, I think all the chairs, co-chairs, they have put a lot of effort in planning the topics, in terms of identifying the speakers, in terms of convincing the speakers that they must accept this and they must do it here, and also allowing it to be hybrid, so that the disadvantage of not doing it at the conference venue is partly offset. Otherwise, if we could have done it at the conference venue, then I'm sure the hall would have been more fuller. But at least this effort itself is not a waste, because a lot of people have joined online also. And the good thing is that online people have asked questions also. So a lot of takeaways for so many of us, maybe all of us. And thanks to all the speakers, to all the organizers, and for the TSDSI for having reached out to NCC to be able to do this. Hopefully, it becomes a regular feature of NCC, and hopefully, it can be planned. The logistics can be planned even better than this year. Thank you.
As well as all of us here, we would like to thank Professor Chaturvedi.
So we have another few talks remaining, guys. Yeah. So Satish, are you there?
Yes, I am here. If you can see and hear
Okay.
me.
You can hear me, right?
Very well.
So Mr. Satish is a part of Nokia Strategy and Technological Division and heads the standardization and industry engagements in the APAC region. He is a distinguished member of technical staff and senior member IEEE. Current research interests include 6G communication systems with focus on sustainable and secure networking. He did, he did his engineering in electronics and communication from Delhi College of Engineering and Masters in Nyaya and Varsika from Karnataka Sanskrit University. Also, in his earlier roles, he has been part of robotic system research at Nokia Bell Labs and contributing to wireless research and standardization in the mobile network C2 organization. We welcome Satish, and over to you.
Thanks a lot. Can I actually share my screen? Asif, maybe you
Yeah,
can help
please.
me with it.
Yeah, sure.
Okay.
Sure, sir.
Would you have to enable something so that a button shows up that allows me to share screen?
No. Can you see this third button, sir?
Yeah, yeah, I can see. Thank you.
Nearby the mic. Yeah.
Yes. Can you see my screen?
Yes, sir.
And can you hear me okay?
Yeah. Yeah, it's
Okay, all
perfectly
right.
fine, sir. Thank you.
All right, right. First of all, thanks a lot for this opportunity. I mean, when I was looking the topic of the session and also the distinguished experts with whom I am going to share the stage, I mean, it was quite overwhelming already. Professor Chaturvedi, Professor Chokalingam, and my friend Anshuman, who is an industry veteran, spoke very well on this topic. And I'm just contemplating, and what comes to my mind is what Mahatma Gandhi said, that you should speak only when so when you can improve upon silence. Given that very detailed technology discussion has happened, Anshuman has spoke about standards roadmap. I'm just thinking, what should I do with my talk now? But still, I will try uh, uh, to say something that would be worthy of your patience around 5 p.m. in the evening. So with that, maybe I'll get started and try to be brief so that we don't belabor your stay for long. Trying to focus on key messages. Uh, the theme today is about ubiquitous, intelligent, mobile, connected society. And then, since it is part of standards-driven research, I was just thinking what could be the message, or like an interesting perspective that we could share from an industry technology provider like Nokia to the audience. So there, I was thinking that we will have technologies that will be developed that will enable us to create this intelligent, mobile, connected society. But then, what would really be needed to enable that it is realized, and as my friend Anshuman said, in a way that it is widely available at scale and at a cost, so that common people have access to those societies rather than just being constrained to the research labs. So for that, I think technology ecosystem is very important to enable this connected society. And the key to successful realization of this technology ecosystem is that we actually get all these different technologies developed all over the world into one common place where the multiple stakeholders figure out a way how they can talk and do this collaboration with each other to provide this end-to-end solution. Because as you might have seen, I mean, all these technologies are very niche, and there is no one player that would be able to provide all the piece parts of the solution. So that's the theme of what I wanted to talk today, and that is why I think the work that is being done inside India by TSDSI to create an environment which encourages contribution towards standardization, and then by standardization enabling a multi-stakeholder ecosystem, is a very great one. And also NCC being a premier conference for India where bright minds come and share their research, is also a very key part where we are getting these technology components. And this conference, which actually blends these two, is a very ideal platform. All right. So much for the motivation. So I have just divided my talk into these parts. So why do we need this kind of ubiquity in connectivity and also availability of intelligence? So I'll talk about vision and purpose and how technology is evolving. What is the collaborative research ecosystem that exists today? And then talking about significance of standardization and the harmonization. So, what is the vision of the connected society? So, we see that the way the society will evolve in the future is the one where the world of humans and the world of machines, which we call as the physical world, and the digital world, where where in the network you have availability of all the data that has been collected about our universe, plus all the inferences that have been derived by the application of intelligent algorithms are present. So how this intelligence is available to both the machines and the humans? But why do you need that? We think this kind of fusion of digital, physical, and the world of the human is needed because we want to enable humans to do more beyond the constraints of being in the need to be at the physical place. Like the fact that I am able to share my thoughts by sitting in Bengaluru with you guys being stationed in Guwahati is itself an example of technology, and we want to take this even beyond. I mean, the kind of interaction that we are having today should be like improved multiple times as we get into the future. So that's one example. The other example is humans should be able to do more beyond their current level of information gathering as well as intelligence. So that is why access to the digital world is very important right at the time when they need it, plus also in a form. It should not be like an information overload, but in a form that will allow humans to actually execute the right tasks. Similarly, interacting with the physical machines to do things which are either dangerous for the humans to do on their own, or it is impossible in terms of mechanical or like strength constraints that are there with the humans. So that's what we think. The need to liberate human potential in the future is what will drive the need for a connected society. So there is a need for more intelligence, better control of the environment, better control of the environment via the machines, as well as newer experiences wherein we can overcome the need for being, physically present at a particular place, and also the kind of information that we can get from our environment beyond the limitation of our eyes, ears, and smell and touch, of course. Yeah. So how does this connected society manifest? So we see, so as I indicated, there are two major categories that we see where this connected society will manifest. So one is to drive augmentation of humans' abilities, so that we can get more from the environment beyond what our sense organs limitations are, so that we are able to see beyond what the ability of the eye, for example, by use of high resolution cameras, and then storing the data, inferring it in a way that our brain can process that. And then the other aspect is the fusion of physical industries with the digital technologies, because that is how we think we can actually increase our productivity in a sustainable way in the future, by adding more intelligence, by making the processes more efficient. So what would be the enablers? So today we are talking about handhelds, VR head-mounted devices, tethered AR glasses. But then going forward, we think what would be the kind of devices, and this was also hinted by Anshuman briefly, that the kind of devices will have to be completely reimagined. And the slide shows some example. Also, the needs of the industry would be to support complex enterprise-wide, industry-wide digital avatars that can actually interoperate with the physical world in a way that it is in sync with the physical world, by taking care of all the security that would be needed when we share information between the digital world and the real world, plus the kind of control that would be needed in terms of latency, security of the communication, etc. So we broadly divide again what we call as the metaverse, or this new digital world, in three main areas. One is the consumer metaverse, where we talk about humans experiencing interactions with each other. Say, for example, holographic communication that will enable me to feel as if I were physically located. Then we have more of this IT centric enterprise metaverse, and then finally, we have the industrial metaverse, where we are looking at digital avatars of the different components of the machines, plus their environment, having being instantiated in the digital world, so that you can run multiple what if scenarios and try to execute the task in the most efficient way. So for all this, network will be the key. So that's the thesis, as in like we will need these things in society. So then what is the role of the network? To ensure communication between the different entities, so that we realize these use cases. Of course, I don't need to preach to the choir. I mean, we all know that network will be the key to realizing these opportunities. But what kind of network will be needed? If you look at this slide, there are different services, and they have completely different kinds of requirements. So if you were looking at the way the communication technology has evolved, we had the 2G GSM, which talked about digital voice, then we had 3G, which started introducing broadband data. 4G delivered broadband data at scale, and then 5G delivered enhanced mobile broadband, plus catering to some of the industrial applications. But if you look at what is the need of the society in the future, you see that the kind of requirements from each of these services is completely different, and sometimes in fact competing with each other. So how do you enable such a communication infrastructure that can support all the different kinds of applications? This would require us to develop new network capabilities, which are in fact beyond just improving the amount of data that can be transmitted from a radio base station. It would require us to create more capabilities in the network. Say, for example, trying to provide information about what objects are present, so that the communication itself can be adapted according to it. So that brings in the aspect of sensing. So we already support positioning, provision of timing information from the network as part of 5G, 5G Advanced, but it has to go a level beyond, where we can do radar like communication and radar like sensing in the era of the future society. And then we talked about industry specific optimization. There would be different industries that would have different needs. So we need a network that is actually flexibly architected, that can adapt to the needs of the specific vertical. We have the seeds of that already sown in as part of 5G, which we call as network slicing, but that has to be taken to the next level. Then we talk about ubiquity and accessibility. My friend Anshuman talked about the need for different kinds of networking technologies, whether it is cellular, satellite. Everything has to work in such a way that we provide the desired communication at all places where the humans or the machines would need that. Then with all these features that are going to come in, it would be literally humanly impossible to actually figure out what would be the most optimal configuration, and that optimal configuration itself would change depending on the number of devices, the type of devices, the kind of applications that need to be supported. So therefore, there is a big stress on how we can leverage AI, so that we can allow these networks to autonomously configure themselves to the most efficient operating point. So what I wanted to essentially convey through this slide was the fact that there is research and activity that has to be done beyond just enhancing radio interface capabilities. Radio interface capabilities is of course a key enabler, but there is also work beyond that is very critical for us to support all these applications in the future. So now let's talk very briefly about technology evolution. I mean, it's not that these applications are completely new out of the blue. We see that some amount of XR is already supported as part of the different 5G releases, which is going to be improved as part of 5G Advanced. And then going forward, we will have technologies that are named as 6G that will potentially come around 2030, where some of these advanced use cases and applications can be supported. So let's briefly look at what are the capabilities today, and the way we see 5G Advanced enhancing those, taking us to the next level, being in some sense the bridge between 5G to 6G. So as you can see, maybe I'll take just one example. So we can support object-driven digital twinning. So we can model based on the sensory information from individual components, create the digital manifestation of those individual objects, and then try to infer what would be the most optimal operation, and also try to probably control at an object level. 5G Advance intends to take this to a larger scale, where we are able to have multiple objects which can interact in the digital world, and then be used to support uh, a little bit more sophisticated use case. For example, that of a vertical farm, where you need a drone flying around a vertical farm, trying to figure out what are the kind of plants, what are the kind of soil situation that is there, and then on the basis of that, provide information back to the network, and then also activate some of the actuators that would need to address the particular need. And then finally, in 6G, what we anticipate is that we will have to go one level higher, where we would have the needs to improve industrial productivity. I mean, this is all with a purpose. We need to have digital twins, whether they are the digital twins of the industries or even the digital twins of the networks themselves, be in sync with their physical cousins, if you may, in a way that they are able to exchange information in in the real time, so that you can make decisions in the digital world in the real time, and ensure the most optimal operation in the real world. We have talked in detail, even in the previous sessions, of the need for the network to go beyond just providing a communication channel. We're already talking about precise location timing services that complement GNSS coming as part of 5G Advanced, and there is a need to support information from the network to be provided to all the intelligent systems, and that also would be another key aspect that would be provided by the network beyond just communication, which is the ability to sense the surroundings. So then, to get to all these things, of course, we have to work on different technology pillars, and this is our view of what are the major technology areas. So we have to address the need for very high bandwidths. So that would require us to talk about operating at different spectrums. So it could be very high spectrum like sub-terahertz. So therefore, we need to figure out what would be the right waveforms there. And then we have to also, contend with very different kinds of devices which would have different capabilities. If it is a watch, the amount of power that it can support, or in terms of the number of antennas that it can support, with the devices coming from different types of vendors, would we be able to anticipate and assume that they would have a particular way of operation? So what I'm talking about is, say for example, uh, can we actually address the fact that there would be some kind of imperfections in the device themselves? So all these different variables take us to the fact that it will be very difficult to have a fixed kind of waveform that we could define for all the applications. So therefore, the need for artificial intelligence as a tool to be used to define what would be the kind of transmissions that you are receiving from a transmitter, identify that, and then you know uh, and then you will have to infer what would be the kind of reception chain that you will have to create so that the data is delivered. So that kind of AI based native air interface is what we are anticipating to be driving air interface technology in 6G. uh, so we talked about network as a sensor, and then one key thing that actually, I should have put as part of this slide, is the topic about sustainability. uh, all these different technologies are the features that would be needed to enable the use cases, but then given the kind of consumption of the different energy sources plus the impact of the consumption from the energy sources, none of these, I can assure you, will see the light if it leads to greater consumption of energy. So therefore, whatever we do has to be done in such a way that it consumes lesser and lesser energy. So let's take an example. We talk about AI based native air interface because that is very important tool for us in terms of sustainability. For example, in GSM, we had this very grand old frequency division multiplexing. Then we got CDMA to support, uh, to take advantage of this intercell interference so that we can actually turn that into our advantage. And then when we wanted to support higher data rates, we went to OFDM. So from each of these generations, energy consumption because of the kind of waveform, the kind of data rates that we need to support has actually increased. So now if we talk about 6G, what would be the kind of waveform will actually depend on the kind of application, whether it is high data rate application or whether it is low latency application, whether it is low data rate, but high reliability kind of application. So such different combinations of the applications will really need AI for us to choose the most energy efficient air interface. Uh, in the interest of time, I will again skip because each of these topics would require much more time and detailed treatment. Uh, so now let's go on to this aspect. So like we have seen in the current conference also, there are many great ideas that are being currently discussed across the world. So we have work that is happening as part of India. So in TSDSI, we have the roadmap activities. We have work related to to we have the work related to this 6G vision, that everybody from the industry and academia are contributing. Similar activities are like happening in Korea, Japan, China. Europe has been, working on this from, quite some time. It's like very mature project. And we know that, the first 6G flagship was actually, coming out of University of Oulu, Finland, where we can probably say that we also, co-founded that initiative. So all these different technology development is happening across the world. Okay. And each region or like no region can claim that it has got all the technologies that would be required to build the whole system. So therefore we have to use the collective intelligence of the world, if you may, to come together and then build a system that would take the best from each of these technology options, and then build a system that would enable us to deliver these services at scale, at a cost, and in a way that it is available to all the people who are going to be the consumers. So therefore what is very important is to actually understand that we are going to have a very different multi-stakeholder ecosystem, both in terms of users as well as technology providers. So some activity just going further, which I wanted to indicate in terms of global activities that are happening, is that we are already trying on a 5G millimeter wave system some of the concepts, like for example cell-free MIMO was talked by Professor Chaturvedi. We talked about massive MIMO. So all these things, what are the potential performance gains, what would be the limitations. So we are getting valuable information based on the POCs that we are doing currently. So the case of Arena 2036, where we are looking at where we are looking at effectiveness of the kind of localization and the different sensing technologies that we are trying to anticipate that will come in 6G, would work in a real industrial environment, which consists of these moving robots, moving vehicles. And then we're also working with operators, leveraging their experience in terms of delivering the services. So one example in this case is with Docomo. The work that we are doing in terms of uh, the initial prototype around this AI-based air interface. So a lot of work is happening. There are different stakeholders that are there. So as I said, some regions are ahead than others, but then ultimately everything has to come together if we have to really deliver the technology at scale. So then there are two components that I really wanted to stress in terms of the main theme that I really wanted to convey is the role of standardization, the role of ecosystem. So we all know that already the spectrum is a very crowded spectrum is a very uh, uh, crowded resource. So then people are talking about different bands because of purely from the perspective of different types of services that have to be delivered. We do need large bandwidths that are only possible at much higher frequencies. For example, sub-terahertz bands, the bands that are shown here. But then we also know that at those frequencies, coverage is a big issue. This is a big learning that we got from our experiments with millimeter wave and the different deployments that we have in 5G. That we also need to look at spectrum that will allow us deliver services at scale on a city-wide basis. So for such kind of services, say for example, XR services that would have to be delivered on a citywide basis, uh, uh, or if you want to, say for example, improve the number of improve the KPIs in terms of reducing the number of accidents for the vehicles moving on a road, terahertz might not be the best spectrum, for us to deliver such services. So therefore, it is also critically important for us to deliver the services at a citywide scale to consider a combination of both higher bands as well as whatever spectrum is available even at the bands where we think we can evolve technologies like, for example, MIMO, reflective intelligence services, and whatnot to support higher bandwidths that can deliver services on a larger coverage area scale. Okay. So then finally, Anshuman, thanks a lot for actually touching on this. This is indeed the right time. So you see, there are many initiatives that are actually happening all over the world where people, like we discussed here, are talking about component technologies, validating them. Okay, and then one important thing that we heard from that we heard from uh, that we heard from Professor Chokalingam is that when somebody asked about RIS, he actually stressed on the importance of actual effectiveness of the technology. So those kind of validations, this is the right time to do, because you know like all the areas, like all the different technology components will start to get discussed uh, in different global standards forums, whether it is IETF as it is appropriate, whether it is 3GPP for the part that relates to the cellular network. So this global standardization thing is expected to begin somewhere in the starting of the next year. So therefore there will be a lot of discussions as to what are the most promising use cases, what are the most useful services that we should support. Because if we try to get the whole gamut of things, I mean, the wish list, it is big, but then we also need to figure out what we can practically deliver by say around 2030, by the turn of the next decade, right? So those discussions are going to happen. This is the right time to talk about different technology components, what are the value, and then also try to collaborate globally across different bodies that are doing research. So for example, whether it is between India and EU, and also working with the different technology providers, like say for example from the industry, whether it is like Nokia, Samsung, or others. So this is the time when we have to get together, figure out what would be the component technologies, what are their potential performance benefits, and then finally get together to see how to build an end-to-end system based on these component technologies. That is why standardization is very important, and we have heard in many forums there is an ambition for many big and small players to be part of this journey. So that also makes standardization and the kind of ecosystem that it enables very important. Uh, if you don't have a way that I can understand what function my neighboring technology block will do, how I can interact with it, it will be difficult to build an end-to-end system that will allow me to deliver a service. Okay, and that is where standardization comes into picture. So therefore, while we focus on technologies, and through this forum which has the right focus, it is also very important to see how the different components interact with each other, what is the performance of the end-to-end system, and build a product that will then deliver end-to-end service rather than just focusing on the component piece parts. So with that, I would like to end today's talk by again telling that there is a purpose why we need these different applications, why we need the fusion of human, physical, and digital world, which is to liberate human potential, which is to make our lives easier in a way that is inclusive, where we overcome the barriers of technology, location, or anything, and in a way that it can be done sustainably. So with that, I would like to end my talk today and thank again the organizers for the opportunity. Namaste. So, so Vishnu, I am actually done. If you are still able to hear me, Asif.
Yeah, the seminar hall is on mute.
Okay. Yeah, sorry. So thank you very much, Satish, for a wonderful talk and to provide a comprehensive overview of 6G standardization activities and associated challenges. And again, thanks a lot for your patience. I understand that the talk questions, any online question or any offline question, please.
Online, there is none.
Okay. Audience, any questions? Okay, if there is no question, let's thanks the speaker again. Thank you,
Yeah,
Satish.
thanks a lot for your
Thanks
questions as
again.
well. If there are any questions, I mean, I'm also very happy to interact over email or otherwise. Thank you. Bye.
Okay, sure. Thanks. So now with this, I would like to hand over the stage to Mr. Vishnu from TSDSI to provide uh, overview of ITU and one M2M. Okay.
Thank you, sir. Kindly show the next slide, Chandrakanta. I would like to introduce Mr. Vishnu. Till the time this slide comes, Mr. Vishnu is our colleague. He is the technical consultant with TSDSI. He is an alumnus of IIT Delhi, has 23 years of hands-on experience in the field of telecom industry, developing and implementing standards, holds 13 international granted patents, published many papers, and was appointed as scientific advisor board associate member of Motorola Networks. He currently consults with ITUT as an independent consultant and is the chief editor of the recently published ITUT recommendations. We have been interacting with him, and he has been an asset to us as a TSDSI. Without any delay, I would request Vishnu sir to continue. Thank you.
Okay, as if whenever you're ready, huh?
Yeah, thank you, Sir Chandrakant. Yeah, thank you.
Cool. Yeah, thanks a lot. So, yeah, this is the last session. I will try to make it quick. This is overview of ITU, and Madanji is not here, Mr. Madan. So I will quickly cover his set of slides as well. Well, I was wondering what to put here, but then I realized that it may be better to just give you a brief overview about what are the opportunities which exist for ITU. Okay, so these are the pre-standardization activities that we do as part of ITU. There are several domain areas or focus areas, like there is, if you are working on health vertical, if you are working on autonomous driving, environmental efficiency, autonomous networks, natural disaster management. There is digital agriculture, and there is also one on data sets and IoT. So these are several activities which are pre-standardization activities, and these are several of them actually collect data sets, collect evaluation metrics, and activities with challenges, competitions, etc. So if you are a student looking for such opportunities as competitions, challenges, winning prizes, etc., or if you are a prof, or if you are in the industry who's into that, then these are the right places for it. And these are mostly free of cost, and we always provide opportunity from TSDSI to go and participate in such activities. Next slide, please. Okay, so WTSA is another opportunity. This is World Telecom Standards Assembly. This is almost the highest decision-making body in ITU, and that is held every 4 years. Last one was supposed to be held in 2020, but we got delayed due to COVID, and that was held in 2022. The way WTSA works is that in the form of resolutions. Resolutions means that you put up policy documents, semi-technical documents. Say, for example, how AI has to be used in the world, right? That's not exactly technical, but you can think of it as a semi-technical document. So these are resolutions. For example, gender balance. How to maintain gender balance in telecommunication standards. Standardization gap, these kind of things, and open source, use of open source. These are some of the things that are handled in the WTSA. Happy news is that India is going to host WTSA in 2024. The last one we held in Geneva, but now it is going to be held in India. That's a happy news for all of us, right? So that is going to happen. So please, if you are interested in attending, this may be an opportunity. If you are interested in working together to form a resolution, pushing some of your ideas into this is the opportunity. Next slide, please. ITU CXO meeting. So, for example, if you are a CTO, CEO, CEO of including startups, if you are such a company or something like that, or if you know somebody who are in this position, then there are opportunities to go and present in ITU what your company is doing, what is their position, and so on. Last one was held just a couple of months back in Dubai, and online. So if you don't want to travel, then that's possible. They discuss things like industry priorities, AI, ML, environment sustainability, and metaverse, and so on. So this is another opportunity where if you are a CEO or CXO or CTO or something like that, or if you want know somebody, then this is the place. Next slide, please. Collaboration of intelligent transport systems. So this is CITS is another forum. TSDSI is invited to present in the next month, March 2023. Last year, in fact, actually not last year, 6 months back, we had Mr. Hemant from CDAC represented us. In case you are working on any of the areas on connected vehicles, etc., this is a good opportunity to come and represent the TSDSI. Next slide, please. Okay, so AI for Good Machine Learning 5G Challenge is another opportunity where if you are a student, if you are a prof, if you are working on machine learning, etc., this is a good place. There are prizes to be won here. There are data sets and prizes and models which will be built over a period of a year. This is going to kick off in May, April-May timeframe, and it will go on till December. So December of this year. So during this period, we will give mentoring, webinars, etc., and we give out prizes at the end of in the mid of December. And the first prize, if I remember right, is 7,000 Swiss francs. So that's a considerable amount. In case you would like to compete building these models, please let me know. Next slide, please. Okay, so then I would like to look at a couple of technical slides. The first one among the lot is this one. That is where these models are going, where these AI ML models are going. You heard a lot of the speakers speak today, right? What are the, there is AI ML applied in most of the places, as you heard. So we have a model which we have been working on even from India side. This is what we have worked upon. On the right side, you see these are the machine learning pipelines that is as part of ITUT 3172, Y.3172. That's actually looking at application of machine learning in telecom network specifically. For example, if you have bugs in the network, or if you want to introduce a feature, so this is the pipeline that you use, 3172 based. On top of it, you have a knowledge base. I think I think Satish also talked about knowledge base. There is several speakers today talked about knowledge base, right? So that kind of knowledge base is built on top of these pipelines, and then comes the models which are in repositories. 3176 gives you a framework for having such model hubs, and there is 3181 that brings the sandbox for experimenting with AI models. So in general, if you come to the left side of this slide, you see this model hubs and local data and networks. This is how we look at in terms of application of models which are built in, for example, Hugging Face type repositories. Hugging Face is basically an open source repository where you can store your model, somebody else can download and apply, right? So that kind of model hubs and can be applied, trained using local data and applied on network. That's how we look at it in terms of how and where these models are becoming more and more open source. Next slide, please. In case you want GPUs, so GPUs are costly. In case you want GPUs, ITU provides state-of-the-art compute platform for GPU. It's free GPU access for students especially. We also, it comes with preloaded Jupyter and Python IDEs. So you just need to start up your IDE and notebook and you're ready to go. So that's what we do in terms of providing compute platform for our participants. Next slide, please. What are some of the focus areas in 2023? In case you would like to align your focus areas, we are looking at increasing the reach and the mentors. So this some kind of large scale integration of multiple AI/ML based use cases. So several you heard today, but maybe different verticals as I showed you in the beginning. Putting AI to work is another important area. Creating this sandbox which can experiment and test, that's another area. Reference model hubs and data set creation of data sets and models. These are some of the focus areas in 2023. So you will see several announcements coming from ITU in this particular regard, and TSDSI will reach out to you especially. Next slide, please. How to involve ITU activities from TSDSI? TSDSI is as a sector member of ITU. You have the opportunity to involve via TSDSI. So you just, all you need to do is that you need to write to us, create a TIES account, ITU TIES account. That is the access that you need to involve in such activities. And meeting registrations are handled by us via TSDSI. You can contact us. You see Kapoorji is here, Bishnoji is here. If anything fails, I'm here. So you can just contact me and we can work it out. Next slide, please. This is a successful example. TSDSI, ITU, IIT Delhi, India EU partnership project. Everybody got together last year in 2022 AI/ML challenge. We did a successful challenge. And the top 3 submissions from this challenge, actually they were from this the solution demo developed by a team in IIT Bhilai, by the way. I miss Razaji, but he basically was a mentor. Was ranked among the top 3 submissions in the world in this last challenge that we did. There were several submissions from across 6 countries in the world. The presentations which they did, actually, the team from IIT Bhilai, they were very well received, and the only one from India to reach the global stage. We also have IITU Journal, where we publish papers. You remember Professor Lal, Brajesh Lal, who talked in the morning. He's actually one of the authors who published in the IITU Journal. Next slide, please. Yeah, so there are several experts from India who are having leadership positions in ITUT. So, for example, this is the set of people who some may be familiar to you. So these are our set of leaders who have from India holding leadership positions in ITUT. If you are so you hear there are academics, yeah. So there are several academics and in the industry people also. In case you are an academic, you would like to take a leadership position in ITU, then we can make it happen. Please talk to us, and you can take a leadership position as a chair, vice chair, etc. in ITU. Next slide, please. All right, that's for ITU. I think could you for doing Mr. Madan slides, could you please bring it up, please? So yeah, while it is coming up, it is on 1M2M, so a slightly different topic. I will try to cover on behalf of Mr. Madan. All right. Yeah, so this is Madanji's slides on 1M2M. So it's a slightly different topic. Next slide, please. Okay, 1M2M partnership project. It is several member organizations are there, 200 member organizations, and you see these are the member organizations. TSDSI is one of them. Next slide, please. This is the organization structure, and I'm looking for familiar names. There is Professor Desai is here. So you see Professor Desai? Yeah. So he's here. And let me see if any other familiar names are there. No, I don't catch anybody. So yeah, so there is the organization, and we have people in the organization. Next slide, please. So yeah, so here also you see there are smart transportation, health, and metering, and these silos. There is a common service layer defined by 1M2M, and that is depicted on this side also. And there are several technologies such as LoRa, Wi-Fi, and 4G which are used here. Next, this common service layer is the focus area for 1M2M, as shown here. Next slide, please. Yeah, so what is 1M2M? So this is the service layer, application layer, network layer. I think you all know this structure from the layer-wise architecture, right? And this is a software middle layer. There's the first question that you need to ask, answer. It sits between applications and underlying communication networking, typically rides on top of IP protocol and so on. So if you write all these points, you get 10 marks. Next slide, please. Okay, so what are the functions of this application layer? So there is registration, discovery, security, etc. I'm not reading out, but you can see that this common service layer, as was shown in the previous slide, there is application layer, network layer, and the service layer, and all these functions are implemented in this common services layer. Next slide, please. Okay, so here is the architecture. You see the common service layer is here in this red boxes that you see here, and then there is application and network layer shown here. There is application entities which are shown on top, network service entities which are shown on below, and then there are application service nodes and middle nodes and infrastructure nodes. I believe these are devices and sensors actuators. This is edge gateways, and this is a cloud. So that's the 1M2M architecture. If you look at the 1M2M documents also, you might see similar picture. Next slide, please. These are release summary. I think Anshuman as well as Satish talked about the release of 3GPP. But here you see 1M2M feature summary by release. This is release 5 is planned. Release 4 features are here. Okay, this one is going beyond 2022. I believe this one is release 5 is what is planned. Next slide, please. Okay, this is a further detailed picture on the releases. I believe this one goes up to Q3 of 2024. Where are we now? We are somewhere here, Q1 of 2023. I believe this TP is going on now, and these are the stages which are going to happen. Next slide, please. Okay, so this is our scorecard. TSTS has 1M2M more than 400 contributions, and the CRs, transposition of releases. TSTSI vice chair is 1M2M committee in steering committee. CDOT and CDAC has 1M2M based interoperable platform. I believe these are important things. IIIT Hyderabad and UIET Chandigarh are centers of excellence for 1M2M. There is a smart living lab in the campus of IIIT Hyderabad as well. TSTSI hosted several meetings. Right, yeah. So release 2 and 3 are adopted in India as national standards. That's also important. Next slide, please. Thank you very much. That concludes our session. If in case you have questions, please ask us. And
There is one question online, sir.
What's that, Asif?
There is one question from Mr. Bhupender Kumar.
Yes, please.
Yeah, I have flashed that one.
Are the APIs open for MSC platform for to test some use cases? I believe we have some platforms. I think Professor Brijesh talked about it in the morning. I saw that he's a co-PI in this test bed also. My suggestion is to write to Professor Brijesh. I'm sure he'll help. In fact, personally, what I know is that he opened his lab for testing of solutions which were built as part of the build-a-thon challenge that I showed you. So the top solutions that were built using this ITU challenge, that those models, it was his complete lab was opened so that they can go there and test this in the models in their lab. So I believe yes, but you should check with Professor Brajesh. He is the co-PI for this testbed platform, and he showed the MEC architecture. Remember, in the morning, he showed that slide. So please write to him, and I'm sure he'll enable it. Thank you for that question. Okay, so with that, I believe um, we can close. Thank you. I would like to personally, on behalf of TSDSI, our partners, as well as IIT Guwahati, we would like to thank you for coming, and all the speakers for their time and energy, as well as the audience who were patiently sitting through all the talks, and especially you heard the summary already from Professor Chaturvedi. It was very insightful. The very inspiring talks that we had today, you can't get it anywhere else. In fact, I was wondering whether to come or to join remotely. Now I'm very glad that I'm here because we could actually meet him and speak to him also. Um, we would like to thank our chair, Arzaji, as well as the others who were organizing this entire event. There were innumerable number of calls to plan this particular thing. Some of you, some of you guys were part of that. I could not join many of those, but still I'm here. So yeah, so thank you very much. And lastly, and but not at all the least, I would like to thank Vaishali, Raktim, and Parvesh who are here. Please applause for them. They have been really running around. So thank you very much, guys, for taking the trouble. With that, we would like to close. Thank you very much. As if we are done.
Yeah, thank you so much. I'm closing the session now.